Hi, my name is Mosh and I'm going to be your instructor in this Python course. In this course, you're going to learn everything you need to get started programming in Python. Python is one of the most popular programming languages, and every day people use it to do cool things like automation. They use it in AI, as well as building applications and websites like Instagram and Dropbox. So if you're looking for a job, Python is for you. In this course, I'm going to teach you everything you need to get started with Python. We're going to talk about all the core concepts in Python, and then we're going to build 3 Python projects together. Here's the first project we're going to build. You're going to learn how to create this beautiful website for an imaginary grocery store. Here on the homepage, we can see all the products in the shop, and we also have an admin area for managing the stock. We're going to build this using a popular Python framework called Django. Now, if you have never built a website before, don't worry, I will teach you everything from scratch. You're also going to learn how to use Python in machine learning or artificial intelligence. So you will learn how to write a Python program that will predict the kind of music that people like based on their profile, just like how YouTube recommends videos based on the videos you have watched before. I'll also teach you how to use Python to automate boring, repetitive tasks that waste your time. You will write a Python program that will process thousands of spreadsheets in under a second. I've designed this Python course for anyone who wants to learn Python. If you're a beginner, don't worry. I will hold your hands through this entire course. You're not too old or too young, and Python is super easy to learn. You can write your first Python program in literally seconds. Plus, I'm going to give you plenty of exercises to help you build your confidence writing cool Python programs. My name is Mosh. I'm a software engineer with 2 decades of experience, and I've taught over 3 million people how to code. I'm super excited to be teaching you Python in this course, so I hope you'll stick around and learn this beautiful and powerful programming language. In this tutorial, I'm going to show you how to download and install Python on your computer. So the first thing I want you to do is open up your browser and head over to python.org. On this page, click on Downloads. Here you can see the latest version of Python. Currently, at the time of recording this video, the latest version is Python 3.7.2. Chances are in the future, when you're watching this tutorial, there is a newer version of Python available. Don't worry, all the materials you're going to learn in this course will apply to the latest version of Python as well. So let's go ahead and download Python 3. All right, now look at your downloads folder. Here we should have Python 3 installer. Simply double click that. If you're on Windows, you're going to see this checkbox here, Add Python to path. This is really important. Make sure to tick this box, otherwise you're not going to be able to follow this tutorial. If you're on a Mac, you're going to see an installer like this. With this setup wizard, we can install Python 3 on our computer. So simply click continue and again, agree with the license agreement and install it. This is going to take a few seconds, so I'm going to pause the recording. All right, we have successfully installed Python 3 on our computer. Let's close this. All right, next we need to install a code editor. We use a code editor to write our code. Just like how we use Microsoft Word to write documents, we use a code editor to write code. Now, there's so many code editors out there. The one that I'm going to show you in this tutorial is Pycharm. That is one of the most popular code editors for writing Python code. You can get it from jetbrains.com/Pycharm. Now, more accurately, Pycharm is considered an IDE, which is short for Integrated Development Environment. And that's basically a code editor on steroids. It has some additional features that makes it really easy to write code. So let's go ahead and download Pycharm. Now here on the download page, you can see 2 versions of Pycharm. One is the professional edition, which has additional features and you'll have to pay for them. The other is the community edition. That is absolutely free, and that's what we're going to use in this tutorial. So go ahead and download this as well. Now, once again, look at your downloads folder. Here you should have Pycharm. So double click this. Now, if you're on Windows, you're going to see an installation wizard. Simply click next until you install Pycharm. If you're on Mac, you need to drag and drop this icon onto the applications folder. So drag and drop. All right, now let's double click this to run it. The first time you run Pycharm, you're going to get this warning because this is an application that you download from the internet. So let's go ahead and open it. Next, you're going to see this dialog box for importing some settings. Leave this to do not import settings. It doesn't really matter. Okay. On this page, select I've never used Pycharm. You can see some keyword shortcuts that might be useful in the future. Just accept this, and down the bottom, click the next button. And then next again, and one more time, and finally start using Pycharm. So here's the main page of Pycharm that you're going to see every time you open it. Click on Create New Project. This is the location for our project. Let's call this project Hello World. Now, before clicking Create, expand this item here. Make sure that base interpreter is set to Python 3. Python interpreter is basically a program that knows how to execute Python code. It will interpret or translate Python instructions into instructions that a computer can understand. Now, Mac computers by default come with an older installation of Python, that is Python 2. It's considered legacy, which means it's no longer maintained or supported. So earlier we downloaded Python 3. Make sure that this is set to Python 3. If not, from this list, select Python 3.7. All right, now let's go ahead and create this project. Now here, right-click on Hello World folder and go to New Python file. Call this file app.py. So by convention, all Python files should have this py extension. All right, let's go ahead. Now let's collapse this project panel by clicking here and write our first Python program. Simply type print, print, all in lowercase, open and close parentheses, and inside this parentheses, add quotations. You can either use single quotes or double quotes. Now, in between the quotes, write your name. I am Mosh Hamedani, so let's write that here. So this is your first Python program. With this piece of code, you can print your name on the screen. Now to run this, go on the top, under the Run menu, click Run. Also note that there is a shortcut associated with this command. When I program, I always use shortcuts because that increases my productivity. So here on a Mac computer, the shortcut is Control, Option, and R. On Windows, it's different. So let's go ahead with that. Now it's asking where you want to run this. Click on App. Now down below, you should see this little terminal window. This is like a little window into our program. So here we can see the results or output of our program. In the future, as you learn more Python, you'll be able to build applications that have a graphical user interface or GUI. That is a little bit complicated. So for now, we're going to use this little terminal window to see the results of our program. So as you can see, my name is printed here. Now, as you write code, this window might get in the way. So you can always resize it or minimize it by clicking this icon here. So this was our first Python program. Now, if you didn't see the result I showed you in this video, use the comment box below and tell me what error you encountered. I'll do my best to help you move forward. In this Python tutorial, we're going to take this program to the next level. We're going to make it more interesting. So I'm going to show you how to draw a dog here. Now, as part of this tutorial, you will learn how Python code gets executed, and you will also learn about a few programming terms. So press enter, and on line 2, write another print statement. So print, open and close parentheses, add a quotation. Now here we want to draw a dog. So I don't know, that is the head of our dog, followed by 4 hyphens. 1, 2, 3, 4. So this is the body. All right. Now one more time, another print statement with quotations. Now we need to draw the legs. So add a space, followed by 4 vertical bars. So like this. So here's a little imaginary dog. Now let's run this program and see what we get. So on the top right corner, you should see this play button. Click that. There you go. So we have our name, and right below that, we have our imaginary dog. Now what you need to understand here is that our Python code gets executed line by line from the top. So earlier I told you about Python interpreter. That is the program that knows how to translate or interpret our Python code into instructions that a computer can understand. So when we run this program by clicking this icon here, Python interpreter starts executing or running our program line by line from the top. So first it executes line 1, then moves on to line 2, and so on. So this is how Python programs get executed. Now let me show you something cool. Let's add another print statement with quotations. Now, in between the quotations, add a star or an asterisk, like this. Now, after the quotation and before the parenthesis, add a space. Once again, add an asterisk, space, 10. What is going on here? Well, anywhere we have quotations, like here or here, we're defining a string. A string is a programming term, which means a series of characters. So here we have a string. We also have a string on line 3, as well as line 2 and line 1. Now here, we are multiplying this string by number 10. So this is the multiplication operator, just like the multiplication operator we have in math. So with this piece of code, we can draw 10 asterisks on the terminal. Let me show you. So let's run this program one more time. There you go. So we have 10 asterisks. Now what we have here, this piece of code here, is called an expression. An expression is a piece of code that produces a value. So when Python interpreter tries to execute line 4, first it will evaluate the code that we put in between parentheses. So it will evaluate our expression. Our expression will produce 10 asterisks, and then those asterisks will be printed on the terminal. Now, as an exercise, you can use these print statements to draw another shape. You can draw a heart, a ball, whatever you like. I will see you in the next tutorial. One of the questions I get a lot on my channel is, how long does it take to learn Python and become job ready? Well, there is no single answer. It really depends on you and how much effort and commitment you want to put into this. But I would say if you spend 2 hours every day consistently, after about 3 months, you should be able to write basic Python programs. But quite honestly, that doesn't get you a job. In order to get a job, you need to specialize in one area. What do you want to use Python for? Do you want to use it to build web applications or desktop applications? Or do you want to use it in machine learning and artificial intelligence? So whatever you want to do, you need to take additional courses. For example, if you want to become a web developer, in addition to learning Python, you should also learn about HTML, CSS, some JavaScript, and Django, which is a popular Python framework for building web applications. Learning all these things would take you another 6 months. So in total, you need 9 to 12 months to become job ready. At that point, you can get a junior developer job with a salary of about $50,000 to $60,000 a year. Now, as you work more, as you do more Python projects, your resume starts to build, and you can ask for $100,000 a year or $120,000 a year, depending on where you are, what company, what geographical area. It really depends. So there is no single answer. So are you excited to learn Python and get started on this career path? If you are, I would encourage you to make a commitment and spend 2 hours every day practicing Python. And use the comment box below and let me know why you're learning Python. What do you want to do with it? What's your dream job? I would love to hear your story. In this Python tutorial, you're going to learn about variables, which are one of the most fundamental concepts in programming. They're not specific to Python. They exist in pretty much every programming language out there. We use variables to temporarily store data in a computer's memory. Here's an example. Let's type price equals 10. When Python interpreter executes this code, it will allocate some memory, then it will store the number 10 in that memory, and finally it will attach this price label to that memory location. As a metaphor, imagine we have a box. In that box, we have number 10, and price is the label that we put on the box. Now we can use this label anywhere in our program to access the value that we have in that box. This is a very simplified explanation. So now let's print price on the terminal. Print. Now this time we're not going to add quotations, because if we put quotations here, we will see the text price on the terminal, not the value of the price variable. So delete quotations and type price. Now let's run this program one more time. There you go. So we see 10 on the terminal. So this is how we define variables. We start with an identifier, which is the name of our variable, then an equal sign, and finally a value. Now more accurately, when this number 10 is about to be stored in the memory, first it will get converted to its binary representation. So this number 10 that we have is in the decimal system, which has all the digits from 0 to 9. Computers don't understand all these digits. They only understand zeros and ones. So when we store the number 10 in the computer's memory, first it will get converted to to its binary representation, which would be a bunch of zeros and ones, like 001001, whatever, I don't know. Then it will get stored in the computer's memory. So let's take this program to the next level. On the second line, we can update the value of this price variable. So we can reset it to a new value like 20. Now, when we run our program, we should see 20 because, as I told you before, Python interpreter executes our code line by line from the top. So first we set price to 10, then we reset it to 20, and finally we print it on the terminal. Let's run the program. There you go. So we see 20 here. Okay. Now these numbers that we have here are whole numbers without a decimal point. In programming, we refer to these numbers as integers. So an integer is a number without a decimal point. We can also use numbers with a decimal point. For example, here on line 2, we can define another variable called rating, and we set it to 4.9. Now in programming, we refer to this kind of number as a floating point number, or float for short. So we have integers and floats. We can also define a variable and set it to a string. For example, name equals Mosh. We also have another kind of value, which is called Boolean, which can be true or false. They are like yes and no in English. Here's an example. I'm going to define a variable is underline published. So we use an underscore to separate multiple words in our variable's name. We set this to true or false. These are the Boolean values. Now, note that Python is a case-sensitive language, which means it's sensitive to lowercase and uppercase characters. So when defining variables, we should always use lowercase letters. But here, false and true are special keywords in the language. So if we spell it with a lowercase f, Python doesn't understand it. You can see we have a red underline here, which indicates an error. So make sure to spell this with a capital F, or if you want to set this to true, make sure T is capital. So in this program, we are storing simple values in our computer's memory. Simple values can be numbers, which can be integers or floats, or they can be strings or booleans. But in Python, we can also store complex values like lists and objects, and that's what I'm going to show you in the future. So before going any further, I want you to do a little exercise. Imagine we're going to write a program for a hospital. So we check in a patient named John Smith. He's 20 years old and is a new patient. I want you to define 3 variables here for his name, his age, and another variable to tell if this is a new or an existing patient. So pause the video and spend 1 minute on this exercise. When you're done, come back, continue, see my solution. All right, so here we need 3 variables. The first one is the patient's name. We set that to John Smith. We can also call this full name. These are both valid names for our variables. The second variable is for the age of our patient. So age is 20. And finally, we need a variable to tell if this is a new or an existing patient. That's where we can use a Boolean value. So we define a variable is new and we set it to true. So you have learned how to print messages on the terminal window. In this tutorial, I'm going to show you how to receive input from the user. So we're going to write a small program that asks the user's name, and then it will print a greeting message customized for that user. So instead of print, we're going to use input. Now, both this input and print are functions that are built into Python. As a metaphor, think of the remote control of your TV. On this remote control, we have a bunch of buttons. These are the functions built into your TV. You can turn it on, turn it off, change the volume, and so on. In Python, we also have a bunch of functions for common tasks, such as printing messages, receiving input, and so on. So we're going to use the input function. Now, whenever we have these parentheses, we say we're calling or executing that function. It's like pressing a button on a remote control. So we're going to call the input function, and in between parentheses, we want to add a string to print something on the terminal. What is your name? With a question mark followed by a space. You'll see why in a second. So this input function will print this message on the terminal, and then it will wait for the user to enter a value. Whatever the user enters, this input function will return. So now we can get that value and store it in the memory using a variable. So we get the result and put it in a variable called name. Okay? Now on the second line, we want to print a message like, hi John, or hi Mosh, whatever. So print, quotations, hi, with a space. Now after the quotation, we want to dynamically print what we have in the name variable. So we add a plus sign and then name. So here we have hi, which is a string. We're concatenating or combining this string with another string. That is what we have in the name variable. So here's another example of an expression. Remember what is an expression? It's a piece of code that produces a value. So this expression concatenates or combines two strings. Let's run this program and see what happens. So run. Okay, here's the question. What is your name? Mosh. Now note that earlier we added a space after the question mark. We did this so here in the terminal window, the cursor is separated from the question mark. Otherwise, it would be so close. So let's type whatever here, press enter. Now we get this message, hi Mosh. Now here's a little exercise for you. I want you to extend this program and ask two questions. First, ask the person's name and then their favorite color, and then print a message like Mosh likes blue. So pause the video, do this exercise, and then come back, continue watching. All right, so here's the first question. Right after that, we're going to call the input function one more time. This time, we're going to ask a different question. What is your favorite color? Now we get the new value and store it in a variable called color, or we could call it favorite underline color. Either works. And finally, we're going to change what we pass to the print function. So first we print the name, then we concatenate this with a string. Here we're going to type likes. We also put one space before and after likes. And once again, we concatenate this with the favorite color. So favorite color. Now let's run this program. So what is your name? Mosh, enter. Favorite color, blue, enter. We get this message, Mosh likes blue. Hey guys, Mosh here. I just wanted to let you know that you really don't have to memorize anything in this course because I've put together a cheat sheet with summary notes so you can quickly review the materials in this course. The link is below this video. So I have done my best to create the best possible Python course on YouTube. And I really appreciate it if you support my hard work by liking this video and sharing it with others so they can learn as well. And be sure to subscribe to my channel for more tutorials like this. All right, now let's move on to the next tutorial. In this Python tutorial, we're going to write a program that will ask the year we were born in, and then it will calculate our age and print it on the terminal. So let's start with our input function, input. Let's print birth year, followed by a colon and a space. Now let's get the return value and store it in a variable called birth underline year. So as I told you before, we use an underscore to separate multiple words. Next, we need to calculate the age. So we define another variable called age. And here we do some basic math. Currently, we are in 2019. So let's write an expression like this. 2019 minus birth year. Now, finally, let's print age on a terminal. Let's run our program and see what happens. So my birth year is 1982. Enter. Oops, we got an error. What is going on here? So whenever you see this red message, that means there is something wrong in your program. With the information here, we can find exactly where the error occurred. So next to the file, you can see the file that generated this error. In this case, that is app.py. So currently our program has only a single file, but real complex programs often have hundreds or even thousands of files. So in this file, on line 2, this is where we got this error. And right below that, you can see the piece of code that generated this error. So that is where we're calculating the age. And right below that, you can see the type of the error. In this case, we have a type error. And here's the message, unsupported operand types for subtraction, int and stir. So int is short for integer, and that represents a whole number. And stir is short for string. So here we're subtracting a string from an integer, and Python doesn't know what to do with it. Let me explain. So I'm going to close the terminal window. So after the first line is executed, we have this birth year variable set to a string. So whatever we type in the terminal is always treated as a string, even if we type a number. In other words, when we run this program, this birth year variable will be set to a string with 4 characters, 1982. This string is different from the actual number 1982. One is an integer, the other is a string, right? So back to line 2, where this error occurred. At runtime, which means when we run our program, this expression on the right side of the assignment operator is going to look like this. 2019 minus string 1982. Python doesn't know how to interpret or how to evaluate this expression. To fix this problem, we need to convert this 1982 into an integer, and then we'll be able to subtract it from 2019. And that is very easy. So far you have learned about 2 built-in functions. One is print, the other is input. We have a few more functions for converting values into different types. So we have int for converting a string into an integer. We also have float for converting a string into a float or a number with a decimal point. And we also have bool for converting a string into a Boolean value. So to fix this problem, we need to go back on line 2 and pass this birth year variable to the int function like this. Int parentheses like this. So we pass this string to the int function. Int will convert it to an integer, and then Python interpreter will be able to evaluate this expression. Now let's run this program one more time. So birth year is 1982, enter. So I am 37 years old. In Python, we have a useful function for getting the type of variables. For example, let's print the type of birth year. So right after line 1, let's print. Now here we're going to call another built-in function called type. And now let's pass birth year. Okay. Now similarly after line 3, let's also print the type of age. So print type of age. Okay. Let's run our program. So birth year, one more time, 1982. Okay. Here's the result. So the type of birth year, as you can see, is a class of str or string. We'll look at classes in the future. So for now, don't worry about them. And also below that, you can see that the type of the age variable is int or integer. So here's what you need to take away. Whenever you use the input function, you always get a string. So if you're expecting a numerical value, you should always convert that string into either an integer or a float. Now here's a little exercise for you. I want you to write a program, ask the user their weight, and then convert it to kilograms and print it on the terminal. So pause the video, do the exercise, and when you're ready, come back, continue watching. All right, so let's use our input function and ask for the weight in pounds. Here we get the weight in lbs or pounds. Now we need to convert this into kilogram. That is very easy. So we define another variable, weight underline kilogram or kg. We set this to weight underline lbs times 0.45. And finally, let's print weight underline kilogram. Let's run this Python program and see what happens. So my weight is 160. All right, once again, we got an error. Can't multiply sequence by non-int of type float. So as I told you before, this input function returns a string. So we cannot multiply a string by a float. Python doesn't know what to do with it. So in this case, we should convert this number to an integer or a float and then multiply it by 0.45. So let's call the int function and pass weight underline lbs and run our program one more time. 160. Okay, so I am 72 kilograms. In this tutorial, you're going to learn more about Python strings. So I've defined this course variable and set it to Python for beginners. Now, earlier I told you that you can use both single and double quotes to define a string. But there are times that you have to use a specific form, otherwise you're going to run into issues. Here's an example. Imagine we want to change this string into Python's course for beginners. So we want to add an apostrophe like this, Python's course for beginners. You can immediately see this is going crazy because our string starts here and then terminates here. All these characters that we have after the second apostrophe, Python interpreter doesn't know what they are. So to solve this problem, we need to use double quotes to define our string so we can have a single quote in the middle of the string. So let's change this to double quotes. Now you can see it adds another double quote to close it. We have to manually remove this. And also one more time at the beginning of the string, we need to add another double quote. Now you can see the error is gone. So if we print course, we see Python's course for beginners. Beautiful. Now let's say we don't want this apostrophe here. So we have Python for beginners, but we want to put beginners in double quotes. Once again, if you add a double quote here, Python interpreter gets confused because it assumes the second double quote indicates the end of our string, so it doesn't know what these characters are. So to solve this, we need to change our double quotes to single quotes like this, and then we can add double quotes in the middle of the string. Now let's run this program. There you go. So we get Python for beginners. So these are the cases for using single or double quotes. Now, in all the examples I've shown you so far, we only deal with short strings. But what if you want to define a string that is multiple lines? For example, what if you want to define a string for the message that we send in an email? In that case, we need to use triple quotes. So let me delete this. Now we add 3 quotes. So 1, 2, 3. There you go. So we have 3 quotes to start our string and 3 to terminate it. Again, these quotes can be single or double quotes, okay? Now with this, we can define a string that spans multiple lines. For example, we can say, hi, John. Here is our first email to you. Thank you, the support team, like that. Now, let's run this program and here's the result. So we get this beautiful multi-line string. Now let's change this back to something simple so we can look at other characteristics of strings in Python. So I'm going to use single quotes and set the course name to Python for beginners. Now here we can use square brackets to get a character at a given index in this string. Let me show you. So to get the first character, we use square brackets and type 0. So the index of the first character in this string is 0. In other words, this is how Python strings are indexed. 0, 1, 2, 3, 4, and so on. So the index of the first character is 0, the second character is 1, and so on. So let me delete this and run this program. We get P. We can also use a negative index here, and this is one of the features that we don't have in other programming languages, as far as I know. So with a negative index, we can get the characters starting from the end. So if I pass -1 here, assuming that 0 is the index of the first character, -1 is the index of the last character. So when we run this program, we should see S. Let's run it. There you go. We get S. If we pass -2, this will return the second character from the end. Let's run it one more time. Now we get R because that is the second character from the end. Okay. So pay close attention to this square bracket syntax because quite often it's the topic for online Python tests or university exams. So if you're preparing for a Python test, make sure to watch this tutorial one more time and understand exactly how this square bracket syntax works. We can also use a similar syntax to extract a few characters instead of just one character. For example, if we type 0:3, Python interpreter will return all the characters starting from this index all the way to this second index, but it does not return the character at this index. In other words, back to these indexes. So we have 0, 1, 2, 3, and so on. When we run this program, Python interpreter will return the characters starting from index 0 all the way to index 3, but excludes the character at index 3. So when we run this Python program, we're going to see Pyt. Let me show you. So I'm going to delete this line, run this program. There you go. We get Pyt. Now here we also have default values for the start and end index. So if we don't supply the end index, Python will return all the characters to the end of the string. Let's take a look. So run this program. There you go. We get Python for beginners. But if we change the start index to 1, this will exclude the first character. So when we run this program, we see YTHON. So P is removed. Okay. Now similarly, we have a default value for the start index. So if we don't supply the start index, but add an end index like 5, Python interpreter will assume 0 as the start index. So let's run this program. There you go. We get PYTHO. Now, what if we leave both the start and end index? Well, I told you that in this case, 0 will be assumed as the start index, and the length of the string will be assumed as the end index. So with this syntax, we can basically copy or clone a string. In other words, if I define another variable here, let's call it another, and set it to course square brackets with just a colon, now this expression will return all the characters in the course variable. So this second variable will be a copy of our first variable. Let's take a look. So let's print another and run our program. There you go. We get Python for beginners. So once again, the square bracket syntax is pretty important. If you're preparing for online Python tests or college exams, make sure to watch this tutorial again. Now here's a little exercise for you. I'm going to delete all this code, define a variable called name, and set it to Jennifer. Now when we print name of 1:-1, what do you think we're going to see on the terminal? I want you to use your knowledge to tell what we're going to see on the terminal without running this program. So pause the video, think about it for a few seconds, and then come back, continue watching. So this expression will return the characters starting from index 1, which is the second character, all the way to the first character from the end, but excluding the character at this index. In this case, the first character from the end is R, so R will be excluded. In other words, we're going to see all the characters starting from E all the way to the second E. Let's take a look. So I'm going to run this program. There you go. This is what we get. And I hope you guessed it right. In this tutorial, we're going to look at formatted strings in Python programming language. Formatted strings are particularly useful in situations where you want to dynamically generate some text with your variables. Let me show you. Let's say we have two variables, first name and last name. So first, we set this to John, and last, we set this to Smith. Now, it's better to call these variables first name and last name because they're more descriptive. But here I'm using shorter names because I want you to see the entire code on the screen. So let's say with these two variables, we want to generate some text like this. John, in square brackets, Smith is a coder. Let's say we want to print this on a terminal. How do we do this? Well, we define another variable like message. Now here we add the first name. Now we need to concatenate this with a string that contains a space and a square bracket. Next, we need to add the last name. Then we need to add a string that contains the closing square bracket followed by is a coder. Okay, so then if we print message and run this program, we see John Smith is a coder, right? Now, while this approach perfectly works, it's not ideal because as our text gets more complicated, it becomes harder to visualize the output. So someone else reading this code, they have to visualize all these string concatenations in their head. This is where we use formatted strings. They make it easier for us to visualize the output. So I'm going to define another variable, let's say MSG, short for message, and set this to a formatted string. A formatted string is one that is prefixed with an F. So F quotes. Now in between the quotes, first we want to add the value of the first name variable. So we add curly braces, and here we type first. Next, we add a space. We add our square brackets. In between the square brackets, we want to display the last name. So once again, we add curly braces and type last. And finally here we type is a coder. So this is what we call a formatted string. With these curly braces, we're defining placeholders or holes in our string. And when we run our program, these holes will be filled with the value of our variables. So here we have two placeholders or two holes in our string. One is for the value of our first name variable, and the other is for the value of the last name variable. Now compare this formatted string with string concatenation. With this formatted string, we can easily visualize what the output looks like, right? Now let's print this on the terminal to make sure we get the exact same output. So let's print message. There you go. So John Smith is a coder. So to define formatted strings, prefix your strings with an F and use curly braces to dynamically insert values into your strings. In this Python tutorial, I'm going to show you some really cool things you can do with Python strings. So let's start by defining a variable, course, and we set that to Python for beginners. Now to calculate the number of characters in this string, we can use a built-in function called len. So len, we give it this course variable, and then we can print the result. Let's run this program. So as you can see, we have 20 characters in this string. This is particularly useful when we receive input from the user. For example, you have noticed that when you fill out a form online, each input field quite often has a limit. For example, you might have 50 characters for your name. So using this len function, we can enforce a limit on the number of characters in an input field. If the user types in more characters than we allow them, we can display an error, okay? Now, this len function is another function built into Python. It's a general purpose function. So it's not limited to counting the number of characters in a string. In the future, when we look at lists, I'm going to show you that we can use this function to count the number of items in a list. So it's a general purpose function. Now, we also have functions specific to strings. For example, we have functions for converting all these characters to uppercase or lowercase. To access these functions, we use the dot operator. Let me show you. So first we type course, then dot. Look, these are all the functions that are specific to strings. Now, in more accurate terms, we refer to these functions as methods. This is a term in object-oriented programming that we'll look at in the future. But for now, what I want you to take away is that when a function belongs to something else or is specific to some kind of object, we refer to that function as a method. For example, here we have this function, upper, for converting the string into uppercase. Now, more accurately, because this function is specific to strings, we refer to this as a method. In contrast, len and print are general purpose functions. They don't belong to strings or numbers or other kinds of objects, okay? So this is the difference between functions and methods. Now, let's look at this upper method. So let's print the result and run our program. There you go. We get all these characters displayed in uppercase. Now, note that this method does not change or modify our original string. In fact, it creates a new string and returns it. So if we print our course variable right after we call the upper method, you can see that our course variable still has its original form. So let's run this program one more time. There you go. Look, this is our original course variable. It's not modified. Now, similar to the upper method, we have another method for converting a string into lowercase. So let me show you. Print course.lower. Now let's run the program. So on the second line, you can see all characters are in lowercase. Now there are times that you want to find a character or a sequence of character in a string. In those situations, you can use the find method. So let me delete these few lines. We call course.find. Here we pass a character, let's say P, and this will return the index of the first occurrence of that character. Let me show you. So let's print the result. We get 0 because the index of the first capital P in our string is 0. As another example, if we pass a lowercase o here, let's see what we get. We get 4 because the index of this o here is 4. Now, note that the find method is case sensitive, so it's sensitive to lowercase and uppercase characters. As an example, if we pass an uppercase o here and run this program, we get -1 because we don't have an uppercase o anywhere in the string. Okay? We can also pass a sequence of characters. For example, we can pass beginners with a capital B. Let's run this program. We get 11 because the word beginners starts at index 11. Now, we also have a method for replacing a character or a sequence of characters, and that is called replace. So let's change find to replace. Let's say we want to replace beginners with absolute beginners. So we add a comma to pass a second value to this function, or more accurately, this method. We add a string. Here I'm going to pass absolute beginners. Okay, now let's run this program. So we get Python for absolute beginners. Again, this method, like the find method, is case sensitive. So if we pass beginners all in lowercase, this method is not going to find this exact word in our string, so it's not going to replace it with absolute beginners. Let's take a look. So I'm going to run the program one more time. Look, we still get Python for beginners. We can also replace a single character. For example, we can replace capital P with, let's say, capital J. Now, when we run this program, we get Python for beginners. So these are the find and replace method. And one last thing I want to show you in this tutorial. There are times that you want to check the existence of a character or a sequence of characters in your string. In those situations, you use the in operator. So let's say we want to know if this string contains the word Python. We can write an expression like this. String Python space in space course. So we're checking to see if Python is in the course variable. Now, this is an expression that produces a Boolean value, like a true or false. So we refer to this expression as a Boolean expression. Now, if we print this on the terminal, we should get true. And by the way, let me delete the second line. We don't need it anymore. So run the program, we get true. But if I change this capital P to a lowercase p and run the program, we get false because we don't have this exact sequence of characters in our string. Now note that the difference between the in operator and the find method is that our find method returns the index of that character or sequence of characters. But the in operator produces a Boolean value. Do we have this or not? So that's the difference. Now let's quickly recap all the cool things you learned to do with strings in this tutorial. We can use the len function to count the number of characters in a string. This is a general purpose function built into Python. We also have specific functions for strings, which we refer to as methods. These include upper for converting a string into uppercase. We also have lower and title methods. You learn about the find method, which returns the index of a character or sequence of characters. We have the replace method for replacing characters and words in a string. And finally, you learn about the in operator. So some characters in a string. So you have learned that in Python programming language, we have two types of numbers. Integers, which are whole numbers like 10, they don't have a decimal point. And floating point numbers or floats, which are numbers with a decimal point. Now, in this tutorial, we're going to look at the arithmetic operations supported in Python language. These are the same arithmetic operations that we have in math. We can add numbers, multiply them, and so on. So let's look at a few examples. We can print 10 plus 3. So this is the addition operator. We also have subtraction. We have multiplication. We have two kinds of division. Here's one with a forward slash. Let's run this program and see what we get. We get a floating point number. But we also have another division operator for getting an integer. So if we add another slash here and run this program, we get an integer. We have another operator called modulus, which is a percent sign, and this returns the remainder of the division. So when we run this program, we should get 1. There you go. And one last operator we have here is exponent, which is the power. So that is indicated with 2 asterisks, and this will return 10 to the power of 3. So let's run this program, we get 1,000. So these are the arithmetic operators in Python programming language. Now for all these operators that you learned, we have an augmented assignment operator. That is very useful. Let me show you. So let's say we have a variable called x. We set it to 10. Now we want to increment this by 3. We'll have to write code like this. X, we set this to x plus 3. So Python interpreter will add 10 to 3. The result is 13, and then it gets stored into x again. So when we print x, we should see 13. There you go. So this is how we can increment a number, right? Now, augmented assignment operator is a way to write the same code, but in a shorter form. This is how it works. We type x plus equals 3. What we have on line 3 is exactly like what we have on line 2. So this is what we call the augmented assignment operator. We have augmented or enhanced the assignment operator. Now in this particular case, we are incrementing a number using the augmented assignment operator, but we can also subtract or multiply a number by a given value. For example, let's delete what we have on line 2. We can type subtract equal 3. So here we are subtracting 3 from x. When we run this program, we should see 7. There you go. Now let me ask you a question. I'm going to clear all this code here. Define x and set it to 10 plus 3 times 2. What do you think is the result of this expression? This is a very basic math question that unfortunately a lot of people fail to answer. The answer is 16. Because in math we have this concept called operator precedence, which means the order of operations. So the multiplication operator has a higher precedence, so it's applied first, which means 3 by 2 is executed first, the result is 6, and then it's added to 10. That is why x should be 16 after we run this code. Let's verify that. So print x, run the program, x is 16. So this is what we call operator precedence. It's just a basic math concept. It's not about Python programming language. So all the other programming languages behave the same way. So here's the order. First we have the exponentiation, which is the power, like 2 to the power of 3. Then we have multiplication or division. And finally we have addition or subtraction. This is the order of operations. Let me show you another example. Here I'm going to add the exponentiation operator. So 2 to the power of 2. Once again, what do you think is the result of this expression? Pause the video and think about it for a few seconds. The answer is 22. Because the exponentiation operator takes precedence, so first 2 to the power of 2 is executed, the result is 4. Then 4 is multiplied by 3, that is 12. And finally 12 is added to 10. So x should be 22. So let's run this program and verify this. So I'm going to delete these lines here, run the program. There you go. X is 22. Now let me bring back these rules here. We can also use parentheses to change the order of operations. So if we have parentheses, it always takes priority. In this case, we can add parentheses around 10 plus 3. So this piece of code will be executed first. The result is 13. Then the exponentiation operator will be executed. So 2 to the power of 2 is 4. And finally 4 is multiplied by 13. Now here's a little exercise for you. I'm going to set x to parentheses 2 plus 3 times 10 minus 3. What is the result of this? Pause the video and think about it for a few seconds. So you learn that parentheses always overrides the order. So this piece of code is executed first. The result is 5. Then between the multiplication and subtraction, you know that multiplication takes precedence. So next, 5 will be multiplied by 10. The result is 50. And finally, we have the subtraction. So 50 minus 3 will be 47. Let's verify this. Print X, run the program. There you go. I hope you guessed it right. So this is all about operator precedence. It's a very important topic, and I see it quite often in Python tests. So if you're preparing for a Python test, make sure to watch this tutorial one more time. In this tutorial, we're going to look at a few useful functions for working with numbers. Let's start by defining a variable like x and set it to 2.9. Now to round this number, we can use the built-in round function. So we call the round function, give it x, and then print the result. Let's run this program. So we get 3. We have another useful built-in function called ABS, which is short for absolute. And this is the absolute function that we have in math. We give it a value and it always returns the positive representation of that value, even if that value is negative. Here's an example. Let's call the ABS function and give it negative 2.9. When we run this program, we're going to see 2.9 on the terminal. So let's go ahead. There you go. So absolute always returns a positive number. Now, technically in Python, we have a handful of built-in functions for performing mathematical operations. If you want to write a program that involves complex mathematical calculations, you need to import the math module. A module in Python is a separate file with some reusable code. We use these modules to organize our code into different files. As a metaphor, think of a supermarket. When you go to a supermarket, you see different sections for fruits and vegetables, cleaning products, junk food, and so on. Each section in a supermarket is like a module in Python. So in Python, we have this math module, which contains a bunch of reusable functions for performing mathematical calculations. So let me show you how to use this module. On the top, we type import math, all in lowercase. With this, we can import the math module. Now math is an object like a string, so we can access its functions, or more accurately, its methods, using the dot operator. So if we type math dot, look, these are all the mathematical functions available in this module. For example, we can call the ceil method to get the ceiling of a number. So if we pass 2.9 here and then print the result, we should see 3. Let me delete all this other code here. All right, let's run this program. There you go. So we get 3. Another useful method is the floor method. So let's give that a try. Floor of 2.9. What do you think we're going to get? We get 2. Now, there's so many functions built in this module, and we don't really have time to go through all of them. But let me show you how you can learn about them on your own. Open up your browser and search for Python 3 Math Module. Make sure to add the version, Python 3, because the Math module in Python 2 is slightly different from the Math module in Python 3. So, Python 3 Math Module. Now here, you can see the documentation for this module. Let's go. Let's have a look. If you scroll down, you can see the list of all the functions and their explanation. So as an exercise, I encourage you to spend 5 minutes, have a quick look at this documentation, see what functions are there for you in case you need them. In this tutorial, I'm going to talk to you guys about if statements in Python. If statements are extremely important in programming, and they allow us to build programs that can make decisions based on some conditions. So if some condition is true, we're going to do certain things. Otherwise, we're going to do other things. Here's an example. Over here, I've got this text file with a bunch of rules for our program. If it's a hot day, perhaps we want to tell the user it's a hot day, so make sure to drink plenty of water. Otherwise, if it's cold, so here's another condition. If this condition is true, we're going to tell the user it's a cold day, so wear warm clothes. And otherwise, if it's neither hot or cold, we want to tell the user it's a lovely day. So let me show you how to write a program that simulates these rules. So back to our program here, we start by defining a Boolean variable is underline hot. We set this to true. Next, we add an if statement. So if, here we need to add a condition. In this case, we're going to use our Boolean variable. So is underline hot. Now, if this if value is to true, then we're going to do certain things. In this case, we want to tell the user, hey, it's a hot day, drink plenty of water. So back to our program. After our condition, we add a colon. Now, note that when I press enter, Pycharm automatically indents our cursor. Now, any code that we write here will be executed if this condition is true. Otherwise, it will be ignored. Here's an example. Let's write a print statement. Here I'm going to use double quotes because I want to use an apostrophe in our string. So it's a hot day. Now let's press enter. You can see the cursor is still indented. That means we can write more code that will be executed if this condition is true. In this case, let's say we don't want to write any extra code. So to terminate this block, we need to press Shift and Tab. Now the cursor is at the beginning of the line. So let's write a print statement with a message like, enjoy your day. Now, when we run this program, because this condition is true, we're going to see this message followed by this second message. Take a look. So run. There you go. It's a hot day. Enjoy your day. But if I go over here and change this Boolean value to false and run the program again, our first message disappears and we only see the second message. Enjoy your day. So this is how if statements work. Now back here, we can add another print statement. Let's say, drink plenty of water. Now, because this print statement is also indented, it will be executed if this condition is true. So I'm going to revert is hot to true and run the program one more time. There you go. So it's a hot day, drink plenty of water, and enjoy your day. All right, now let's add a second rule here. If it's hot, we're going to execute these two lines. Otherwise, if it's not hot, we want to print a different message. So here, we remove the indentation and type else colon. Now, when we press enter, once again, our cursor is indented. So the code that we write here will be executed if this condition is not true. So here we can print, it's a cold day, print, wear warm clothes. Now let's run our program one more time. So we get the messages about a hot day followed by enjoy your day. We don't see any messages about a cold day. Now, if we go back here on the top and change this Boolean value to false and run our program, we see different set of messages. It's a cold day, wear warm clothes, and enjoy your day. But there's a problem with our program. If it's not hot, it doesn't necessarily mean that it's cold. Maybe it's a lovely day. So the absence of heat doesn't mean it's cold. Back to our conditions. Here on line 4, we have this rule that says, if it's a cold day, then print these messages. Otherwise, if it's neither hot or cold, then say it's a lovely day. So to implement this rule, we need to go back to app.py and define another variable. So let's say is underline cold. We set this to true. Now here we need to add a second condition. So after our first if statement, we can use an elif statement to define a second condition. Here's how it works. So elif, which is short for else if or otherwise if. Now here we add another condition. So is cold. So if it's cold, we want to execute these two lines. So let's cut these from here and move them under our second condition. And finally, if none of these conditions are true, you want to print a different message. It's a lovely day. So right now, is hot is false, is cold is true. So when we run this program, Python interpreter is going to execute the first if statement. In this case, because our condition is false, these two lines will be ignored. Then Python interpreter will look at line 7. It will evaluate this condition. In this case, is cold is true. So we're going to see these two messages on the terminal. Now, in this case, because one of these conditions was true, this else statement will be ignored. So we are not going to see this message. And finally, as before, we're always going to see this message. So let's run our program. There you go. It's a cold day, wear warm clothes, and enjoy your day. Now, back to the top, if we change is cold to false, it's neither hot nor cold, so it's going to be a lovely day. Let's run the program, and here you go. It's a lovely day. Enjoy your day. So this is the basic of using if statements. As you can see, they're very useful in programming. And with these, we can build all kinds of rules into our programs. Okay, here's an exercise for you. Imagine the price of a house is $1 million. Now, if the buyer has good credit, they need to put down 10% of the price of this property. Otherwise, they need to put down 20%. Write a program with these rules and display the down payment required for a buyer with good credit. You will see my solution next. All right, let's define a variable for the price of this house. So price, we set this to 1 million. So 1 with 6 zeros. Next, we need a variable to tell if this buyer has good credit. So has good credit. And we set this to true. Now we need an if statement. So if has good credit is true, colon. Here we need to calculate the down payment. So down underline payment should be equal to 0.1 times the price. That is 10% of the price of this property. Otherwise, colon, the down payment should be 0.2 times price. Now finally, we remove the indentation and print. Here we can use a formatted string. First, we add a label, down payment, colon, and right after that, we add a placeholder or a hole for our down payment variable. So curly braces, down payment. Let's run this program. So down payment for a buyer with good credit is $100,000. Now let's improve this by adding a $sign before this number. So back to our formatted string, just before the curly brace, I'm going to add a $sign. Let's run this one more time. That is better. In this tutorial, I'm going to talk to you guys about the logical operators in Python. We use these operators in situations where we have multiple conditions. Here's an example. Let's say we're building an application for processing loans. If an applicant has high income and good credit, then they're eligible for loan. So in this example, we have two conditions. One is having high income and the other is having good credit. So if both these conditions are true, then the applicant is eligible for loan. So this is where we use the logical AND operator. We use this operator to combine two conditions. And by the way, this is not specific to Python programming language. Pretty much any programming language that supports if statements also supports the logical operators. So back to our program, let's define two variables. Has high income, we set this to true. And another one has good credit. We also set this to true. Now our if statement. If has high income is true and has good credit is also true, then we're going to print eligible for loan. So this is where we're using the AND operator. So if both these conditions are true, then this message will be printed. If one of them is false, we're not going to see this message. Let's try this out. So I'm going to run this program. So we see eligible for loan. But if we change either of these conditions to false and run the program again, look, the message disappeared. So this is the logical AND operator. We also have the logical OR, and we use that in situations where we want to do certain things if at least one of the conditions is true. For example, let's change the rule for this program such that if the applicant has high income or good credit, then they're eligible for loan. So if either or both these conditions are true, then the applicant is eligible. Now, back to our program, we can implement this rule by using the logical OR operator. So we simply replace AND with OR. Now, when we run this program, we're going to see this message because at least one of our conditions is true. Let's take a look. So the applicant is eligible for loan because they have good credit. If we change this to false, but set the other condition to true and run the program, we still see the same result. But if both these conditions are false, then we're not going to see this message anymore. So this is the difference between these operators. With the logical AND operator, both conditions should be true. With the logical OR operator, at least one condition should be true. We also have another logical operator called not, and that basically inverses any Boolean value we give it. If we give it a true Boolean value, it converts it to false. For example, let's make up a new rule. If applicant has good credit and doesn't have a criminal record, then they're eligible for a loan. Let me show you how to implement this. So we go back to our program. In this example, we don't need the first variable, so let's delete that. Let's set this variable to true. We also define another variable like has criminal record. And we set this to false. Now we want to check to see if this applicant has good credit and not a criminal record. This is where we use the not operator. So if they have good credit and not criminal record. So in this example, has criminal record is set to false. When we use the not operator, this basically gets changed to true. So we'll have two conditions that are true. Here's one and here's another one. So our applicant is eligible for loan. And when we run this program, we see this familiar message. However, if an applicant has criminal record, so let's change this to true. Now, when we run this program, we can see our applicant is not eligible because when we apply the not operator on this variable, we'll get false. So true changes to false. And we'll end up with two conditions. One is true and the other is false. So the result is false. And that's why this message is not printed. So this is all about the logical operators in Python. In this tutorial, I'm going to talk to you guys about the comparison operators in Python. We use comparison operators in situations where we want to compare a variable with a value. For example, if temperature is greater than 30, then we want to print it's a hot day. Otherwise, if it's less than 10, it's a cold day. Otherwise, it's neither hot nor cold. And by the way, here I'm talking about Celsius, not Fahrenheit. So to build these rules into our program, we need to use comparison operators. Back to app.py. I'll define this temperature variable. Let's write an if statement. If temperature, now we want to check to see if this is greater than 30. So we use the greater than operator. If this is greater than 30, we want to print it's a hot day. Otherwise, let's just print it's not a hot day. Now, when we run this program, we're going to see the second message because 30 is not greater than 30. So our first condition evaluates to false. Let's verify that. So run, it's not a hot day. Okay. Now, if we change the temperature to 35 and run this again, we're going to see a different message. It's a hot day. So this is where we use comparison operators. Now, what we have here, as you know, is an expression because it's a piece of code that produces a value. So more accurately, this is a Boolean expression. So this is the greater than operator. We also have greater than or equal to. We have less than or equal to. Here's the equality operator. So if the temperature equals to 30, then we can say it's a hot day. Note that this is different from the assignment operator that has only one equal sign. You can see if we use one equal sign here, we immediately get this red underline because this is simply an assignment statement. We're changing the value of the temperature. We're setting the value of the temperature variable to 30. We are not comparing it with something else. So we don't have a Boolean expression. We are not producing a Boolean value. Okay? So our equality operator has two equal signs. And finally, we have not equal, which is an exclamation followed by an equal sign. Now here's an exercise for you. You've probably seen that when you fill out a form online, sometimes the input fields have validation messages. For example, let's say we have an input field for the user to enter their name. Now, if the name is less than 3 characters long, we want to display a validation error like name must be at least 3 characters. Otherwise, if the name is more than 50 characters long, then we want to display a different validation error like name can be a maximum of 50 characters. Otherwise, if the name is between 3 and 50 characters, then we just want to tell the user that name looks good. So go ahead and write a program to implement these rules. All right, let's define a variable called name and set it to, let's say, J. So we're assuming this is what the user types into an input field. Now we want to get the number of characters in this string. So we use the len function, right? Len of name. When we print this, we get 1, right? You have seen this before. Now here we want to use an if statement. So if len of name is less than 3, then we want to print name must be at least 3 characters. Now here we need a second condition to check the upper limit. So L if len of name is greater than 50, then we want to print a different message. Name must be a maximum of 50 characters. Okay, and otherwise, so else, if none of these conditions is true, that means the name looks good. So print name looks good. Let's run our program. So in this case, we get this message because our name is too short. Now, if you go back here and type something really, really long, and then run our program, we're going to see a different message. Name must be a maximum of 50 characters. And finally, if we type a proper name here, like John Smith, and run our program, we get name looks good. Here's another good exercise that combines many of the materials you have learned so far. So earlier you built a program to convert someone's weight from pounds to kilograms. Now we want to extend this program and allow the user to enter their weight in either kilograms or pounds, and then we'll convert it to the other unit. Here's how our program is going to work. So I enter my weight in pounds, so 160. Now it's telling me, is this in pounds or kilograms? So here I need to enter L for pounds or K for kilograms. And by the way, this program is not case sensitive. So whether I enter a capital L or a lowercase l, it takes it as pounds. Now it tells me you are 72 kilos. Let's run this program one more time. This time I'm going to enter my weight in kilos. So 72 is the weight and the unit is kilograms, so K. And it says you are 160 pounds. So go ahead and spend a few minutes on this exercise. You will see my solution next. All right, first, let's ask the user their weight. So we use the input function, weight colon. We get the return value and store it in a variable called weight. Now the second question. So one more time, we use the input function, L for pounds, LPS, or K for kilograms. So let's get that too and store it in a variable called unit. Now we need an if statement. So if unit equals L, then we need to convert this weight into kilograms. However, with this implementation, we are only allowing the user to enter a capital L. If they enter a lowercase l, this code is not going to work. So this is where we use the upper method of string objects. So this unit is a string because, as I told you before, the input function always returns a string. So we can use the dot operator to access all its methods or functions. Here we call the upper method. This will convert whatever the user enters to uppercase, and then we'll compare it with a capital L. Now, if this condition is true, then we need to get the weight and multiply it by 0.45. However, as you know, this weight is a string object, and we cannot multiply a string by a floating point number. We talked about this earlier in this course. So first, we need to convert this weight to a numerical value. So right here, when we call the input function, we can get the return value and pass it to the int function. So we call the int function and give it the return value of the input function. Now, the int function will return an integer, so we can store it in this weight variable. So here's the converted weight. Let's store it in a variable called converted. Then we print. Here we can use a formatted string. So we prefix the string with F. We we add curly braces to dynamically insert the value of converted variable. And finally, we add kilos. Otherwise, if the unit is kilogram, we need to divide the weight by 0.45. So once again, we type converted equals to weight divided by 0.45. And just to refresh our memory, this division operator returns a floating point number, but if we use double slashes, we'll get an integer. In this case, I want to get a floating point number. So finally, let's print a formatted string. You are, curly braces, converted pounds. Okay. Now let's run this program and see what happens. So weight is 160 in pounds, and that equals to 72 kilos. Perfect. If we run it one more time and enter 72 kilos, we get 160 pounds. In this tutorial, I'm going to show you how to use while loops in Python. We use while loops to execute a block of code multiple times, and they're often useful in building interactive programs and games. In a future tutorial, I'm going to show you how to build a simple game using a while loop. So let's get started with the basics. We write a while statement, and right after that, we type a condition followed by a colon. As long as this condition is true, the code that we write in this block will be repeatedly executed. Here's an example. We can define a variable like I, as in short for index, and set it to 1. Now, we set our condition to I less than or equal to 5. So as long as I is less than or equal to 5, we can print I on the terminal. And then we need to increment I by 1. So we set I to I plus 1. The reason we do this is that if we don't do this, I will be 1 forever. So we'll end up with an infinite loop because this condition will always be true. 1 is always less than 5. So in every iteration of this loop, we increment I by 1. So at some point, I is going to be 6. And then that is when this condition will be false. And then we'll jump out of this loop. Okay. Now to demonstrate how everything works, after this loop, I'm going to add a print statement, say done. So note that these two lines are indented, so they're part of the while block. Okay. Now let's go ahead and run this program to see what happens. So take a look. We get the numbers 1 to 5 followed by done. So here's how this program gets executed. First, we set I to 1. Now Python interpreter executes line 2. This condition is true because I is less than 5. So I is printed on the terminal and then incremented by 1. Then the control moves back to the beginning of the while loop. So it doesn't go to the next statement. So we come back here. Now we are in the second iteration. In the second iteration, I is 2. And because 2 is less than 5, our condition is still true. So I will be printed on the terminal. And once again, it will be incremented by 1. So at some point, I is going to be 6. And that's when this condition will be false. So our loop will be terminated. And then this done message will be printed on the terminal. So this is the basics of while loops. Now let's make this program a little bit more interesting. Here we can write an expression like this. We add a string, and in this string we add an asterisk. And then we multiply this string by I. So with this expression, we can repeat a string. When we multiply a string by a number, that string will be repeated. For example, if I is 2, this expression will produce a string with 2 asterisks. Okay, now let's run the program and see what we get. So we get this little triangle shape here because in the first iteration, I is 1. So 1 times an asterisk produces 1 asterisk. In the second iteration, I is 2. So when we multiply 2 by 1 asterisk, we'll get 2 asterisks. In this tutorial, I'm going to show you how to use a while loop to build a guessing game like this. So we have this secret number, which is currently set to 9. Now the computer is asking me to make a guess. So let's say 1. It's not right because the secret number is 9. I can try again. 2. No, it's not right. Let's try again. So I only have 3 chances to make a guess. If I can't guess the number, the program tells me that I failed. Let's run the program one more time. This time I'm going to guess the number. So it's 9. There you go. It says you win. So let's go ahead and build this program using a while loop. All right, let's start by defining a variable to store our secret number. So we call that secret underline number and set it to 9. Now we need a while loop to repeatedly ask a user to make a guess. So while condition colon. What is our condition here? Well, we want to give our user a maximum of 3 guesses. So similar to the last tutorial, we can define a variable like I, set it to 0, and assume this represents the number of guesses the user has made. And then we can write our condition as I less than 3. Note that here I'm not using less than or equal to operator because with this condition, our loop will be executed 4 times, while I is 0, 1, 2, and 3. So here we should use the less than operator. Now, if we give this code to someone else, it's not quite clear what does I represent here. It's only in our head that I represents the number of guesses the user has made. So as a best practice, always use meaningful and descriptive names for your variables. So it's better to rename this variable to guess count. Let me show you how to rename. So right click on I variable and then go to refactor and rename. Look at the shortcut. On a Mac computer, that's Shift and F6. Now in this dialog box, we can easily rename a variable and Pycharm will update all the references to that variable. So we don't have to manually update each instance, okay? Let's change this to guess underline count. Enter. There you go. Now that is better. Also, it's better to store 3 in a separate variable to make our code more readable because it's not quite clear what does 3 represent here. So let's define a variable called guess limit and set it to 3. And then we can change 3 to guess underline limit. Now our code is more readable. While guess count is less than guess limit, see, it reads like a story. This is how you should write code. All right. So while this condition is true, we want to ask the user to make a guess. So here we use our input function, guess. Now, whatever the user enters comes out as a string, so we need to convert it to an integer. So right here, we pass the result to the int function and then get it and store it in a separate variable called guess. So at this point, the user made a guess. Now we need to increment guess count. So guess count, we set it to plus equal 1. Okay. Now we need to check to see if the user made the right guess. So here we need an if statement. If what the user guessed equals our secret number. Again, see, our code is so readable. It's like a story. You can read it like plain English. So if this condition is true, we want to tell the user they won. So print you won. Now let's go ahead and run our program up to this point. So, okay, it's asking me to make a guess. I'm going to make the wrong guess. So 1, it asks me again, beautiful. 2, one more time, 3. Okay, what is missing in this implementation is the message that tells me that I failed. We're going to take care of it momentarily. But let's run the program one more time and make the right guess. So 9, okay, it says you won, but it's still asking me to make a guess because our while loop is going to get executed 3 times. Look, 1 and 2. So we need to change our program such that if the user makes the right guess, we need to terminate our while loop. We need to jump out of it. How do we do that? So over here, if the user makes the right guess, after we print this message, we can use the break statement to terminate a loop. When Python interpreter sees this, it's going to immediately terminate our loop. It's not going to evaluate this condition again. Now let's run our program and see what happens. So I'm going to guess the right number. You won, and look, we were not asked to make 2 more guesses. Beautiful. Now the last thing that we need to add here is the message that tells the user that they failed if they couldn't guess the right number. How do we do that? Well, in Python, our while loops can optionally have an else part, similar to the if statements. So earlier you learned that our if statements can optionally have an else part, like here. So if this condition is true, do this, otherwise do something else, right? In this case, our if statement doesn't have an else part. Now, Similar to the if statements, our while loops, our while statements can also have an else part. So right at this level, we can add an else block, so else colon, and the code that we write here will get executed if this while loop completes successfully without an immediate break. In other words, if the user guesses the right number, we break this loop, we jump out of it, so the code that we write in the else block will not get executed. But if the user cannot guess this number, we're never going to break out of this loop, so this loop will be executed to completion until this condition becomes false. In that case, the code that we write in the else block will get executed. And this is the perfect opportunity for us to tell the user, hey, you made 3 guesses, but none of them were right. So print, sorry, you failed. Now let's test our program one more time. So guess 1, 2, 3. Sorry, you failed. Let's run it one more time. This time I'm going to make a wrong guess and then the right guess. We won and our loop terminated immediately. All right, now it's time for you to practice what you have learned so far. So once again, we're going to build a game. This game is a simulation for a car game. Now, our game doesn't have a graphical user interface or GUI, and it doesn't really matter for now. Our focus is entirely on building the engine for this game. So let's see how this program works. When we run this, we get this little symbol here, and our program is waiting for us to enter a command. If we type help, either in lowercase or uppercase, it doesn't matter. We get the list of commands that our program or our game currently supports. So we can type the start command to start our car. We can type the stop command to stop our car and quit to terminate the game. Any other commands that we type, our program is going to tell us, hey, I don't understand that. For example, if I type ASD here, it says, I don't understand that. If we type start, we get this message, car started, ready to go. If we type stop, it says car stopped. And finally, if we type quit, our program terminates. This is a fantastic exercise for you to practice what you have learned. So pause the video and spend 5 to 10 minutes to build this program. All right, we're going to start with a while loop with a condition. What is our condition here? We want to run this loop until the user types quit. So we can define a variable for storing the command that the user enters, and then we can run this loop as long as the command does not equal to quit. So right before the loop, we define a variable command, and initially we set it to an empty string. An empty string is a string that has no characters in it. We only have the quotes, okay? So then we type out our condition as while command does not equal to quit, then do something. Now, immediately we have a problem here because we're assuming that the user types the command in lowercase. So if they type this in uppercase, our program is not going to behave properly. So to fix this problem, we need to call the lower method of the string object and then compare the result with this quit. We could also call upper and then type quit in uppercase. It's a matter of personal preference. In this demo, I'm going to use lowercase characters. So, okay. Now in this loop, we need to ask the user to enter a command. So once again, we're going to use our input function. We add a greater than symbol followed by a space. Whatever the user enters, we get it and store it in our command variable. Now, apart from the quit command, there are 3 other commands that we need to support: start, stop, and help. So here we need an if statement to compare what the user enters with one of the supported commands. So if command.lower equals start, then we want to print a message like the car started. So print car started, ready to go. It doesn't matter. Now the second condition. What if it's not start? Maybe it's stop. So elif command.lower equals stop. There you go. Then we print a different message, car stopped. Now look at our code. We have repeated this lower multiple times. This is bad. In programming, we have a term called dry, which is short for don't repeat yourself. So whenever you have duplicate in your code, that means you're doing something wrong. So how can we solve this problem? Well, instead of calling the lower method in each condition, we can call it right here when we get the input from the user. So this input function, as you know, returns a string. We can immediately call the lower method on that string. And with this, our command will always be in lowercase. So we don't need to call this method in every condition. Look, we remove the duplication, and also our conditions are shorter and easier to read. There's also one more place we need to modify, so it's right here. That is better. Now the third command. We need one more elif. If the command equals help, then we want to show the commands that we support. So here we're going to print a multi-line string. So we use triple quotes like this and give the user a guideline like this. So start to start the car, stop to stop the car, and quit to quit. Now finally, we need an else part. So if what the user enters is none of these commands, we're going to tell them, hey, we don't understand this. So else colon print, sorry, I don't understand that. And by the way, note that here, because I'm using double quotes, I can easily use a single quote as an apostrophe. Okay, so let's run our program up to this point and see what happens. All right, let's type start, car started, beautiful, stop, car stopped, help. We get this guideline, but there's so much indentation before our commands. We'll fix that in a second. And finally, let's test the quit command. Oops, our program didn't work properly. Here's the reason. With these if statements, we're comparing the command with start, stop, and help. Anything else will end up here. So that's why our program says it doesn't understand that. So that's why our program says it doesn't understand that command. However, after this else statement, the control will be moved to the beginning of the loop. At this point, our command is quit. So our loop will complete and the program terminates. In other words, when we run this program and type quit, our program actually quits, but we still see this message, which shouldn't appear here. How can we solve this problem? Well, we can come back here and just before the else block, add another elif, something like this. Elif command equals quit. Then we can immediately break. This will solve our problem, but note that we have kind of repeated this expression in two places. The reality is we don't really need this condition on the top because with these if statements, well, more accurately, with this elif, we can jump out of this loop and terminate our program. So we can simplify our condition to something like this. True. So while true means this block of code is going to get executed repeatedly until we explicitly break out of it. Okay. Now let's test our program one more time. So quit. Now our program terminates and we don't see that message. Beautiful. So let's fix the last problem. You saw that when we typed help, these guidelines appeared with so much indentation. And here's the reason. Look, right here in our code, they're already indented. So when we use triple quotes, what we type here will be printed exactly as is. So because we have indentation here, this indentation will also be printed on the terminal. So let's delete these. Okay, run the program one more time. Type help. The indentation is gone. Beautiful. Now here's a challenge for you. I want you to take this program to the next level. So right now, if we type start, we get this message, car started. And if we type start again, we get the same message. It would be better if we got a message like car is already started. So it doesn't make sense to start a car twice. Similarly, if we type stop, it says car stopped. If we type it again, we get the exact same message. It doesn't make sense to stop a car twice. So here's what I need you to do. If the car is stopped and the user tries to stop it again, the program should say, hey, the car is already stopped. What are you doing? And similarly, if the car is already started and the user tries to start it again, the program should yell at the user. So go ahead and make the necessary changes to implement this scenario. All right, to add this to our program, we need to know if the car is started or not. So there is one more piece of information that we need to store in the memory. What is the kind of data we need to store here? A Boolean. Is the car started or not? It's a matter of yes or no, true or false. So on the top, here we can define another variable like started, and initially we set it to false. So the car is not started, right? Now, when the user types the start command, here we need to check to see if the car is already started. If not, we'll start it, otherwise we'll yell at the user. So in this block, we write another if statement. If it's already started, then we print car is already started. Otherwise, so we add an else statement here. And at this point, we set started to true. So we start the car and print this message, okay? Now we need to make a similar change for the stop command. So if the car is already stopped, we need to print a different message. If not started, so here we're using the not operator to see if the car is stopped. So if it's not started, that means it's stopped, okay? So if it's stopped, we print car is already stopped with double P's. Otherwise, so else, we need to stop the car. How do we do that? We set started to false. And then we'll print this message. As easy as that. Let's go ahead and run our program. So initially our car is stopped. So I'm going to type stop. It says the car is already stopped. So let's start it. Okay, now our car is started. Let's start it one more time. The program is yelling at us. So we cannot start the car twice. Beautiful. Now let's stop it. It says the car is stopped. Let's stop it one more time. We get this message again. In this tutorial, I'm going to talk to you guys about for loops in Python. In the last tutorial, you learned about while loops. You learned that we use while loops to execute a block of code multiple times. In Python, we have another kind of loop that is a for loop, and we use that to iterate over items of a collection, such as a string, because a string is a sequence of characters. So it looks like a collection. So we can use a for loop to iterate over each character in a string and then do something with it. Here's an example. We type out for, then we define a variable. This is what we call a loop variable. In each iteration, this variable will hold one item. So let's call it item. In here we type out a string like Python and then colon. So with this for loop, we can iterate over this string. And in each iteration, this item variable will hold one character at a time. In the first iteration, it will be set to P. Then in the second iteration, it will be set to Y. In the third iteration, it will be set to T and so on. Okay. So here we are inside our for block because of the indentation here. So whatever we type here will be executed in each iteration. For now, we can simply print this item. Now, let's run this program and see what happens. So you can see each character in our string is printed on a new line. Let's look at another example. In Python, we can define lists using square brackets. So let me remove this string from here and define a list using square brackets. A list is simply a list of items, like a list of numbers, a list of customers, a list of emails, products, blog posts, whatever. So here we can define a list of names like Mosh, John, Sarah, and then go ahead, run our program. So you can see in each iteration, we get one name and print it on a new line. We can also loop over a list of numbers. For example, 1, 2, 3, 4. Let's run it. Again, we see each number on a new line. But what if we want to iterate over a large list of numbers? We don't want to explicitly type out a list with, let's say, 100 or 1,000 numbers. We don't want to type 5, 6, 7, all the way to 100. That is when we use the range function. So let me delete this. In Python, we have a built-in function called range for creating a range of numbers. So we give it a number, let's say 10. Let's run this program. Now we can see here on the terminal, we have numbers 0 all the way to 9. So 10 is not included. So basically, when we call the range function, this range function creates an object. It's not a list, it's a special kind of object that we can iterate over. In each iteration, this object will spit out a new number. We can also work with a range of numbers here. Let's say we want to start from 5 and go all the way to 10. So let's run our program. Now we have the numbers 5, 6, 7, and 9. Also, this range function can optionally take a step. So we can pass 2 as the step to this function. And when we run our program, you can see that our first number is 5. Now we go 2 steps forward to get 7. Once again, we go 2 steps forward, we get 9, and that is the end of our range. So this is the basics of using for loops in Python. Now here's an exercise for you. I want you to write a program to calculate the total cost of all the items in a shopping cart. So let's say we have a list of prices like 10, 20, and 30. I want you to use a for loop to calculate the total cost of all the items in our imaginary shopping cart. So calculate that and then print it on a terminal. That's pretty easy, and you should do it in a couple of minutes. So as you learned, we use for loops to iterate over all the items in a collection. A collection can be a string, it can be a list, it can be a range object that is returned from the range function, anything, any kind of object that has multiple items. So in this example, we're going to use a for loop to iterate over the list of prices. So for item in prices, colon, and by the way, this loop variable, we don't have to call this item, we can call it anything. For example, in this case, we can rename it to price. So for price in prices. Now in each iteration, this price will hold one value. In the first iteration, it's going to hold 10, then it's going to be 20, and then it's going to be 30. So we need to define another variable to calculate the total. So we define that outside of our for loop. Let's call it total. And initially we set it to 0. Now in each iteration, we get the current price and add it to the total. So we write total equals total plus price. Or as you learned earlier, we can use the augmented assignment operator to simplify this code. So after our for loop, this total variable has the total of all the prices. We can simply print it here. Or we can use a formatted string. So a string prefixed with F. We add a label like total, curly braces, to dynamically include some value in our string. In this case, our total variable. So let's go ahead and run this program. There you go. So the total cost of all the items in our imaginary shopping cart is 60. In this tutorial, I'm going to talk to you guys about nested loops in Python. Using a nested loop basically means adding one loop inside of another loop. And with this technique, we can do some amazing things. For example, we can easily generate a list of coordinates. So a coordinate, as you know, is a combination of an X and Y value. Let's say 0 and 0. Now let's say we want to generate a list of coordinates like this. So we have 0 and 0, then we'll have 0 and 1, then 0 and 2. Next, we're going to change X. So we're going to use 1 for the X. And once again, we're going to use these 3 values for the Y coordinates. So 1 and 0, then 1 and 1, and 1 and 2. You got the point. We can easily generate these coordinates using nested loops. Let me show you. So we start with one loop, let's say for X in range 4. With this loop, we can generate values for the X coordinate. Let's print this on the terminal. Okay, so we get the values 0 to 3. Now, for each X, like 0, we should generate a few Y values. So that is where we use a nested loop. So inside of this loop, we're going to add another loop. So instead of just printing X, first we want to add another loop for Y in range, let's say 3. Now we can print X and Y together. So print, here we use a formatted string. to display coordinates like this. So we add parentheses. Inside of this parenthesis, first we need to add x, so curly braces, x, then a comma, followed by another set of curly braces, and y. Let's run this program and see what we get. There you go. So we have these coordinates 0 and 0, 0 and 1, 0 and 2. Then we have 1 and 0, 1 and 1, 1 and 2, and so on. So let me explain exactly how this program gets executed. So in the first iteration of our outer loop, x is 0, right? Now we are on line 2. Here we have a new loop, which we call an inner loop. In this inner loop, in the first iteration, y is going to be 0. So we'll print 0 and 0 on the terminal. Now the control goes back to line 2, or our inner loop. In this second iteration, y will be set to 1, but we're still in the first iteration of our outer loop. So x is still 0, but now y is incremented to 1. So that is why we see 0 and 1 on the terminal. Once again, the control goes back to line 2. We are in the third iteration of our inner loop. So this will continue until this inner loop completes. That is when y reaches 2, because this range function generates number 0 to 3, but not including 3. So we'll have 0, 1, and 2. After this inner loop completes, then the control goes back to line 1. At this point, we're going to be in the second iteration of our outer loop. So x will be 1, then the control will be moved to line 2, or our inner loop. At this point, this range function is going to generate the numbers 0 to 3 one more time. So this inner loop will be executed 3 times, and then we'll go back to our outer loop. So this is how nested loops get executed. Okay, here's an exercise for you, but this one is a little bit more challenging than the exercises we have done so far. So I really don't expect you to do it, but if you do it, wow, I will be so proud of you. So see what I have done here? Using nested loops, I've written some code to draw this F shape. Can you see that? So let me give you a hint. First of all, we have this list called numbers. In this list, we have these values, 5, 2, 5, 2, 2. These values determine the number of x's we have on each line. So, for example, the first item in this list, this tells us that we should have 5 x's on the first line. There you go. So 1, 2, 3, 4, 5. On the second line, we're going to have 2 x's. On the third line, we're going to have 5 x's, like this. So I've written code to convert a simple list of numbers into a shape like this. Now here's a tip for you. Using a for loop, you need to iterate over this list. In each iteration, you get one number. This determines the number of x's to be displayed on that particular line. So if you want to cheat, you can get this number and multiply it by a string that contains x. So if you multiply x by 5, you'll get 5 x's. That's not what I want you to do. I want you to use an inner loop here to generate a string that contains 5 x's. So imagine in Python, we cannot multiply a string by a number. So to solve this problem, we need a nested loop. So go ahead and spend 5 minutes on this exercise. And by the way, do your best to solve this. It is a little bit challenging, but it's not extremely difficult. It just requires a little bit of focus. You'll see my solution next. All right, so first we need to iterate over all the items in this list. So for item in numbers, or we could rename this variable to x_count. That is the number of x's on each line, okay? Now I told you that if you want to cheat, you can write code like this. Print x times x_count. If we run this program, we get the same output. So this is the beauty of Python. With Python, we can write expressions like this. We can multiply a string by a number to repeat it. A lot of other programming languages don't support this feature. But for this exercise, I wanted you to imagine that we don't have this feature in Python, so you would have to use an inner loop to solve this problem. Here's how it works. In the first iteration, x count is going to be 5. So we need to generate 5 x's. How can we do that? Well, let's say we define a variable called output, and initially we set it to an empty string. Now we need to add 5 x's to this string. So we can use another loop for count in range of x_count. So we're using the range function to generate a sequence of numbers from 0 up to x count. So in our first iteration, x count is going to be 5. So range of 5 would generate the numbers 0, 1, 2, 3, 4. So this inner loop will be executed 5 times. That is exactly what x count represents. So now, in each iteration, we simply need to append an x to our output variable. So we said output plus equals x. And then after this inner loop, we simply print the output. With this, we'll print 5 x's on the first row. Then we go to the second iteration of our outer loop. At this point, x count is going to be 2. Now, on line 3, we're going to reset our output variable to an empty string. So we start over. Then we go to our inner loop. This loop will be executed 2 times, so we'll append 2 x's to the output variable and then print it. As simple as that. So see, it wasn't really that difficult, but it was slightly more difficult than the previous exercises. So let's run this program. There you go. Now, if you're adventurous, I want you to modify the values that we have in our numbers list to print an L here. Now, in this tutorial, we're going to take a closer look at lists. So I'm going to define a list of names. Let's set them to John, Bob, Mosh, Sarah, and Mary. So if we print this list here, what we see on the terminal looks exactly like how we define our list. So we have square brackets, and in between these square brackets, we have our items. So we have 5 strings in this list. Now we can also access an individual element using an index, just like how we can access an individual character in a string using an index. So here we type out square brackets and specify an index. The index of the first item in this list is 0. So let's run this program. There you go. We get John. Now, if you want to print out the third element in this list, its index is 2. So names of 2 returns Mosh. Now we can also pass a negative index here. So -1 refers to the last item in this list, that is Mary. Let's run the program. There you go. We see Mary. If we pass -2, this returns the second item from the end of the list. So let's run the program. There you go. We get Sarah. So this is exactly like accessing individual characters in a string. We can also use a colon to select a range of items. For example, if we pass 2 colon, this will get all the items starting from the index of 2, that is Mosh here, all the way to the end of the string. So let's run this program. There you go. We get this list with 3 items, Mosh, Sarah, and Mary. We can also specify an end index, let's say 4. So this will return all the items up to this index, but it doesn't include the item at this index. So when we run this program, we only see Mosh and Sarah. The item at index 4, which is the 5th element or the 5th item in this list, is not returned. So Mary is not returned, okay? And also here we have default values. So if we leave out the end index, this expression is going to return all the items starting from the index of 2 to the end of the list. Or if you leave out the start index, this expression assumes 0 as the default index, so it will return all the items from the beginning to the end of the list, okay? And by the way, just like strings, these square brackets here don't modify our original list. They simply return a new list. For example, if we pass 2 here, you can see this returns a new list with 3 items. So if we go back here and print our original list of names right after, you can see it's not affected. So whenever we use square brackets with a colon to select a range of items, we get a new list. And by the way, we can also modify any of the elements in this list. For example, let's say we made a mistake and the first item shouldn't be spelled John with an H. So we want to remove the H. That is very easy. So we access it using an index, that is names of 0, and we set it to a new value like this. Now let's print our list. So you can see the first item in this list is now updated. So this is the basics of lists. And here's an exercise for you. I want you to write a program to find the largest number in a list. This is a fantastic exercise for beginners, so go ahead and spend a few minutes on this and then come back, continue watching. All right, let's define a list of numbers with a bunch of random numbers, 3, 6, 2, 8, 4, and 10. Now, to find the largest number in this list, we need to define another variable. Let's call it max. This variable will hold the largest number. Now, initially, we want to assume that the first item in this list is the largest number. So we set max to numbers of 0. We're only assuming that the first item is the largest number. Chances are our assumption is wrong. So we need to iterate over this list. We need to loop through it, get each item, and compare it with max. If it's greater than max, then we need to reset max to that number. So in the first iteration, we get 3, and max is also 3. Is 3 greater than 3? No, so we move on. We get the second number. Is 6 greater than 3? It is, so we need to reset max to 6. Once again, we continue, we get 2. Is 2 greater than 6? No, it's not, so we move on. Then we get 8. Is 8 greater than 6? It is, so we should reset max to 8. That is pretty easy. So here we need a for loop. For number in numbers, colon. Now we need to check to see if this number is greater than max. So if number is greater than max, colon, then we need to reset max. So we set max to this new number. That's all we had to do. So let's print max and run our program. We can see the largest number in this list is 10. It doesn't matter whether this number is at the end of the list or at the beginning. So if I move 10 and put it right at the beginning, we should still see the same result. Let's run our program. We still see 10. If I put this somewhere in the middle, our program should still work. Let's put it right after 2. Run the program. We still get 10. In this tutorial, I'm going to talk to you guys about two-dimensional lists in Python. Two-dimensional lists are extremely powerful, and they have a lot of applications in data science and machine learning. Here's an example. In math, we have a concept called matrix, which is like a rectangular array of numbers. Let me show you. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a rectangular array of numbers. We have rows and columns. So this is a 3 by 3 matrix in math. Now we can model this in Python using a two-dimensional list. A two-dimensional list is a list where each item in that list is another list. So you want to define a matrix. We set it to a list. Each item in this list is going to be another list, and that list represents the items in each row. So the first item in our list is going to be another list, and in this list we're going to have the values 1, 2, and 3. Now the second item in our matrix list. Once again, we have a list. This list represents the items in the second row. So 4, 5, and 6, and finally 7, 8, 9. So as you can see, we have a two-dimensional list. Each item in our outer list is another list. Okay? So this is how we can implement a matrix in Python. Now to access an individual item in our matrix, once again, we use square brackets. Let me delete this stuff. All right. So how do we access one here? Well, we start with our list. Then we add square brackets. First, we need to go and get the first item in this list, right? So we pass 0. Now this expression returns another list. That is the inner list. In this list, let's say we want to access the second item. So once again, we add square brackets and we pass 1. That is the index of 2 in this list, right? So if we print this on the terminal, we get 2. Okay, so using 2 square brackets, we can access individual items in our matrix. And also we can modify these values using this syntax. So before printing this, let's change it to 20. So matrix of 0 and 1, let's change it to 20 and then print it. There you go. It's modified. Now here we can also use nested loops to iterate over all the items in this matrix. Let me show you. So we start with the rows for row in matrix. So with this loop, we are iterating over our matrix list. In each iteration, row will contain one list, one item, okay? Now, here we need to use an inner loop. So we need to loop over this row, which is a list of items. We can type out for item in row, colon, and print item. Okay, so let's run this program. There you go. We get all the items in our list. Hey, I just wanted to make a quick announcement. In case you haven't seen my website yet, head over to codewithmosh.com. This is my coding school where you can find plenty of courses on web and mobile application development. In fact, recently I published a comprehensive Python course that goes way beyond this beginner's course on YouTube. And if you're serious about learning Python and getting a job, I highly encourage you to enroll in this course. Just like this tutorial, you can watch it anytime, anywhere, as many times as you want. And you will also receive a certificate of completion that you can add to your resume. And the course comes with a 30-day money-back guarantee. So if you're not happy, we give all your money back. No questions asked. The price for this course is $149, but the first 200 students can get it for only $15. So if you're interested, the link is below this video. Click the link and get started. In this tutorial, I'm going to talk to you guys about the list methods or list functions. These are the operations that we can perform on a list. So let's define a list of numbers. Here we pass a bunch of random numbers like 5, 2, 1, 7, and 4. Now, there are a number of things we can do with this list. We can add new items to it. We can remove existing items. We can check for the existence of an item. These are the operations that we can perform on a list. So when we type numbers dot, we can see all these functions, or more accurately, the methods that are available in our list objects. So we can call the append method to add a new item to this list. Let's say 13. Actually, no, it's not a good number. I'm joking. I'm not superstitious. So let's add 20. Doesn't really matter. And then print our list. When we run the program, you can see 20 is added at the end of this list. But what if you want to add a number somewhere in the middle or at the beginning of our list? For that, we use a different method that is called insert. So insert. Now this method takes two values. Let me show you. So when we open parentheses, look at this little tooltip above the insert method. You see the first value that we need to pass here is an index. So this is the index at which we want to insert this new item. Let's say we want to add an item at the beginning of our list. So we pass the index position of 0. And then the second value is the actual object we want to add to this list. Let's say we want to add the number 10. Now, when we print this list, you can see that the number 10 is placed at the beginning of the list and all the other items are pushed to the right. We can also remove an item. So we call remove and pass the item that we want to remove. Let's say we want to remove 5. Now we print our list. So you can see 5 is gone and we have 2174. If you want to remove all the items in the list, you can call the clear method. So clear. This method doesn't take any values. So we simply call it and it empties our list. All the items are removed. We also have another useful method called pop. And with this, we can remove the last item in a list. Let me show you. So run our program. You can see the number 4 is removed from the end of our list. Now, if you want to check for the existence of an item in a list, you can call the index method. So we call index and pass a value here like 5. And this returns the index of the first occurrence of this item. So let's print this on the terminal. We don't need this line anymore. So the index of 5 is 0. What if we pass a number that doesn't exist in this list? Let's say 50. Run the program. We get an error. We get a value error. 50 is not in the list. There is also another way to check for the existence of an item. We can use the in operator. So let me show you. We type out 50 in numbers. Earlier, we used the in operator with a string. we could check for the existence of a character or a sequence of characters in a string. Now here we're checking for the existence of 50 in the list of numbers. So let's print this. We get a Boolean value, false. So unlike the index method, this expression doesn't generate an error. So it's safer to use this. We also have another method for counting the occurrences of an item. Let's say we have another 5 over here. Now we can call numbers.count and pass 5. And this should return 2 because we have 2 5s in this list. Take a look. There you go. That is pretty useful. Now, if you want to sort your lists, you can call the sort method. So we call the sort method here. This method doesn't take any values. So look at the return value. That is none. None is an object in Python that represents the absence of a value. So this sort method doesn't really return any values. It simply sorts this list in place. So instead of printing the return value of this method, we simply call it to sort our list and then print our list. Take a look. Now all the items are sorted in ascending order. We can also sort the items in descending order. So after we sort the list, we can call the reverse method, and this simply reverses our list. Now let's go ahead and run our program. Take a look. Our numbers are sorted in descending order. And one last method I want to show you here that is pretty useful is the copy method. So copy. With this method, we can get a copy of our list. So let's define another variable called numbers2. Now numbers2 is a copy of our original list. So if you make any changes to our original list, if you add new items to it, if you remove existing items, these operations are not going to impact our second list. Let me show you. So after we take a copy of our numbers list, let's add a new item to this list. So numbers.append 10. So the first list is updated. So now we have a new item in our first list. Then let's print the second list. Take a look. We don't have the number 10 here because these are two independent lists. So these are all the operations that we can perform on lists. We can add new items to a list. We can remove existing items. We can check for the existence of an item. We can sort our lists and copy them. Now here's the exercise for this tutorial. I want you to write a program to remove the duplicates in a list. Again, this is a fantastic exercise. So spend a few minutes on this and then come back, continue watching. All right, let's say we have a list of numbers with a bunch of duplicates. So 2, 2, 4, 6, 3, 4, 6, 1. We want to remove the duplicates. So we need to define another list. Let's call that Unix. Initially, we set it to an empty list. Then we need to iterate over our first list, get each item, and if we don't have that number in this Unix list, then we'll add it to the second list. As simple as that. So for number in numbers, now we need to check to see if we have this number in the second list. So we use the in operator. If number not in Unix, so note that here we are using the not operator. So if we don't have this number in this Unix list, then we'll need to add it. So Unix.append number. That's all we have to do. So let's go ahead and print the Unix list. There you go. So we have 2, 4, 6, 3, and 1. The duplicates are removed. In this tutorial, I'm going to talk to you guys about another important structure in Python called tuple. Tuples are similar to lists, so we can use them to store a list of items. But unlike lists, we cannot modify them. We cannot add new items. We cannot remove existing items. We say tuples are immutable. We cannot mutate or change them. Let me show you. So I'm going to start by defining a list of numbers, 1, 2, 3. So we use square brackets to define lists and parentheses to define tuples. So if we change this to parentheses, 1, 2, 3, now we have a tuple. So if we type numbers dot, look here, we don't have the append or insert methods. So we cannot add new items to this tuple. We also don't have remove, clear, and pop. We cannot remove any of these items here. We only have two methods, count and index. We use count to count the number of occurrences of an item, and index to find the index of the first occurrence of an item. So we can only get information about a tuple. We cannot change it. And by the way, these other methods that you see here, they start with 2 underscores. We refer to these as magic methods. They're more of an advanced topic, so they go beyond the scope of this tutorial. If you're interested to learn about them, you can get my Python course. I've covered them in detail. So similar to lists, we can access individual items using square brackets. So we can get the first item like this and then print it on the terminal. There you go. The first item is 1. But if we try to change the first item, we'll get an error. So numbers of 0, we set it to 10 and run our program. There you go. We get this type error because the tuple object does not support item assignment. So we cannot mutate or change tuples. They are immutable. Now, practically speaking, most of the time you'll be using lists, but tuples are also useful. If you want to create a list of items and you want to make sure that nowhere in your program you accidentally modify that list, then it's better to use a tuple. In this tutorial, I'm going to show you a powerful feature we have in Python called unpacking. So let's define a tuple called coordinates. And here we pass 3 values, 1, 2, 3. So imagine these are the coordinates for x, y, and z. Now let's say we want to get these values and use them in a few expressions, in a few complex expressions in our program. Maybe we want to include them as part of a large complex formula. So to get them, we'll have to write code like this. Coordinates of 0. Then let's say we want to multiply this by coordinates of 1 and then multiply it by coordinates of 2. Our code is getting a little bit too long. This is just a very simple example. But let's say we want to use these values in quite a few places in our program. So a better approach is to get these values and store them in separate variables. Like we can get coordinates of 0 and store it in x. Then we get coordinates of 1 and store it in y. And similarly, we get coordinates of 2 and then store it in z. Now, instead of repeating coordinates of 2 or coordinates of 0 multiple times, we can simply work with these variables, x times y times z. That is better, right? So nothing new so far. But in Python, we have a powerful feature called unpacking. And with that, we can achieve the same result with far less code. So we can define our variables x, y, and z and set them to our tuple. What we have on line 6 is exactly identical to what we have on lines 2 to 4. So this is a shorthand to achieve the same result. So let me delete this and explain how this code works. When Python interpreter sees this statement, it will get the first item in this tuple and assign it to this variable. Then it will get the second item in this tuple and assign it to the second variable. And similarly, it will get the third item in this tuple and assign it to the third variable we have here. So we are unpacking this tuple into 3 variables. Now, if we print x, you can see x is 1. Similarly, y is 2. There you go. So this is unpacking. And by the way, this is not limited to tuples. We can use this feature with lists as well. So if I change parentheses to square brackets, now coordinates is a list. So we can unpack this list into 3 variables. Now, run our program. You can see y is 2. In this tutorial, I'm going to talk to you guys about dictionaries in Python. We use dictionaries in situations where we want to store information that come as key value pairs. Here's an example. Think of a customer. A customer has a bunch of attributes like name, email, phone number, address, and so on. Now, each of these attributes has a value. For example, the name can be John Smith. The email can be john@gmail.com. The phone can be whatever. So what we have here is a bunch of key value pairs. So in this example, our keys are name, email, and phone, and each key is associated with a value. So this is where we use a dictionary. With a dictionary, we can store a bunch of key value pairs. So let me show you how to define a dictionary in Python. Back to our program, I'm going to define a variable, customer, And here we set it to curly braces. With these curly braces, we can define a dictionary. In this example, we have an empty dictionary that doesn't have any key value pairs. Now we can add one or more key value pairs in between the braces. So let's add a key value pair here. I'm going to set the key to name and the value to John Smith. Then we add a comma to add another key value pair. So let's set age to 30. Let's add another key value pair is underline verified. And we set this to a Boolean. Now what matters here is that these keys should be unique. So if I add another key value pair here, let's set age to 40. Now look, Pycharm has highlighted the age key because we have duplicated that, and that's not allowed. So each key should be unique in a dictionary, just like the dictionaries we have in the real world. In a real dictionary, we have a bunch of words and their definition. Each word is listed only once in a dictionary. We don't have the word book twice. So let's delete this second duplicate key value pair. So the keys should be unique. And in this example, I'm using strings, but they can also be numbers. We're going to look at that later. But the value can be anything. It can be a string, a number, a Boolean, a list, literally anything. Now we can access each item in this dictionary using square brackets. So we type customer, square brackets, and then specify a key, like name. And this will return the value associated with the name key. Let's print it on the terminal, have a look. There you go. So the name is John Smith. Now, what if we pass a key that doesn't exist? Let's say birth date. Run the program. We get a key error because we don't have a key called birth date. Also, if we spell name with, let's say, a capital N, we get the same error because we don't have a key with the exact same sequence of characters in this dictionary. Now, to get around this, we can use the get method. Let me show you. So instead of using the square brackets, we call the get method and specify our key. Now, if we use a key that doesn't exist here, it doesn't yell at us. For example, if we pass birth date, it simply returns the none value. Earlier, I told you that none is an object that represents the absence of a value. So instead of getting a key error, we get none. Now we can also optionally supply a default value. For example, if this dictionary doesn't have this key, we can supply a default value. Let's say January 1st, 1980. Let's run the program. Now, instead of getting none, we get this default value. So this is how we can access the value associated with a key in a dictionary. We can also update these values. For example, before a print statement, we can write code like this. Customer of name. Let's update the name to Jack Smith. Now, this little warning here is telling us that we could simply put Jack Smith here instead of defining it once and then update it. Don't worry about that. It doesn't really matter. Now with this line, if we print the name of this customer, we should see Jack Smith. Let me show you. So I'm going to use the square bracket notation again. Let's print the name of the customer. You can see that is updated here. We can also add a new key here. Let's set the birth date to some value like January 1st, 1980. And then we can print it here. So as you see, we can easily add new key value pairs to a dictionary. So this is the basics of using dictionaries in Python. They're extremely important and they have a lot of applications in the real world. Okay, here's an exercise for you. So here we have this program that asks our phone number. Let's type 1234. We type it in digits, and then this will translate it to words. Take a look. Enter. It prints 1234. That's a pretty cool program. So go ahead and spend a few minutes on this exercise. It's pretty easy. I will see you next. All right, so first we need to get the user's phone number. We call the input function with the label phone. We get the result and store it in this variable. Now let's say the user enters 1234. So we need to loop through this string, get each character, and translate it to a word. So what we need to implement this scenario is a dictionary, because a dictionary is a structure that allows us to map a key to a value. So we can have a dictionary with keys like 1, 2, 3, 4, And we map each of these keys to a word. So we can map the digit 1 to the word 1. We can map 2 to TWO. You got the point. So let's define a dictionary. We can call it digits underline mapping. Now in this dictionary, I'm going to add a few key value pairs. 1, we map it to 1, 2 to 2, 3 to 3, and finally 4 to 4. Now technically we should add all the digits from 0 to 9, but I don't want to waste your time typing repetitive things here. You got the point. So let's move on. Now we need to loop through the phone string. So for character in phone, we get each character and then use it to access a key value pair in our dictionary. So digits underline mapping, we can use square brackets or call the get method. I would prefer to use the get method. So in case the user enters some character that is not part of our dictionary, our program is not going to yell at them. So we call the get method and pass this character as the key. And if we don't have this key, we can supply a default value like an exclamation mark. So with this, we'll get a word. Now we need to add this word to an output string. So we can define an output string. Initially, we set it to an empty string. In each iteration, we get this and add it to our output string. So we type output plus equals this. And we should also add a space at the end. So the words are not close to each other. Okay, that's all we have to do. Now, finally, let's print this output, run our program. So I'm going to type 1, 3, 4, 5. Let's see what we get. We get 1, 3, 4 with an exclamation mark. In this tutorial, I'm going to show you something really cool that you can do with dictionaries. So here we have this program. We can type a message like good morning, followed by a smiley face. When we press enter, we get this beautiful smiley face. Or we can type I am sad with a sad smiley face, and it gets translated to this beautiful emoji. So this is another application of using dictionaries. We have a dictionary that maps these characters into smiley faces. So let's go ahead and build this program together. We start by calling the input function. Here we pass a greater than symbol as an indicator for the user to type a message. We get that message, store it here. As you know, that is a string. Now we need to split the string by a space. So if the user types good morning with a smiley face, we want to break this down into 3 words: good, morning, and smiley face. To do that, we can call the split method. So we call message.split and pass a string with 1 space as the separator. What this method does is basically it goes through the string, and anywhere it finds this character, in this case a space, it uses that as a boundary to separate this string into multiple words. And then it will return a list. Let me show you. So let's store that here, words, and then print it on the terminal. Let's go ahead and run our program. So if we type good morning sunshine, enter, we get a list with 3 items. Each item is a string. Okay, now back to our program. We need to define a dictionary for mapping special characters like these 2 into a smiley face. So we can call that emojis, set it to curly braces. Here we add a key value pair, a smiley face, and we map that to a string. In the string, we want to add an emoji. If you're on a Mac keyboard, you can press Control, Command, and space, and this should bring up this emoji box. If you're on Windows, honestly, I really don't know how you can do this, but there must be applications that do this for you. So let's go ahead and pick this happy smiley face. Good. Now let's add another key value pair for a sad face. We map this to this face here. Good. So we have a list of words. Now we need to loop through this list, get each word, and potentially map it to an emoji. So we can write a for loop for word in words. Now we want to go to our dictionary and see if we have an item with this word as the key. If you have an item with that key, then we'll get its value. Otherwise, we want to use the same word. So if the user types good morning, we don't want to translate those words. We just want to return those. So that is the case where we use the get method to supply a default value. So we want to get an item with the key word. And if we don't have an item with that key, we simply use that word as the default value. Now, similar to the exercise that we did in the last tutorial, we need an output variable. So let's define that here, output, set it to an empty string. Now back to line 9, we get the return value of the get method and add it to our output variable. So output plus equals whatever we get from the get method. And finally, we need to append a space at the end. That's it, we're done. So let's print the output and run our program. I'm going to type good morning, sunshine, with a smiley face. We get that, beautiful. Let's try a sad face as well. I am sad, too bad. Beautiful. So as you can see, dictionaries have a lot of use cases in real applications. Here's a solution from the last tutorial where we created an emoji converter. Now, so far we've been writing all our code right here in app.py, but as our programs grow, we need a better way to organize our code. We need to break up our code into smaller, more manageable, and more maintainable chunks, which we call functions. So a function is a container for a few lines of code that perform a specific task. For example, you have learned about a few of the built-in functions in Python like print and input. Each of these functions have a purpose. They know how to perform a specific task. So when building large, complex programs, we should break up our code into smaller, reusable chunks, which we call functions, to better organize our code. And that's what I'm going to show you in this tutorial. So let's write a simple program for printing a greeting message. So we're going to do a print, hi there, and let's add another message, welcome aboard. So here we have a simple program with only 2 lines of code. Now let's say these 2 lines, potentially we're going to need them in other programs. So we can put them in a function that we can reuse. Let me show you how to do that. So we start typing out def, that is a reserved keyword in Python, and it's short for define. When Python interpreter sees this, it knows that we're defining a function. Next, we need to give our function a name. Let's say greet underline user. So all the best practices you learn about naming your variables also apply here, which means you should name your functions with lowercase characters. If there are multiple words, you need to separate them using an underscore. And you should always use meaningful and descriptive names for your functions. So here we're defining a function called greet user. After that, we need to add parentheses followed by a colon. Now, you know that whenever we add a colon at the end of a line, we're telling Python that we're defining a block of code. So when we press enter, the next line is indented. Now, any code that we write here will belong to this function. So I'm going to move these 2 lines, these 2 print statements inside of our function. We can simply press tab to indent them. Beautiful. Also, let's remove this extra line break. That is better. So these 2 lines now are part of our greet user function. So whenever we call this function, these 2 lines will be executed. Okay. Now let's remove indentation. So here we are outside of our function. Let's do a print statement and print start. After that, let's call our function. So greet user. And finally, let's do another print statement and print finish. Now we have this little warning here, this underline. If you hover your mouse over this line, this tooltip is telling you that we should add 2 blank lines after function definition. This is coming from PEP 8, which is a document that defines the best practices for formatting our code. We'll look at that in the future. So for now, to make Pycharm happy, let's add an extra line break after this function. So whenever we define a function, we need to add 2 line breaks after. Okay. So now let's run our program and see what happens. All right. So we get 4 messages on the terminal. First, we get the start message. Then we get the messages coming from our greet function. So hi there and welcome aboard. And finally, we see the finish message. So let me explain the flow of our program. When Python runs this code, it doesn't actually print these 2 messages on the terminal because these lines of code are inside of this function. So they will only get executed if we call this function. If we don't call this function, these lines will not get executed, okay? So the execution of our program actually starts here. The first message that we see on the terminal is the start message. After that, Python sees that we're calling the greet function. So it will jump over here and then execute these two lines. Then it will jump outside of this function and continue the normal execution of our program. So it will print the finished message on the terminal. So this is how functions work. Also note that the order of this code matters. So here we're calling the greet function after we have defined it. If you try to call it before you define it, you will see an error. For example, if we call the greet user function right here, see, we immediately get this red underline, which says unresolved reference greet user, which basically means Python doesn't know what is this greet user. It's not defined anywhere. So we always define our functions first and then call them. Here's the function we created in the last tutorial. Now I got a question for you. What is the difference between calling this function and the print function of Python? The difference is that the print function takes some information, in this case, the message that we want to print, but our greet function doesn't take any information. Wouldn't that be nicer if you could pass the name of the user here, and then instead of saying, hi there, we could print the name of the user? So in this tutorial, I'm going to show you how to pass information to your functions. And that is pretty easy. So back to the definition of our greet user function. Inside of this parenthesis, we can add parameters. These parameters are placeholders for receiving information. For example, we can add a name parameter, and with this, we can pass the name of the user when calling this function. So let's pass John here. Now, when we call this function and pass this value, this name parameter will be set to John. So it will act like a local variable that we define inside of this function. Just imagine we didn't have this parameter, and instead we had a variable like name that was set to John. Now here, we could simply print the name of this user. So we could use a formatted string and print the value of the name variable, right? Now, we don't really have this local variable defined in this function. We have a parameter. It's exactly the same thing. So with these parameters, we can receive information in our functions. Now let's go ahead and run this program. So take a look. We get, hi John, welcome aboard. We can take this to the next level. Now we can call this function one more time. So greet user, and this time supply a different name. Let's say Mary. So we are reusing our greet function and passing it a different value. Imagine if we didn't have this function, we would have to repeat this line twice. Once for hi John and another time for hi Mary. So this is the benefit of defining functions. We can take a few lines of code that have a specific purpose and put them inside of a function. So now let's run our program one more time. There you go. So we get hi John, welcome aboard. Then we get hi Mary, welcome aboard. Now note that when a function has a parameter, we are obligated to pass a value for that parameter. So if we remove John from here and run our program, we get this type error, greet user missing one required positional argument. Argument in programming is the value that we supply to a function. So back to this example, Mary in this case is an argument that we pass to the name parameter. A lot of programmers don't know the difference between parameters and arguments and think they are the same, but they are not. Parameters are the holes or placeholders that we define in our function for receiving information. Arguments are the actual pieces of information that we supply to these functions, okay? So let's bring back this John string, okay? Now we can also define multiple parameters. For example, let's rename this parameter to first name. As I told you before, you can right click here, go to refactor, and then rename, or preferably you can use a shortcut. So the shortcut for this on Mac is Shift and F6. And this brings up the rename dialog box. Here we can change this to first underline name. Now we can add a second parameter, so comma, followed by last underline name. So back to our formatted string, let's also print the last name. Beautiful. So here when calling these functions, then we can supply another argument. So John Smith, And let's delete this line. We don't really need it anymore. Run our program. Take a look. Hi, John Smith. So in the last tutorial, you learned that whenever we define parameters for our functions, we should always supply values. Otherwise, we'll get an error. Let's look at that error one more time. So I'm going to delete the second argument and only pass John. Run our program. We get this message. Greet user, missing, 1, required, positional argument. So these arguments that we have here, like John and Smith, we refer to these as positional arguments, which means their position or order matters. In other words, the first argument we add here is the value for the first parameter, and the second argument is the value for the second parameter. So if we change their position or order, we'll get different result. Let's take a look. Let's pass Smith first and then John. Okay. Delete. That's good. Let's go with this. So instead of getting hi John Smith, we get hi Smith John. So that is the reason we refer to these arguments as positional arguments. Their position or order matters. But in Python, we also have keyword arguments, and with those, the position doesn't matter. Let me show you how they work. So let's say here we want to pass John as the value for the first name parameter. We can simply specify that here. So first name equals John. Now what we have here is a keyword argument. So this combination of having the parameter name followed by its value is what we call a keyword argument. And with these keyword arguments, the position doesn't really matter. So here we're supplying John as an argument for the first parameter. Now similarly, we can use a keyword argument for Smith. Let me show you. So last name equals Smith. So now we have two keyword arguments. So with these keyword arguments, we don't have to worry about the order of the parameters. That doesn't mean we should always use keyword arguments. Not really. Most of the time, we use positional arguments. But in certain situations, these keyword arguments help us improve the readability of our code. So on line 7, it's quite clear that we're supplying Smith as the last name and John as the first name. Now, in this particular example, even if we didn't have the keyword arguments, just passing two positional arguments like John and Smith would be sufficient because it's easy to guess what is the purpose of these arguments. But sometimes you're dealing with functions and you're passing numerical values to them. In those situations, it may not be quite clear what these values represent. Let me show you an example. Let's say we have a function for calculating the total cost of an order. So we can call that calculate underlying cost. So when calling this function, we need to supply three pieces of information. One is the total cost of all the order items, let's say $50. The other is the shipping cost, let's say $5. And the last piece is a discount, let's say 0.1. Someone reading this code may not be sure what these three values represent. In this case, we can improve the readability of this code by using keyword arguments. So we can prefix each value with the name of the parameter they target. For example, we can set total to 50 and then shipping to 5 and discount to 0.1. Now, if we give this code to someone else, they can immediately tell what these values represent. So that is the power of keyword arguments. So here's what I want you to take away. For the most part, use positional arguments. But if you're dealing with functions that take numerical values, see if you can improve the readability of your code by using keyword arguments. You simply prefix the arguments that you pass with the name of their parameters, and this will increase the readability of your code. Now, there is one more thing you need to know about keyword arguments. These keyword arguments should always come after positional arguments. Let me show you what I mean. So back to our simple greet user function. Let's use a keyword argument for the first name. So let's set first name to John and see what happens. Look, we immediately get this error. Take a look. Positional argument after keyword argument. So when calling this function, we're supplying one keyword argument and one positional argument. And Python doesn't like this. So if you're mixing positional and keyword arguments, you should always use the positional arguments first and then the keyword arguments. In other words, let's remove this keyword argument here. So John is now a positional argument, is targeting the first parameter, right? Now, after this positional argument, we can supply any number of keyword arguments. So if we set last name to Smith, look, Python doesn't have any problem with this because we're adding a keyword argument after a positional argument. So let's quickly recap. For the most part, use positional arguments. If you're dealing with functions that take multiple numerical values and it's not quite clear what those values represent, use keyword arguments to improve the readability of your code. And finally, if you're passing both positional and keyword arguments, use the keyword arguments after the positional arguments. So far, you have learned how to create functions and send them information using their parameters. In this tutorial, I'm going to show you how to create functions that return values. This is particularly useful if you're doing some kind of calculation in your function and you want to return the result to whoever is using your function. Let me show you. So let's start by defining a function called square. This function simply calculates the square of a number. So we need to add one parameter here, that is our number. Now here we want to calculate number times number. That is the square of a number. Now to return this number outside of this function, we simply use the return statement. So return. Now our square function is very simple. It only has one line of code. But in a real program, you might have a function that has 10 lines of code to calculate something. So this return statement is very valuable. With that, we can return values to the callers of our function. So with this, when we call the square function, let's say we give it 3, now this function returns a value, just like the input function of Python. This input function waits for the user to type something and press enter, and then it will return the user's input as a string. So we can get it and store it in a variable like this, right? We have the same story with our square function. So our square function returns a value. We can simply get it and store it in a variable. Let's call that result. Now we can print result on the terminal. There you go. So result is 9. We could also pass this function call directly inside of the print function without defining a separate variable. Sometimes this is useful for writing shorter code. So in this case, we don't really need this result variable. We simply want to print the square of 3. So we could simply pass this function call right here as an argument for the print function. So let's delete this variable. Now our code is shorter. So with this, we're calling the square function. This returns a value, and we'll pass that value as an argument to the print function. Okay? When we run this program, we get the exact same result. There you go. Now, what happens if we don't use a return statement in our function? So in the last example, we simply used a print statement. Let's temporarily remove this return statement and print the result on the terminal like this. So let's run our program one more time and see what we get. We get two things on the terminal, the number 9 and none. What is happening here? Well, when Python interpreter executes this code, first it will call the square function. So the control moves to the square function. Here we calculate the square of this given number and then print it on the terminal. That is the reason we see 9 right here. Now, by default, all functions return the value none. So if we don't have a return statement here, by default, Python returns none. None is an object that represents the absence of a value. It's like nothing or null in C, C++, Java, and JavaScript. So in this example, we didn't have a return statement, and by default, Python returned none from this function. So after this square function is executed, the value none is returned and passed as an argument to the print function. That is the reason we see none on the second line. So here are the two things you need to take away from this tutorial. By default, all functions in Python return none. You can change that. So if you have a function that calculates something, you can return the result using the return statement. Here's the code for our emoji converter program that we wrote earlier. If you missed that tutorial, make sure to go back and watch it. As I told you before, there is a table of content right below this video in the description. So you can simply click on the emoji converter tutorial to watch it. Now, Your exercise is to reorganize this code using a function. So I want you to extract a function in this code. Because this algorithm for converting these smiley faces into emojis is something that we probably want to use in a lot of different applications. We can use it in a chat application, in an email application, and so on. We don't want to write all this code every time. We want to convert these characters into smiley faces. So out of all these lines of code that we have, from line 1 to line 10, the lines 2 to 9 belong to our algorithm. All these lines together implement this feature. So you should put these lines in a separate function. Now, why don't we have the input in that function? Because the input can come in different forms. Currently, we're using the input function to receive the input from the terminal, but in other applications, we might receive the input from a graphical user interface. So the input can come in different forms. We don't want to put that in our function because this line will not be reusable. We want to give our function the actual message as a string. We don't care how we got that message. In one program, we might get it from the terminal. In another program, we might get it from a graphical user interface. So that is the reason this line of code should not be in that function. By the same token, you shouldn't include the last line in that function because what we do with the output is different from one program to another. In this program, we're printing the output. In another program, we might send that output as an email or as a response in a chat application. So as a general rule of thumb, your function should not worry about receiving input and printing it. These lines of code should not belong to your functions. So go ahead and reorganize this code by extracting a function. All right, on the top, first we need to define our function. So we type def, give our function a name like emoji underline converter. So the name of this function clearly tells me what it does. Each function should be responsible for one and only one task, and that task should be clearly explained in the name of the function. Okay, so our emoji converter function should take a parameter. We call that message. That is a string, right? Colon. Now we need to move the lines 5 all the way to the end of our for block into that function. So let's select all these lines. We can cut them from here by pressing Command and X on Mac or Control and X on Windows. Then we paste them here. As you can see, these lines are automatically indented, so they are part of the emoji converter function. If this didn't happen on your computer, make sure to select these lines and use the tab to indent them. All right, so here's our emoji converter function. Beautiful. Now, after that, in the main flow of our program, first we get the input from the user. We store it in this variable message, and then we call emoji converter and pass this message. This function should return a value. That is what we calculate at the end of this function. So right after this for block, we need to add a return statement, return output. Now that our function returns a value, we can get it and store it in a separate variable. Let's call that result. And then we can simply print that here, or we can make this code shorter. We don't really need this variable here. So we can simply call the emoji converter and print the result like this. Now here we have an underline because, as I told you before, we need 2 blank lines after our function definitions. So currently we have only 1 blank line. We need to add another blank line. Good. Let's go ahead and run this program to make sure everything works as before. So I'm going to type a message like good morning with a smiley face. Good. Let's run it one more time. I'm sad. Too bad. Okay, beautiful. So here's the final result. We defined this function called emoji converter. This function takes a parameter called message and finally returns the output. In this tutorial, I'm going to teach you guys how to handle errors in your Python programs. So let's start by writing a small program to get the user's age from the terminal. So we call the input function input, add a label here like age. This returns a string, so we need to pass it to the int function and then store the result in a variable called age. Now let's print age to make sure we have implemented everything properly. Run our program. We type 20. 20 is printed here. Beautiful. Now look at the exit code of this program. Exit code 0 means our program terminated successfully. There were no errors. But what if we run this program one more time, and instead of entering a numerical value, we enter something like ASD. We get a value error with this message, invalid literal for int with base 10. Basically, what this message is telling us is that this string ASD does not contain a valid whole number that can be converted to an integer. Now look at the exit code of this program. Exit code 1 means our program crashed. So 0 always means success, and anything but 0 means crash. Now, as a good Python programmer, you should anticipate these situations. You don't want to let your entire program crash just because the user entered an invalid value. So instead of letting the program crash, you should handle this situation and print a proper error message. And that's what I'm going to show you in this tutorial. Now, before going any further, look at the type of the error we get here, value error. So remember this, we're going to get back to this shortly. Now, how can we handle these errors? In Python, we have a construct called try except. We use that to handle errors. Let me show you how it works. So on the top, we type try colon. Now, as you know, we're defining a code block. So I'm going to move these two lines inside of our try block. So press tab here and remove this blank line. Now, these two lines are part of our try block, right? So after try, we type except, and then we add the type of the error that our program may encounter. That is value error, okay? Then we add a colon, and in this block, we can define what should happen if our program encounters an error of type value error. In this case, we want to print a proper error message. So print invalid value. So with this try and except, we're telling Python, hey, go ahead and try running these two lines of code. If you encounter an error of type value error, then instead of crashing the program, print this error message on the terminal. So this is how this works. Now, more accurately in programming terms, we refer to this kind of error as an exception. So an exception is a kind of error that crashes our program. So if the user enters an invalid value, this line of code, line 2, will raise an exception, and on line 4, we'll catch it and print this error message so our program will no longer crash. Let me show you. So let's go ahead and run this. Age 20, everything works just like before, and the exit code is 0. Beautiful. Let's rerun this program and enter ASD. So we get this proper error message, invalid value, and once again, the exit code is 0. So that means our program completed successfully, didn't crash. Now, we can also handle different kinds of errors or exceptions. For example, right after we get the age, let's define a variable, income, and set it to 20,000. And then define another variable called risk and set it to income divided by age. Let's run this program and enter 0 as the age to see what happens. So 0 is obviously a numerical value. So when we enter this value, technically we shouldn't get any exceptions. Take a look. Our program crashed with a 0 division error because we cannot divide a number by 0. Once again, look at the exit code. So we couldn't catch this kind of error or this kind of exception with this except block. This except block is only catching exceptions of type value error. And this happens when we try to convert a non-numerical value to an integer. So in a situation like this, we should handle different kinds of exceptions. We can add another except statement for an exception of type 0 division error. Now in this block, we can print a different kind of message like age cannot be 0. Let's run our program one more time. Now I'm going to enter 0 as the age. So we get this error message, age cannot be 0, and look at the exit code. It's 0, so our program didn't crash. So to recap, we use try except blocks to handle exceptions that are raised in our programs. As a good programmer, you should always anticipate these kind of exceptions and handle them properly. In this tutorial, I'm going to talk to you guys about comments in Python. We use comments to add notes or comments to our programs. For example, here I'm going to make a print statement. Sky is blue. Now, before that, I can add a comment using a hash sign, and then whatever I type here is going to get ignored. It's not going to get executed. Let me show you. So let's run this program. Look, we only see this message, sky is blue. So with this comment, we can explain something about our code. We can use that as reminders to fix things or clean things up, or we can use it to communicate things with other developers reading our code. Why we have written this code in a certain way. These are good use cases for using comments. We can also have comments over multiple lines, so we can simply add more comments. Each line should start with a new hash sign. Now, one thing you need to avoid when using comments is explaining what the code does. So here's an example of a bad comment. Let me just delete these 2 lines. And with this comment, I'm going to say print sky is blue. Why is this a bad comment? Because it's telling me the obvious. It is obvious that the next line is going to print sky is blue. Now, the problem with this comment is that apart from being verbose and repetitive, if we come back here and change sky to ocean, now this comment gets outdated. So every time we change this code, then we'll have to come back and modify the corresponding comment. So I've seen some developers add comments in front of their functions. For example, they define a function, let's say square, that takes a number and simply returns number times number. Well, it is obvious that this function calculates and returns the square of the given number. So there is really no need to add a comment and explain that. Calculates and returns the square of a number. This is very repetitive and it creates noise in your code. Someone else reading your code, they get distracted with all these unnecessary comments. So use comments to explain whys and hows, not whats. If you have made certain assumptions, you can use comments to explain those assumptions, or you can use them to add notes to remind yourself or other developers to do something in the code. So comments are good, but too much of a good thing is a bad thing. In this tutorial, I'm going to talk to you guys about classes in Python. Classes are extremely important in programming and they're not specific to Python. In fact, a lot of other programming languages do support the notion of classes. We use classes to define new types. For example, so far, you have learned about the basic types in Python like numbers, strings, and booleans. These are the basic or simple types in Python. You also learn about a couple of complex types like lists and dictionaries. While these types are extremely useful, they cannot always be used to model complex concepts. For example, think of the concept of a point or a shopping cart. A shopping cart is not a boolean. It's not a list. It's not a dictionary. It's a different kind of thing. So we can use classes to define new types to model real concepts. Now, in this tutorial, I'm going to show you how to define a new type called point. And this new type is going to have methods for working with points. For example, back to our main program, let's create a list, numbers, 1, 2, 3. You know that here, when we type dot, we get access to these functions or methods available in list objects. Now, similar to this, we're going to create a new type called point. This point is going to have methods like move, draw, get, distance from another point. These are the operations that we can perform on points. So let me show you how to do this. We start by defining a class using the class keyword. And right after that, we give our class a name. Now look at the naming convention I have used here. I've capitalized the first letter here. This is what we call Pascal naming convention. So the convention we use for naming our classes is different from the convention we use for naming our variables and functions. For variables and functions, we always use lowercase letters and we separate multiple words using an underscore. But when naming classes, we don't use an underscore to separate multiple words. Instead, we capitalize the first letter of every word. So in this case, our class has only a single word. If it had multiple words, let's say email client, Look, I've capitalized the first letter of every word. Once again, this is called Pascal naming convention, and it comes from the old Pascal language that you might have heard of. So back to our point class. Here we add a colon, which means we're going to define a block. Now in this block, we can define all the functions or methods that belong to points. For example, we can define a function called move for moving a point. Now note that as soon as we type open parentheses, Pycharm automatically adds self here. This is a special keyword, and we're going to get back to this shortly. So for now, in this method, let's print move on the terminal. Now let's define another method like draw. So define draw. And in this method, let's print draw on the terminal. Now let's remove the indentation. We are done with the definition of our point class. So we need to add 2 line breaks. Okay. So with this class, we defined a new type. With this new type, we can create new objects. So an object is an instance of a class. A class simply defines the blueprint or the template for creating objects, and objects are the actual instances based on that blueprint. So we could have tens or hundreds of points on the screen. These are the objects or the instances. So to create an object, we type out the name of our class and then call it like a function. This creates a new object and then returns it. So we can store that object in a variable. Let's call that point1. There you go. Now when we use the dot operator, look, we have these 2 methods that we defined, draw and move. We also have a bunch of other methods that start with 2 underscores. These are called magic methods. We'll look at them later in the course. So now let's call the draw method of our point object and run our program. So you can see draw is printed on the terminal. Now, apart from methods, these objects can also have attributes, and these attributes are like variables that belong to a particular object. For example, here, after we define point1, we can set point1.x to 10 and point1.y to 20. Now we can easily print out these attributes. Let's print point1.x and run our program one more time. Take a look. So the x coordinate of point1 is 10. Now we can create another object. Let's call that point2. So point2, once again, we type out the name of our class and then call it like a function. Now this object is completely different from the first object. So if we print point2.x, look, we get this attribute error because this point object doesn't have an attribute called x. So each object is a different instance of our point class. Now here we can assign a value to point2.x. Let's set that to 1 and then run our program. So we can see the x coordinate of point2 is 1. So to recap, we use classes to define new types. These types can have methods that we define in the body of the class, and they can also have attributes that we can set anywhere in our programs. You have learned how to create new types using classes. Now there is a tiny problem in this implementation. We can create a point object without an x or y coordinates. Let me show you. So point, we create this object here, and before we set point.x, let's print point.x. Run our program. We get this attribute error that you saw in the last tutorial. So point object has no attribute called x. This is the problem we have here. It is possible to have a point object without an x or y coordinates. And that doesn't really make sense because whenever we talk about a point, we need to know where that point is located. To solve this problem, we use a constructor. A constructor is a function that gets called at the time of creating an object. So here on line 9, when creating this point object, we want to pass values for x and y coordinates, let's say 10 and 20. And with this point object that we get here will have its x and y coordinates initialized. So how do we do this? We need to add a special method in this class called constructor. So on the top, we define a new function. Look at the name of this function, double underscore init double underscore. So init is short for initialize. And this is the function or the method that gets called when we create a new point object. Now press enter. So this automatically adds self in parentheses. We're going to come back to this shortly. Now, right after self, we want to add two extra parameters, x and y. So let's type out x and y. And then in the body of this method, we should read the values passed here and use them to initialize our object. So when we pass 10 and 20, these arguments will be used for x and y parameters. Now to initialize our object, we type out code like this, self.x equals x. And then self.y equals y. What is going on here? This self that you see here is a reference to the current object. So back to line 13, when we create a new point object, self references that object in memory, the same object that we are referencing using this variable. So earlier we typed point.x equals 10. With this code, we set the x attribute of this point object. Now what we have in the constructor is exactly the same. We're using self to reference the current object, and then we set the x attribute to the x argument passed to this function. So using this init method, we can initialize our objects, and we refer to this method as a constructor. This method is used to construct or create an object. Okay, so now let's remove line 14. So we create a point object with these values and then print point.x. Let's run our program. There you go. X is 10. We can also change these values later. So just before printing point.x, we can set point.x to 11 and then run our program. So x is updated. Beautiful. All right, here's an exercise for you. I want you to define a new type called person. These person objects should have a name attribute as well as a talk method. This is a very easy exercise, so you can tackle it in probably a couple of minutes. All right, so first we start with the class keyword. We define this person class. Once again, look at the naming convention I have used here. The first letter of the first word, in this case, the only word, is uppercase. Now, in this class, we define all the methods that we need. Currently, we have only one method, that is the talk method. So define talk. Pycharm automatically adds self. We come back to this shortly. For now, let's just print talk. So this is the body of our person class. We remove the indentation and add two line breaks after defining our classes. Now we can create a person object. Let's call that John. We set it to person. We can call John.talk. Let's run the program. So we get this message, beautiful. But our person objects should also have a name attribute. It doesn't make sense to have a person without a name. So that is when we use the constructor function. So on the top, we add a new method. The name of this method is double underscore init double underscore. So we call this method a constructor. Now, in this method, we need to add another parameter that is name. So we simply set self.name to name. Once again, self references the current object. So we're setting the name attribute of the current object to the name argument passed to this method. With this, we can go back to line 9. And when creating a person object, we pass the name. Let's say John Smith. Now let's print John.name and run our program. There you go. So John Smith is printed on the terminal. Beautiful. So this is all you had to do as part of this exercise. But let's make this program a little bit more interesting. Instead of printing this boring message here, let's print, hi, I am John Smith. So we can use a formatted string with a message like, hi, I am. Now we want to dynamically add the name of this person. How do we do that? Well, look at the parameter of this talk method. As I told you before, every method in our class should have this parameter, self. And this should be the very first parameter of every method, okay? So with this self, we can get reference to the current object. So we can add curly braces and type out self.name. This returns the name attribute of the current person object. With this, we can remove line 10, where we print john.name, and simply call john.talk. Let's run our program. Hi, I am John Smith. Beautiful. Now we can create another person object. Let's say Bob is a new person called Bob Smith. When we say bob.talk and run our program, we get a different message. Hi, I'm Bob Smith. So each object is a different instance of a person class. In this tutorial, I'm going to talk to you guys about inheritance in Python. Inheritance is a mechanism for reusing code. And once again, it's not limited to Python. Most languages that support classes also support inheritance. So let me show you how it works. Let's say we have this dog class with a simple walk method. In this method, we're simply printing the walk message on the terminal. Now, let's say in a real program, instead of just one line of code here, we're going to have 10 lines of code. Now, what if in the future, we want to define another class, let's say cat, and we want to add this walk method there as well. We'll have to repeat all that code in this new class, walk. This is bad because we have repeated or duplicated our code. In programming, we have a principle called DRY, which is short for don't repeat yourself. And here's the reason. Let's say sometime in the future, we discover a problem in our walk method. If we have repeated or duplicated this method in many other places, then we'll have to come back and fix that problem in every single place we have duplicated this code. So that's why in programming, we should not define something twice. So how can we solve this problem? Well, there are different approaches. One approach, which is easier to understand for beginners, is inheritance. And here's how it works. We define a new class called mammal and move the walk method right there. Then we'll have the dog and cat classes inherit that method from their parent, just like how humans inherit certain attributes or behaviors from their parents. It's exactly the same. So on the top, we define a new class. Let's call it mammal. Then we need to move the walk method there. So we select it, cut it using Command and X on Mac or Control X on Windows. And then paste it here. Beautiful. Now we want our dog class to inherit this method from the mammal class. So right after the class name, we add parentheses and then type out the name of the parent class. In this case, mammal. That's all we had to do. So with this, the dog class will inherit all the methods defined in the mammal class. Now there's a tiny problem here. If you look at line 9, there is a red underline here. The reason this is happening is because Python doesn't like an empty class. So right now, our dog class is empty. It doesn't have anything. We either need to add methods specific to dogs, or just to make Python happy, we can use the pass statement, and that basically means nothing. We're telling Python interpreter, hey, pass this line, don't worry about it. But with this, we don't have an empty class, okay? Now, as I told you before, after each class, you should have 2 line breaks. So right now, we only have 1 line break, and that is the reason we have this little warning here. So let's add another blank line. Beautiful. So our dog class is inheriting the walk method from the mammal. We need to apply the same change to the cat class. So we'll have cat inherit from mammal, and then we use the pass statement here. With these changes, now we can create either a dog or a cat object. Let's say dog1. We set it to a dog object. And when we type dot, look, we have the walk method that is defined in the mammal class. We can easily call it. Let's run our program. There you go. We see the walk message. So both the dog and cat classes are inheriting all the methods defined in their parent class. Now here we can add methods specific to dogs. For example, we can define a method called bark and then print bark. Now we don't need the pass statement because we already defined one method in our dog class. So now when we type out dog1 dot, look, we have 2 methods. One is the walk method that we inherited and the bark method that we just defined in the dog class. Similarly, we can add a method specific to a cat. For example, we can define a method called be annoying. Yeah, I hate cats. So let's print annoying. Now when we create a cat object, let's remove that, cat1, and type out cat1 dot, we have these two methods, walk and be annoying. So these are the basics of inheritance in Python. Now, there's more to this that really goes beyond the scope of this beginner's tutorial. If you're interested to learn more about inheritance and other mechanisms for reusing code, I encourage you to get my complete Python course. In this tutorial, I'm going to talk to you guys about modules in Python. A module in Python is basically a file with some Python code. And we use modules to organize our code into multiple files, just like sections in a supermarket. When you go to a supermarket, there are different sections for fruits, vegetables, cleaning products, and so on. We don't have one section with all the products in the supermarket. We have the same concept in programming. So instead of writing all of our code, instead of writing all the functions and classes in app.py, we want to break up our code into multiple files. We refer to each file as a module. With this, not only is our code better organized and structured, but we'll also have the ability to reuse our code. For example, over here in app.py, I've defined two functions for converting weight from pounds to kilograms and vice versa. Now we can take these two functions and put them in a separate module called converters. And then we can import that module into any program that needs these converter functions. Let me show you how to do this. So let's open up our project panel and right-click the project, go to new and add a new file. We're going to call this file converters.py. Then we go back to app.py, select all this code, cut it, and then paste it into our new module, converters.py. With this, we have cleaned up our app module. It's not bloated with different functions. So as we write more functions and classes, we put them in their corresponding modules. A module should contain all the related functions and classes, okay? Now, you want to import the converters module into our app module, and that is really easy. On the top, we write import converters without the extension. So we don't add .py. We only type out the name of the file. Let me close the project panel. Now, this converters is an object, so we can use the dot operator to access its members. So currently we have defined these two functions inside of our module, kilogram to pounds and pounds to kilogram. So we can easily call one of these functions. Let's pass 70 kilos, get the result and print it out. Run our program. So that is 155 pounds. Now there's also another syntax for importing modules. Let me show you. So instead of importing the entire module, we can import specific functions from that module. Here's how it works. We type out from, then we add the name of our module, so converters, import. Now here, if you press Control and space, you can see the list of all the functions defined in this module. So here we can grab one of these functions, let's say kilogram to pounds, and with this we can directly call this function just like a function defined in this file, app.py. Compare what we have on line 4 with what we have on line 6. On line 6, we'll have to prefix this function call with the name of an object, converters. So we have to type converters dot, and then we'll be able to access this function. In contrast, when we import a specific function from our module, then we can easily call that function without prefixing it with the module name. So here's what you need to take away. We use modules to better organize our code. Instead of writing all the code, instead of writing all our functions in one file, we break up our code across multiple files. Each file is called a module, and it should contain all the related functions and classes. Then we can import a module into another module. In this case, we are importing the converters module into our app module. And as you saw, there are two ways to import a module. We can import the entire module, and then we'll get an object with the same name as the module. So we can type converters dot, and then we'll be able to access all the functions and classes defined in this module. The other approach is to import a specific function or class from a module using the from import statement. Now here's your exercise. Earlier in the course, we had an exercise for finding the largest number in a list. So here on the top, we have a list of numbers. Initially, we set max to the first number in this list. Then we loop through this list, get each number. If the current number is greater than max, then we reset max. And finally, when we're done with our loop, we print max on the terminal. Now here's what I want you to do. This code currently has no organization. We don't have any functions. We don't have any modules. We wrote all the code in app.py. And that is okay for small programs, but as your programs grow, you need to properly organize your code into functions, classes, and modules. So as part of this exercise, I want you to write a function, call it find max. This function should take a list and return the largest number in that list. Now, after you do this, go ahead and put this function in a separate module. So extract it from here and put it in a module called utils. So in this module, we're going to have a bunch of utility functions. Okay? Then import the utils module into the current module and call this function. Finally, get the result and print it on the terminal. This is a fantastic exercise to teach you how to properly organize your code. So go ahead and spend a couple of minutes on this exercise. So the first step is to define a function called find max. So on the top, I'm going to define a function, find max. This function should take a list of numbers. So we add a parameter called numbers. Now inside of this function, we want to have these few lines. This is the algorithm for finding the largest number in a list. We don't want to bring the first line because this is where we create a list. So somewhere in our program, we're going to create this list and then pass it as an argument to find max function. Okay, so let's go ahead and grab these few lines, cut them, and put them inside of find max function. All right, so we find the largest number in this list. Finally, we need to return it. So return max. So here's our function. Now we need to move this into a separate module. So let's go to the project panel, right-click the project, and add a new file. We can also add a new Python file. It's the same. Let's call that utils. So if you add a new Python file, Pycharm automatically adds .py extension. But if you go to new file, we'll have to explicitly type out .py. So make sure to get the extension right. Now, back to app.py. Let's cut this code and paste it into this new module. Okay, beautiful. Now we go back to app.py and import our new module. We can either import the entire module, so import utils, and then access individual functions. So we can call utils.findMax, or we can explicitly import this function from the utils module. It doesn't really make a difference. So we could type from utils, import, find max. And then we don't need to prefix this with the name of its object. So we simply call find max. Now we need to call this after we initialize our list. So first we need to define the list of numbers. Then we pass that list as an argument to find max. We get the result, which is max. And finally, we print it on the terminal. Let's go ahead and run our program. So the largest number in this list is 10. Beautiful. Now, one last thing before we finish this tutorial. Here we have this little warning under max. And the tooltip says shadows built-in name max. The reason we see this is because in Python, we actually have a function called max, and it does the exact same job as our find max function. So this is actually built into Python. But I ask you to do it as an exercise because it's a great exercise for beginners. Now, back to the warning. This warning is basically telling us that we are overwriting the built-in max function in Python. So we're changing the meaning of this function, and this is considered a bad practice. Let me show you what I mean. So let's comment out what we have on line 4. By putting a hash sign here, we can also use a shortcut, command and slash on Mac, or control and slash on Windows. So now this line is commented out. Look at the color of max here. It's purple. It's the same color as print. And this is the color used to identify the built-in functions. So now we can call this function and give it our list of numbers. Run our program. We get the exact same result. However, if we bring this line back, once again, we can use the same shortcut, that is command and slash on Mac or control slash on Windows. Now we are redefining max. So up to this line, max used to be a function, but after line 4 is executed, max is set to an integer. That is the largest number in this list. So we'll no longer be able to call it on line 5. Let's run our program and see what happens. So there you go. We get this type error. Int object is not callable because max is now an integer. It's not a function, so we cannot call it. So to solve this problem, we can rename this variable to something else. So right click here, go to refactor and rename this to maximum. So you can see the warning is gone. Also, we have the same warning in our utils module. So here we're redefining max. And as I told you before, this is a bad practice. We're changing the meaning of built-in functions in Python. So let's rename this as well. I'm going to use the shortcut that is Shift and F6. There you go. And here we can change this to maximum. Enter, done. In this tutorial, we're going to talk about packages in Python. Packages are basically another way to organize our code. So currently we have only 3 files or 3 modules in our project, but a real project can contain hundreds or even thousands of modules. We don't want to add all those modules here because over time, this directory will get bloated with so many files. So a better approach is to organize related modules inside of a package. So a package is a container for multiple modules. In file system terms, a package is a directory or folder. So in our project, we can add a new directory, and in that directory, we can add all the related modules. As a metaphor, think of a mall. When you go to a mall or a shopping center, there are different sections for men's, women's, and kids' clothing. So that is like a package. Now, when you go to the men's section, there are different areas for different kinds of products. We have a section for shoes, t-shirts, jackets, and so on. So each of these is like a module. So in this tutorial, I'm going to show you how to create and use packages in Python. Here in our project panel, right-click the project and add a new directory. Let's call this directory e-commerce. So we're going to create a package called e-commerce. And in this package, we're going to have all the modules related for an e-commerce application. For example, we can have modules for sales, shipping, customer service, and so on. So let's go ahead. Now, here we have an empty directory. In order to convert this to a package, we need to add a special file in it. So right-click this directory and add a new Python file. Call that file $init. This is a special convention in Python. When Python interpreter sees a file with this name in a directory, it treats this directory as a package. We also have a shortcut for that in Pycharm. So let me delete this directory and start again. So delete. Once again, right-click the project and go to new. But instead of creating a new directory, we can create a new Python package. Let's call our package e-commerce. As you can see, Pycharm automatically creates this file for us, so we don't have to manually create it. Okay. Now, in this package, let's add a new module. So a new Python file. Let's call it shipping. Okay. Now, in this module, we want to add a function for calculating the shipping cost. So define calculate underline shipping. And don't worry about parameters or the implementation. We simply print calculate underline shipping. Now let's say we want to import this shipping module into our app module. With this new structure, this shipping module is now part of the e-commerce package. So we cannot import it directly. We have to start from the e-commerce package. Okay. So back to app.py. Once again, there are 2 ways to import this module. We can import the entire module, or we can import one of its functions or classes. So let me show you both approaches. First, we're going to import the entire module. Import. Now, what is the name of our package? That is e-commerce, right? So e-commerce dot shipping. So instead of typing import shipping, we type import e-commerce dot shipping. We have to prefix it with the name of its package. Now to access any of the functions or classes in this module, we'll have to type out e-commerce e-commerce.shipping dot, and there you go. Now we can access the calculate shipping function. So let's go ahead and run our program. We see this message printed on the terminal. Beautiful. However, with this approach, every time we want to call one of the functions in this module, we'll have to prefix it with e-commerce.shipping. That is very verbose. So when working with packages, we often use the second approach using the from statement. So we can type from e-commerce.shipping import calculate shipping. Now we don't have to prefix this function with e-commerce.shipping, and we can call it multiple times in this module. So our code is a little bit shorter. But what if you want to use multiple functions in this shipping module? We can either import them all here, so calculate shipping, comma, let's say calculate underline tax, or we can import the entire module and then access all the functions or classes in that module. So let me revert this back. To import the entire module, we type from e-commerce, so we remove .shipping. So from this package, import the shipping module. Now this shipping module is an object, so we can access all the functions and classes defined here using the dot operator. So shipping dot, there you go, calculate shipping. So to recap, when using the from statement, we can either start from the package and import a specific module, or we can start from package dot module and then import a specific function like calculate shipping. So this was the basics of using packages in Python. As I told you before, packages are extremely important, especially when you want to work with a framework like Django. We use Django for building web applications with Python, and I'm going to show you that later in this course. So in Django, we have quite a few packages, and each package contains several modules. So make sure to watch the tutorials about modules and packages one more time. Otherwise, you're going to get confused later when we get to Django. In this tutorial, I'm going to talk to you guys about the built-in modules in Python. So Python comes with a standard library that contains several modules for common tasks such as sending emails, working with data and time, generating random values and passwords, and so on. There are so many modules already built into Python, and that means there is already lots of functionality that we can reuse. We don't have to code all of that from scratch. Let me show you where you can find this standard library. So open up your browser and search for Python 3 module index. Make sure to add the version number because the modules in Python 2 are different from modules in Python 3. So here we search for Python 3 module index, and the first page here, you can see it's Python module index for Python 3. Let's go ahead. So these are all the modules built into Python. For example, we have modules for working with data and time. We have modules for sending emails, for encoding values. There are so many modules here. Now, the explanation of all this is beyond the scope of this course. That really requires its own course because we have so many modules here. But don't let this list intimidate you. This is not something that you need to learn right now. As you work with Python, as you build more applications, gradually you will get more familiar with various modules here. In fact, nobody knows all the modules in Python standard library. Everybody knows some modules based on the applications they have built. So in this tutorial, I'm going to show you how to use one of the built-in modules for generating random values. So on the top, we import the random module. Now, because random is a built-in module, we don't need to have a file here called random.py. So Python interpreter knows that random is a built-in module, and it knows where to find it. Now, if you're curious where this random module is stored on the disk, let me show you. So here in the project panel, expand external libraries, then expand Python 3, and then one more time, Python 3.7 library root. So this is a folder somewhere on your computer. In this folder, we have all the built-in modules in Python. So if you scroll down, you should be able to find the random module. There you go. It's right here. So random.py. You can open this, and this shows you the source code of this module. There you go. Now, in this tutorial, we don't want to worry about that. So let's go back to our app.py and use this module to generate random values. So when we import this module, now we have this object random. So we can use the dot operator to access its methods. One method that is very useful here is the random method. And every time we call it, it generates a random value between 0 to 1. So here we can do a for loop. Let's say for I in range 3. So just to refresh our memory, we are using the range function to create a range object. We can loop through this range object, and in each iteration, this object will spit out a value. So with this for loop, we can execute this code 3 times. Now let's indent this. Okay. And finally, let's print the result. There you go. So we can see that in each iteration, we get a new random value between 0 to 1. Now, what if we want a random value for a particular age? Let's say random values between 10 to 20. Well, there is another method here, randint. We pass 2 arguments here to specify our range. Let's say 10 and 20. Run our program one more time. Now we have the numbers 20, 13, and 18. If we run our program one more time, we get different values. So 20, 19, 11, one more time. Look. We also have another powerful method for randomly picking an item from a list. Let's say we have a list of team members and we want to randomly pick someone as the leader. Let me show you how to do that. So we define the list of team members. We set it to John, Mary, Bob, and Mosh. Now we can call random the choice and pass our members list. This method randomly picks an item from this list and returns it. So we can store the result in leader and then print it on the terminal. Let's run our program. So now the leader is Mary. If we run our program one more time, this time it's Mosh. Now it's Mosh again, one more time. It really likes Mosh. Now it's Bob. You got the point. So the random module is very powerful and it has a lot of applications. Now here's a very cool exercise. I want you to write this program to roll a dice. So every time we run this program, we get different values. Now we have 3 and 1. Next time we get 3 and 6. One more time, 5 and 6, 4 and 3, double 1. That's a very cool exercise. So before we get started, I want you to pay attention to a few things. I want you to define a class called dice. In this class, we're going to have a method called roll. So every time we call this method, we get a tuple. A tuple, remember, is a list of values, but that list cannot be changed. We cannot add a new item to it. We cannot remove it. So it's like a read-only list. So every time we call the roll method, we should get a tuple of 2 random values. So go ahead and do this exercise. You'll see my solution next. All right, we start by importing the random module on the top. Then we define a class called dice, colon. In this class, we want to have a method called roll. So define roll, parentheses. This automatically adds self. Now, in this method, we want to generate 2 random values between 1 to 6. So we call random.randint and pass 1 and 6. So this generates the first number. We can put that here. Now let's call this one more time. So I'm going to copy what we have on line 5, put it here, and change this variable to second. So we have 2 variables, first and second, with 2 random values. Finally, we need to return them in a tuple. So return parentheses instead of square brackets, first and second. Now in Python, when you want to return a tuple from a function, you don't have to add this parentheses. So you can simplify your code and Python will automatically interpret this as a tuple. Okay? So we're done with the definition of our class. We remove the indentation and add 2 line breaks. Now we create an object of this type. So we set dice to dice. Next, we roll the dice, so dice.roll, and print the result on the terminal. That's all you had to do. Let's run this program. So now we get 2 and 5. Let's run it one more time. 3 and 2, 1 and 1. Beautiful. Now we have this little warning here that says expected 2 blank lines, found 1. Once again, this is coming from PEP 8. PEP is short for Python Enhancement proposal. We have so many Python enhancement proposals or PEPs. PEP 8 is a very famous one. And in this document, we have all the best practices for formatting our code. So PEP 8 says that after we define our classes, we should have 2 line breaks. We already done that. So the reason this is complaining is because we have 1 line break before the class. So let's add 1 more line break. Now Pycharm is happy. So basically Pycharm is following all the best practices defined in PEP 8. Now you don't have to memorize any of these best practices. As you code in Pycharm, Pycharm gives you little warnings, and gradually you will learn how to properly format your code so it's readable by other people. In this tutorial, I'm going to show you how to work with directories in Python. So here on Python 3 module index, you can see we have a module called pathlib, which provides an object-oriented file system path. That basically means it provides classes that we can use to create objects to work with directories and files. So if you click here, you can see how this module works. You can see all kinds of examples. For example, here under basic usage, you can see this is how we import the path class from the pathlib module. Let me zoom in so you can see clearly. Okay, so look, from pathlib, that's our module, import path. Note the naming convention. P is capitalized. That means path is a class. So we need to create an instance of this class, as you can see right here. Now there is so much documentation here. You can read this on your own, but let me quickly show you a few examples to help you get started. So back in Pycharm, on the top, from the pathlib module, let's import the path class. Now we need to create a path object to reference a file or a directory on our computer. So there are basically 2 ways to do this. We can use an absolute path or a relative path, which basically means a path starting from the current directory. For example, if you want to reference this e-commerce directory in our project, we can use the relative path. So we start from the current directory and then go somewhere else. With absolute paths, we start from the root of our hard disk. For example, if you're on Windows, you might have an absolute path like this: C drive / program files / Microsoft. So these are directories in C drive. On Windows, we use a / to build a path. If you're on Mac or Linux, your paths look a little bit different. So instead of a /, we have a /. Let's say user /local /bin. So these are examples of absolute paths. In this tutorial, we're going to work with a relative path to work with this e-commerce directory that we have in our project. Now, if you didn't create this directory earlier, simply right-click on the project and then go to New Directory. Okay, so let's close this panel. We create a path object. Now, if we don't pass an argument here, this will reference the current directory. Alternatively, we can pass a string. In this string, we can add a file or a directory. Let's say the e-commerce directory. Now this returns a path object, so we store it here. Now this path object has a few interesting methods. For example, we can check to see if a path exists by calling the exist method. This simply returns a Boolean, so let's print it on the terminal. There you go. So this path exists, but if we change this to, let's say, e-commerce 1 and run our program, we get false. We can also create a new directory. For example, let's change this path to emails. Now, when we run this program, obviously we don't have this directory, but we can create it by calling the mkdir method. So make directory. Let's run our program. All right. This method returns none, which basically means it doesn't return any values. Now, if you look at the project panel, you can see here we have a new directory called emails. We can also delete this directory. So instead of mkdir, we call rmdir, which is short for remove directory. Let's go ahead. Now you can see that directory is gone. We can also find all the files and directories in a given path. That is very useful if you want to write a little program to automate something. For example, you can iterate over all the spreadsheets in a directory, open them, and process them. Let me show you. So first we change the path to the current directory, and then we call the glob method. With this method, we can search for files and directories in the current path. So as the first argument, we need to pass a string that defines a search pattern. We can type an asterisk, and that means everything, all files and all directories. We can optionally add an extension. So to get all the files, we use star dot star. With this pattern, we'll only get the files in the current directory, but not the directories. We can also search for all the Py files or all the Excel spreadsheets, anything. So let's search for all the Py files in the current directory. Now, when we run our program, we get this generator object. Generator objects are kind of an advanced topic, and they are beyond the scope of this beginner's Python course. But for now, all you need to know is that we can iterate or loop through these generator objects. So instead of printing this generator object, let's just iterate over it using a for loop. So for file in the generator object that is returned from the glob method, let's print file. Run our program. There you go. So these are all the Py files in my current directory. This could be different on your machine if you didn't follow the exercises I gave you earlier. For example, this utils.py, we created this as part of one of the exercises earlier in this course. So don't worry if the files you see here are different on your machine. So we can use the glob method to search for files using a pattern. We can also get all the files and directories in the current path. So we just use one asterisk, run our program, take a look. So we have this e-commerce directory. We have notes.txt. This is a file I added earlier just to write notes as part of my presentation. So you're not going to have this file. We also have a bunch of other directories and files. Even though Python's standard library is very comprehensive and has so many modules for common tasks, it's not complete by any means. That's why we have this directory called Python Package Index or PyPI. And in this directory, you can find thousands of packages for doing awesome things. These are the packages that people like you and I have built as part of their projects, and then they published it in this directory for other people to use. So that's why we have a fantastic community in Python. There are so many Python developers out there, and there's so many packages right in front of us to reuse in our programs. Let's say you want to send text messages in your programs. You don't have to build this functionality from scratch. You can simply come to pypi.org and search for SMS. As you can see, there are so many projects or packages that give you this functionality. Of course, not every package, not every project is complete or bug-free. Some of them are still in development or they have bugs. But if you look around, I'm pretty sure for any kind of functionality you can imagine, there is a good, reliable, and well-documented package for you. In my complete Python course, I will show you some of the most useful packages on PyPI. For example, you will learn how to access the information on Yelp.com in your programs. So you can write a program and search for businesses registered on Yelp. Let's say you want to search for the best barbers in New York City. I will show you how to do that. You also learn about a technique called web scraping, which means you can build an engine and have that engine browse a website and extract information from HTML files. This is the same technique that Google does to index various websites. So they have several engines or web crawlers. These crawlers are continuously looking at various websites and extracting information from their pages. When you publish a blog post, Google's web crawler finds the title of your post, its keywords, and so on. So I'm going to show you how to do that with Python. We'll also look at browser automation, and this is extremely powerful because you can automate testing of your web applications. So you might get a job as a test engineer, and your daily job is to browse a website, click here and there, fill out this form, that form, and ensure that the website is functioning properly. You can automate all of that with a powerful Python package called Selenium, as I have shown in my complete Python course. Now, in this tutorial, I'm going to show you how to install packages from pypi.org. So here on pypi.org, let's search for OpenPyXL. This is a package that we use for working with Excel spreadsheets. So let's search for this package. There you go. So currently it's at version 2.5. On the top, you can see this instruction, pip install OpenPyXL. This is the command that we need to type into a terminal window to install this package into our program. So back to Pycharm. Here on the status bar, we can open up a terminal window for executing various commands. So let's open it. Now, if you're on Windows, you're probably going to see something different instead of this $sign. Don't worry about that. Just execute this command. I'm going to show you. So pip install open PyXL. Make sure to spell everything properly. So pip is the tool that comes with Python installation, and we use it to install or uninstall packages registered on pypi.org. So here we're using pip to install this package, open PyXL. Enter. Let's go ahead with that. It's going to take a few seconds. Okay, done. Now we can import this package and its modules just like the built-in modules in Python or the modules that we have in our project. Now, if you're curious where this package is stored on disk, let me show you. So open up the project panel and then expand external libraries. Next, expand Python 3 and then expand site packages. This is where all these packages that we install with pip are stored. So here we have open PyXL. You can open this. In this folder, we have another folder called cell. Now, look what we have here. We have this init py. Earlier, I told you that whenever we add this file to a folder, Python treats that folder as a package. So cell is a package, and in this package, we have these modules, cell, interface, read-only, and text. So as you can see, this package, OpenPyXL, has several sub-packages like cell, chart, chart sheet, and so on. And in each package, we have several modules. In the next tutorial, I will show you how to work with Excel files. So we have covered all the core concepts in Python. I hope you learned a lot. Please support my hard work by liking this video and sharing it with others. And be sure to subscribe to my channel for more tutorials like this. Next, we're going to work on our first Python project that involves automation. You're going to write a Python program that can process thousands of spreadsheets in under a second. Are you excited? Let's get started. In this tutorial, I'm going to show you something really awesome you can do with Python. You're going to learn how to process spreadsheets. And this is extremely valuable in situations where you have hundreds or thousands of spreadsheets that need to be updated. If you want to do this by hand, it may take hours, days, weeks, or even months. You can simply build a Python program in less than half an hour and have that Python program automatically process thousands of spreadsheets in under 1 second. So here we're going to work on this Excel spreadsheet. You can download this below this video. In this spreadsheet, we have 3 columns: transaction ID, product ID, and price. Now, don't worry about the 4th column yet. So in this spreadsheet, we record all kinds of transactions, but let's say due to an error, it could be a human error or a system error, the price that we have here is wrong. Let's say we need to decrease this by 10%. If you want to do this manually, we'll have to come back here and add a formula. So we type out equal sign. Let's say we want to recalculate the value of this cell, that is C2. So we'll have to get that and then multiply it by 0.9. So that is like the 90% of the original price. We are reducing the price by 10%. Now when we hit enter, you can see the updated price. Next, we'll have to come back here, select the cell, and then apply the same formula to all the other rows. Now, what if we have thousands of rows here? We'll have to scroll up and down. This is going to be very tedious. So we're going to write a Python program that will do this for us. It's going to automate this process. And not only that, it will also add this beautiful chart right here. Once again, if you want to open up hundreds or thousands of spreadsheets and add a chart to each one, this is going to take at least a week or 2. Our Python program is going to do all of this in a matter of seconds. So let's get started. All right, the first thing I want you to do is to download this transactions file and add it to your project. I'll put the link below this video for you to download. So if you're wondering how to put this in this project, you can simply right-click the project. And if you're on Mac, you have this item, Reveal in Finder. If you're on Windows, you should see something like Reveal in Explorer or File Explorer or Windows Explorer. Whatever it's called, when you click this, this opens up the directory on your machine where this project is stored. So you can simply copy and paste the transactions file right here. Now, here on the top, first we need to import the OpenPyXL package. So import OpenPyXL. We can give it an alias to make our code shorter. So as Excel. This is not required, but it just makes our code a little bit cleaner. Let me show you. So now instead of typing openpyexcel dot, we type xl dot. Okay, so that's an alias for this package. Now in this package, we have a function for loading an Excel workbook. So let's call load workbook. And as the argument, we pass transactions.xlsx. So this will load our Excel workbook and return a workbook object. Okay. Now, if you open this workbook, you can see you have only one sheet, and that is called sheet 1. So to access that, we use square brackets and specify the name of the sheet. That is sheet 1. Make sure to spell this with a capital S because this is case sensitive. If you don't spell it properly, you're going to get an error. So this returns our first sheet. Now in this sheet, we have various cells. So next you need to learn how to access a particular cell. And that is very easy. Back to Pycharm. With this sheet object, we can use square brackets and give the coordinate of a cell. The coordinate is the combination of the column and the row. For example, this cell, its coordinate is A1. So back to Pycharm, here we can type A1 and this returns our first cell. There is also another approach to get a cell. Instead of using square brackets with a string, we can use the cell method of the sheet object. So sheet.cell, we pass the row and the column. So row 1 and column 1. This returns the exact same cell. Now let's print the value of this cell. So cell.value and run our program. So the value is transaction ID. Beautiful. So now we need to iterate over all these rows. And for each row, we need to get the value in the third column. That is the price. We'll get that and then multiply it by 0.9. So first we need to know how many rows we have in this spreadsheet. We can get that from the sheet object. So sheet has an attribute called max_row. Let's print this. So in this sheet, we have 4 rows and you can verify that here. So we have a total of 4 rows. So we need to add a for loop that would generate the numbers 1 to 4. So let's delete this print statement and add a for loop for row in. We're going to use the range function to generate a range of numbers starting from 1 all the way to sheet.max_row plus 1. The reason we're adding 1 to this is because, as I told you before, this range function would generate numbers starting from this value all the way to this value, but it will not include the second value. So currently max row returns 4. If we use range of 1 to 4, this will generate the numbers 1, 2, and 3, but not 4. So to include 4, we need to add 1 to it. Let's go back here. So we type sheet.max_row plus 1. Now before going any further, let's just print row and make sure our program is working up to this point. So let's run this. We get the numbers 1 to 4. Beautiful. So now we can easily get the cells in the third column. However, we don't really want this first cell, that's the heading. So technically we want to ignore the first row. Back here, we want to change our range function and start from 2. Okay. Now we're going to use sheet.cell to get access to the cell at this row. And the column should be 3. We get a cell object. Let's print its value and make sure we're on the right track. So run our program. These are the values we get: 5.95, 6.95, and 7.95. These are the values in the third column. Beautiful. Next, we need to multiply each value by 0.9. So instead of printing cell.value, we multiply it by 0.9. And this is the corrected underlying price. So this is the mistake we're going to fix with our program. Now we need to add a new cell to our worksheet. So we want to add all the corrected prices in a new column. We could also overwrite the values in this column, but in this tutorial, I'm going to show you how to add a new column. So using the same method, now we need to get a reference to the cell in the given row, but in the fourth column. So we call sheet.cell and pass row and 4 as the arguments. Once again, this returns a cell object. Let's store that in a separate variable and call it corrected underline price underline cell. So note that my variable names are very descriptive. There is no guesswork. We have corrected price, which holds the actual value, and we have corrected price cell, which is a cell object in this spreadsheet. Next, we need to set the value for this cell. So we set corrected price cell dot value to this corrected price. With these few lines, we can easily update our spreadsheet. But first, we need to save it. So after our for loop, we call workbook.save. Now let's save this in a new file. So we don't want to accidentally overwrite the original file in case our program has a bug. So I'm going to call that transactions2.xlsx. Now finally, let's run our program. So you can see that happened in a split of a second. Now here we have a new file, transactions2. When we open this, we get something like this. So you can see we have this fourth column with the updated prices. Beautiful. So half of the problem is solved. Now we need to add a chart here. To add a chart, we need to import a couple of classes on the top. So after this import statement, let's type out from openpyexcel.chart import bar chart, comma, reference. So let's see what's going on here. In this package, we have a module called chart. And from this module, we're importing two classes, bar chart and reference. Again, look at the naming convention used here. The first letter of every word is capitalized. Also, it's better to add a line break after our import statements to make our code cleaner. So before we save our workbook, we need to add a chart to the current sheet. First, we need to select a range of values. For this exercise, I'm going to select the values in the fourth column. So all the values in rows 2 to 4. These are the values I'm going to use in our chart. Now, in this particular example, it doesn't really make sense to add a chart per transaction, but that doesn't really matter. We just want a bunch of numbers to create a chart. So after our for loop, we're going to use the reference class to select a range of values. Now, the first argument in the constructor is the sheet. So we pass our sheet here. Then we add 4 keyword arguments. The first one is min underline row. We set this to 2. The second one is max underline row. We set this to the maximum row in this sheet. That is sheet.max underline row. So we want to select the cells in row 2 to 4. Okay. Now to make this code a little bit cleaner, I'm going to put this on a new line so you can see clearly. Now this is going to select all the cells in all the columns in these rows. That's not what we want. We only want the values in the fourth column. So back here, we need to set a couple more keyword arguments. Min underline col or column, we set that to 4. And also max underline col, we set that to 4 as well. So we're limiting the range of cells we're selecting to the fourth column. Okay. Now we're creating an instance of the reference class. Let's store the result in a variable called values. So this values object will have all these values in the fourth column. Now we're ready to create a chart. So we create an instance of the bar chart class and store it in this object. Next, we call chart.add underline data and pass our values. That is pretty straightforward. Finally, we need to add this chart to our sheet. So we call sheet.add underline chart and pass this chart object. We should also specify where we want to add this chart. Let's say we want to add it here on row 2 after the fourth column. So the coordinate of this cell is E2, and this is going to be the top left corner of our chart. So as the coordinate, I'm going to pass E2. That's all we had to do. Done. Let's run our program one more time. Beautiful. Let's open up the updated workbook. And here's the end result. So right after the fourth column, we have this beautiful chart. Now we could take this to the next level. We could add a legend here. We could change the color of these bars. We could even use a different kind of chart. It doesn't have to be a bar chart. So to learn more about this, you can read the documentation for OpenPyXL. So our program is complete, but our code is dirty. It's not clean. It's not organized. We don't have any functions here. We have written all the code in app.py. So let's go ahead and organize this code like a professional software developer. So on line 4, we're loading our workbook. Then we're getting a reference to the first sheet, but we don't really need these 2 lines here. This was purely for demonstration to show you how you can access a cell. So let's delete these unnecessary lines. This is a very important practice. As you're coding, always look at your code, always review it. See if you have some code that is not used. Always delete those. Okay, next we're iterating over all the rows, fixing the prices, and then we select these values to add a chart, and finally we save the workbook. Now, if we were going to use this to automate the process of updating thousands of spreadsheets, this program wouldn't work because it's only relying on this file. So we want to reorganize this code and move it inside of a function. This function should take the name of the file as an input. So let's define a function. Let's call it process underline workbook. It gets a file name. Now we move all the code inside of this function. So let's select everything and then press tab. Beautiful. Now back to our function. Instead of loading this transactions file, we're going to load this file name. That's better. Also, now that our program is working properly, there is really no need to store the result in a separate file. So here we can simply overwrite the same file. So let's pass file name. That is the end of our function. So now we have this reusable function. We can simply reuse this to process thousands of spreadsheets. Earlier in this Python course, you learned how to find all the files in a directory. So you can get each file in a directory and pass the name of the file to this function. This function will go ahead and update that spreadsheet in just a second or less. So that was just one example of using Python to automate repetitive, boring tasks that waste your time. But automation is not just about processing Excel spreadsheets. There are so many things we can automate. Here's a question for you. What do you want to automate? How do you want to use Python to make your life easier? Use the comment box below and let me know. I love to hear about your ideas. Next, we're going to work on a project that involves machine learning, which is a subset of artificial intelligence. Are you excited? Let's get started. In this section, you're going to learn about machine learning, which is a subset of AI or artificial intelligence. It's one of the trending topics in the world these days, and it's going to have a lot of applications in the future. Here's an example. Imagine I ask you to write a program to scan an image and tell if it's a cat or a dog. If you want to build this program using traditional programming techniques, your program is going to get overly complex. You will have to come up with lots of rules to look for specific curves, edges, and colors in an image to tell if it's a cat or a dog. But if I give you a black and white photo, your rules may not work. They may break. Then you'll have to rewrite them. Or I may give you a picture of a cat or a dog from a different angle that you did not predict before. So solving this problem using traditional programming techniques is going to get overly complex or sometimes impossible. Now, to make the matter worse, what if in the future I ask you to extend this program such that it supports 3 kinds of animals: cats, dogs, and horses? Once again, you'll have to rewrite all those rules. That's not going to work. So machine learning is a technique to solve these kind of problems. And this is how it works. We build a model or an engine and give it lots and lots of data. For example, we give it thousands or tens of thousands of pictures of cats and dogs. Our model will then find and learn patterns in the input data, so we can give it a new picture of a cat that it hasn't seen before and ask it, is it a cat or a dog or a horse? And it will tell us with a certain level of accuracy. The more input data we give it, the more accurate our model is going to be. So that was a very basic example. But machine learning has other applications in self-driving cars, robotics, language processing, vision processing, forecasting things like stock market trends and the weather, games, and so on. So that's the basic idea about machine learning. Next, we'll look at machine learning in action. A machine learning project involves a number of steps. The first step is to import our data, which often comes in the form of a CSV file. You might have a database with lots of data. We can simply export that data and store it in a CSV file for the purpose of our machine learning project. So we import our data. Next, we need to clean it. And this involves tasks such as removing duplicated data. If you have duplicates in the data, we don't want to feed this to our model because otherwise our model will learn bad patterns in the data and it will produce the wrong result. So we should make sure that our input data is in a good and clean shape. If there are data that is irrelevant, we should remove them. If they're duplicated or incomplete, we can remove or modify them. If our data is text-based, like the name of countries or genres of music or cats and dogs, we need to convert them to numerical values. So this step really depends on the kind of data we are working with. Every project is different. Now that we have a clean data set, we need to split it into two segments, one for training our model and the other for testing it to make sure that our model produces the right result. For example, if you have 1,000 pictures of cats and dogs, we can reserve 80% for training and the other 20% for testing. The next step is to create a model, and this involves selecting an algorithm to analyze the data. There's so many different machine learning algorithms out there, such as decision trees, neural networks, and so on. Each algorithm has pros and cons in terms of accuracy and performance. So the algorithm you choose depends on the kind of problem you're trying to solve and your input data. Now, the good news is that we don't have to explicitly program an algorithm. There are libraries out there that provide these algorithms. One of the most popular ones, which we're going to look at in this tutorial, is scikit-learn. So we build a model using an algorithm. Next, we need to train our model. So we feed it our training data. Our model will then look for the patterns in the data. So next, we can ask it to make predictions. Back to our example of cats and dogs, we can ask our model, is this a cat or a dog? And our model will make a prediction. Now, the prediction is not always accurate. In fact, when you start out, it's very likely that your predictions are inaccurate. So we need to evaluate the predictions and measure their accuracy. Then we need to get back to our model and either select a different algorithm that is going to produce a more accurate result for the kind of problem we're trying to solve, or fine-tune the parameters of our model. So each algorithm has parameters that we can modify to optimize the accuracy. So these are the high-level steps that you follow in a machine learning project. Next, we'll look at the libraries and tools for machine learning. In this lecture, we're going to look at the popular Python libraries that we use in machine learning projects. The first one is NumPy, which provides a multi-dimensional array. Very, very popular library. The second one is Pandas, which is a data analysis library that provides a concept called data frame. A data frame is a two-dimensional data structure similar to an Excel spreadsheet. So we have rows and columns. We can select data in a row or a column or a range of rows and columns. Again, very, very popular in machine learning and data science projects. The third library is matplotlib, which is a two-dimensional plotting library for creating graphs and plots. The next library is scikit-learn, which is one of the most popular machine learning libraries that provides all these common algorithms like decision trees, neural networks, and so on. Now, when working with machine learning projects, we use an environment called Jupyter for writing our code. Technically, we can still use VS Code or any other code editors, but these editors are not ideal for machine learning projects because we frequently need to inspect the data, and that is really hard in environments like VS Code and Terminal. If you're working with a table of 10 or 20 columns, visualizing this data in a terminal window is really, really difficult and messy. So that's why we use Jupyter. It makes it really easy to inspect our data. Now, to install Jupyter, we're going to use a platform called Anaconda. So head over to anaconda.com/download. On this page, you can download Anaconda distribution for your operating system. So we have distributions for Windows, Mac, and Linux. So let's go ahead and install Anaconda for Python 3.7. Download. All right, so here's Anaconda downloaded on my machine. Let's double click this. All right, first it's going to run a program to determine if the software can be installed. So let's continue. And once again, continue. Pretty easy. Continue one more time. I agree with the license agreement. Okay. You can use the default installation location, so don't worry about that. Just click install. Give it a few seconds. Now, the beautiful thing about Anaconda is that it will install Jupyter, as well as all those popular data science libraries like NumPy, Pandas, and so on. So we don't have to manually install this using pip. All right, now as part of the next step, Anaconda is suggesting to install Microsoft VS Code. We already have this on our machine, so we don't have to install it. We can go with continue and close the installation. Now, finally, we can move this to trash because we don't need this installer in the future. All right, now open up a terminal window and type Jupyter with a Y space notebook. This will start the notebook server on your machine. So enter. There you go. This will start the notebook server on your machine. You can see these default messages here. Don't worry about them. Now it automatically opens a browser window pointing to localhost port 8888. This is what we call Jupyter Dashboard. On this dashboard, we have a few tabs. The first tab is the Files tab, and by default, this points to your home directory. So every user on your machine has a home directory. This is my home directory on Mac. You can see here we have a desktop folder as well as documents, downloads, and so on. On your machine, you're going to see different folders. So somewhere on your machine, you need to create a Jupyter notebook. I'm going to go to desktop. Here's my desktop. I don't have anything here. And then click New. I want to create a notebook for Python 3. In this notebook, we can write Python code and execute it line by line. We can easily visualize our data, as you will see over the next few videos. So let's go ahead with this. All right, here's our first notebook. You can see by default, it's called Untitled. Let's change that to Hello World. So this is going to be the Hello World of our machine learning project. Let's rename this. Now, if you look at your desktop, you can see this file, helloworld.ipynb. This is a Jupyter notebook. It's kind of similar to our Py files where we write our Python code, but it includes additional data that Jupyter uses to execute our code. So back to our notebook, let's do a print hello world. And then click this run button here. And here's the result printed in Jupyter. So we don't have to navigate back and forth between the terminal window. We can see all the result right here. Next, I'm going to show you how to load a dataset from a CSV file in Jupyter. All right, in this lecture, we're going to download a dataset from a very popular website called Kaggle.com. Kaggle is basically a place to do data science projects. So the first thing you need to do is to create an account. You can sign up with Facebook, Google, or using a custom email and password. Once you sign up, then come back here on Kaggle.com. Here in the search bar, search for video game sales. This is the name of a very popular data set that we're going to use in this lecture. So here in this list, you can see the first item with this kind of reddish icon. So let's go with that. As you can see, this data set includes the sales data for more than 16,000 video games. On this page, you can see the description of various columns in this data set. We have rank, name, platform, year, and so on. So here's our data source. It's a CSV file called vgsales.csv. As you can see, there are over 16,000 rows and 11 columns in this data set. Right below that, you can see the first few records of this data set. So here's our first record. The ranking for this game is 1. It's the Wii Sports game for Wii as the platform, and it was released in year 2006. Now, what I want you to do is to go ahead and download this data set. And as I told you before, you need to sign in before you can download this. So this will give you a zip file, as you can see here. Here's our CSV file. Now, I want you to put this right next to your Jupyter notebook. On my machine, that is on my desktop. So I'm going to drag and drop this onto the desktop folder. Now, if you look at the desktop, you can see here's my Jupyter Hello World notebook. And right next to that, we have vgsales.csv. With that, we go back to our Jupyter notebook. Let's remove the first line and instead import pandas as PD. With this, we're importing pandas module and renaming it to PD, so we don't have to type pandas dot several times in this code. Now let's type pd dot read underline CSV and pass the name of our CSV file. That is vgsales.csv. Now, because this CSV file is in the current folder right next to our Jupyter notebook, we can easily load it. Otherwise, we'll have to supply the full path to this file. So this returns a data frame object, which is like an Excel spreadsheet. Let me show you. So we store it here, and then we can simply type df to inspect it. So one more time, let's run this program. Here's our data frame with these rows and columns. So we have rank, name, platform, and so on. Now, this data frame object has lots of attributes and methods that we're not going to cover in this tutorial. That's really beyond the scope of what we're going to do. So I leave it up to you to read Pandas documentation or follow other tutorials to learn about Pandas data frames. But in this lecture, I'm going to show you some of the most useful methods and attributes. The first one is shape. So shape Let's run this one more time. So here's the shape of this data set. We have over 16,000 records and 11 columns. Technically, this is a two-dimensional array of 16,011. Okay? Now, you can see here we have another segment for writing code. So we don't have to write all the code in the first segment. So here in the second segment, we can call one of the methods of the data frame, that is df.describe. Now, when we run this program, you can see the output for each segment right next to it. So here's our first segment. Here we have these 3 lines, and this is the output of the last line. Below that, we have our second segment. Here we're calling the describe method, and right below that, we have the output of this segment. So this is the beauty of Jupyter. We can easily visualize our data. Doing this with VS Code and terminal windows is really tedious and clunky. So what is this describe method returning? Basically, it's returning some basic information about each column in this data set. So as you saw earlier, we have columns like rank, year, and so on. These are the columns with numerical values. Now, for each column, we have the count, which is the number of records in that column. You can see our rank column has 16,598 records, whereas the year column has 16,327 records. So this shows that some of our records don't have the value for the year column. We have null values. So in a real data science or machine learning project, we'll have to use some techniques to clean up our data set. One option is to remove the records that don't have a value for the year column, or we can assign them a default value. That really depends on the project. Now, another attribute for each column is mean. So this is the average of all the values. Now, in the case of the rank column, this value doesn't really matter, but look at the year. So the average year for all these video games in our data set is 2006, and this might be important in the problem we're trying to solve. We also have standard deviation, which is a measure to quantify the amount of variation in our set of values. Below that, we have min. As an example, the minimum value for the year column is 1980. So quite often when we work with a new data set, we call the describe method to get some basic statistics about our data. Let me show you another useful attribute. So in the next segment, let's type df.values. Let's run this. As you can see, this returns a two-dimensional array. This square bracket indicates the outer array, and the second one represents the inner array. So the first element in our outer array is an array itself. These are the values in this array, which basically represent the first row in our data set. So the video game with ranking 1, which is called Wii Sports. So this was a basic overview of Pandas data frames. In the next lecture, I'm going to show you some of the useful shortcuts of Jupyter. In this lecture, I'm going to show you some of the most useful shortcuts in Jupyter. Now, the first thing I want you to pay attention to is this green bar on the left. This indicates that this cell is currently in the edit mode, so we can write code here. Now, if we press the escape key, green turns to blue, and that means this cell is currently in the command mode. So basically, the activated cell can be either in the edit mode or the command mode. Depending on the mode, we have different shortcuts. So here we're currently in the command mode. If we press H, we can see the list of all the keyboard shortcuts. Right above this list, you can see macOS modifier keys. These are the extra keys that we have on a Mac keyboard. If you're a Windows user, you're not going to see this. So as an example, here is the shape of the command key. This is Control, this is Option, and so on. With this guideline, you can easily understand the shortcut associated with each command. Let me show you. So here we have all the commands when a cell is in the command mode. For example, we have this command, open the command palette. This is exactly like the command palette that we have in VS Code. Here's a shortcut to execute this command. That is Command, Shift, and F. Okay, so here we have lots of shortcuts. Of course, you're not going to use all of them all the time, but it's good to have a quick look here to see what is available for you. With these shortcuts, you can write code much faster. So let me show you some of the most useful ones. I'm going to close this. Now, with our first cell in the command mode, I'm going to press B, and this inserts a new cell below this cell. We can also go back to our first cell, press escape. Now the cell is in the command mode. We can insert an empty cell above this cell by pressing A. So either A or B. A for above and B for below, okay? Now, if you don't want this cell, you can press D twice to delete it, like this. Now, in this cell, I'm going to print a hello world message. So, print hello world. Now, to run the code in this cell, we can click on the run button here. So, here's our print function, and right below that, you can see the output of this function. But note that when you run a cell, this will only execute the code in that cell. In other words, the code in other cells will not be executed. Let me show you what I mean. So in the cell below this cell, I'm going to delete the call to the describe method. Instead, I'm going to print ocean. Now, I'm going to put the cursor back in this cell where we print the hello world message and run this cell. So you can see hello world is displayed here, but the cell below is still displaying the describe table, so we don't see the changes here. Now, to solve this problem, we can go to the cell menu on the top and run all cells together. This can work for small projects, but sometimes you're working with a large data set, so if you want to run all these cells together, it's going to take a lot of time. That is the reason Jupyter saves the output of each cell, so we don't have to rerun that code if it hasn't changed. So this notebook file that we have here includes our source code organized in cells, as well as the output for each cell. That is why it's different from a regular Py file where we only have the source code. Here we also have auto-completion and IntelliSense. So in this cell, let's call df data frame dot. Now, if you press tab, we can see all the attributes and methods in this object. So let's call describe. Now, with the cursor on the name of the method, we can press shift and tab to see this tooltip that describes what this method does and what parameter it takes. So here in front of signature, you can see the describe method. These are the parameters and their default value. And right below that, you can see the description of what this method does. In this case, it generates descriptive statistics that summarize the central tendency and so on. Similar to VS Code, we can also convert a line to comment by pressing Command and slash on Mac or Control slash on Windows, like this. Now this line is a comment. We can press the same shortcut one more time to remove the comment. So these were some of the most useful shortcuts in Jupyter. Now, over the next few lectures, we're going to work on a real machine learning project. But before we get there, let's delete all the cells here. So we start with only a single empty cell. So here in this cell, first I'm going to press the escape button. Now the cell is blue, so we are in the command mode, and we can delete the cell by pressing D twice. There you go. Now the next cell is activated and is in the command mode. So let's delete this as well. We have two more cells to delete. There you go. And the last one, like this. So now we have an empty notebook with a single cell. Over the next few lectures, we're going to work on a real machine learning project. Imagine we have an online music store. When our users sign up, we ask their age and gender, and based on their profile, we recommend various music albums they're likely to buy. So in this project, we want to use machine learning to increase sales. So we want to build a model. We feed this model with some sample data based on the existing users. Our model will learn the patterns in our data, so we can ask it to make predictions. When a new user signs up, we tell our model, hey, we have a new user with this profile. What is the kind of music that this user is interested in? Our model will say jazz or hip hop or whatever. And based on that, we can make suggestions to the user. So this is the problem we're going to solve. Now back to the list of steps in a machine learning project. First, we need to import our data. Then we should prepare or clean it. Next, we select a machine learning algorithm to build a model. We train our model and ask it to make predictions. And finally, we evaluate our algorithm to see its accuracy. If it's not accurate, we either fine-tune our model or select a different algorithm. So let's focus on the first step. Head over to bit.ly/music-csv. This is a very basic CSV that I've created for this project. It's just some random made-up data. It's not real. So we have a table with 3 columns: age, gender, and genre. Gender can either be 1, which represents a male, or 0, which represents a female. Here I'm making a few assumptions. I'm assuming that men between 20 and 25 like hip-hop, men between 26 and 30 like jazz, and after the age of 30, they like classical music. For women, I'm assuming that if they're between 20 and 25, they like dance music. If they're between 26 and 30, they like acoustic music. And just like men, after the age of 30, they like classical music. Once again, this is a made-up pattern. It's not the representation of the reality. So let's go ahead and download this CSV. Click on this ... icon here and download this file. In my downloads folder, here we have this music.csv. I'm going to drag and drop this onto desktop because that's where I've stored this Hello World notebook. So I want you to put the CSV file right next to your Jupyter notebook. Now back to our notebook, we need to read the CSV file. So just like before, first we need to import the pandas module. So import pandas as PD. And then we'll call pd.read_CSV. And the name of our file is music.csv. As you saw earlier, this returns a data frame, which is a 2-dimensional array similar to an Excel spreadsheet. So let's call that music_data. Now let's inspect this music_data to make sure we loaded everything properly. So run. So here's our data frame. Beautiful. Next, we need to prepare or clean the data. And that's the topic for the next lecture. The second step in a machine learning project is cleaning or preparing the data. And that involves tasks such as removing duplicates, null values, and so on. Now, in this particular data set, we don't have to do any kind of cleaning because we don't have any duplicates. And as you can see, all rows have values for all columns. So we don't have null values. But there is one thing we need to do. We should split this data set into 2 separate data sets. One with the first 2 columns, which we refer to as the input set, and the other with the last column, which we refer to as the output set. So when we train a model, we give it 2 separate data sets, the input set and the output set. The output set, which is in this case the genre column, contains the predictions. So we're telling our model that if we have a user who is 20 years old and is a male, they like hip hop. Once we train our model, then we give it a new input set. For example, we say, hey, we have a new user who is 21 years old and is a male. What is the genre of the music that this user probably likes? As you can see, in our input set, we don't have a sample for a 21-year-old male. So we're going to ask our model to predict that. That is the reason we need to split this data set into 2 separate sets, input and output. So back to our code. This data frame object has a method called drop. Now, if you put the cursor on the method name and press Shift and Tab, you can see this tooltip. So this is the signature of this drop method. These are the parameters that we can pass here. The parameter we're going to use in this lecture is columns, which is set to none by default. With this parameter, we can specify the columns we want to drop. So in this case, we set columns to an array with 1 string, genre. Now, this method doesn't actually modify the original data set. In fact, it would create a new data set, but without this column. So by convention, we use a capital X to represent that data set. So capital X equals this expression. Now, let's inspect X. So as you can see, our input set, or X, includes these 2 columns, age and gender. It doesn't have the output or predictions. Next, we need to create our output set. So once again, we start with our data frame, music data. Using square brackets, we can get all the values in a given column. In this case, genre. Once again, this returns a new data set. By convention, we use a lowercase y to represent that. So that is our output data set. Let's inspect that as well. So in this data set, we only have the predictions or the answers. So we have prepared our data. Next, we need to create a model using an algorithm. The next step is to build a model using a machine learning algorithm. There's so many algorithms out there, and each algorithm has its pros and cons in terms of the performance and accuracy. In this lecture, we're going to use a very simple algorithm called decision tree. Now, the good news is that we don't have to explicitly program these algorithms. They're already implemented for us in a library called scikit-learn. So here on the top, from sklearn.tree, let's import the decision tree classifier. So sklearn is the package that comes with scikit-learn library. This is the most popular machine learning library in Python. In this package, we have a module called tree, and in this module, we have a class called decision tree classifier. This class implements the decision tree algorithm. Okay, so now we need to create a new instance of this class. So at the end, let's create an object called model and set it to a new instance of decision tree classifier, like this. So now we have a model. Next, we need to train it so it learns patterns in the data. And that is pretty easy. We call model.fit. This method takes two data sets, the input set and the output set. So they are capital X and Y. Now finally, we need to ask our model to make a prediction. So we can ask it, what is the kind of music that a 21-year-old male likes? Now, before we do that, let's temporarily inspect our initial data set, that is music data. So look what we got here. As I told you earlier, I've assumed that men between 20 and 25 like hip-hop music. But here we only have 3 samples for men aged 20, 23, and 25. We don't have a sample for a 21-year-old male. So if you ask our model to predict the kind of music that a 21-year-old male likes, we expect it to say hip-hop. Similarly, I've assumed that women between 20 and 25 like dance music, but we don't have a sample for a 22-year-old female. So once again, if you ask our model to predict the kind of music that a 22-year-old woman likes, we expect it to say dance. So with these assumptions, let's go ahead and ask our model to make predictions. So let's remove the last line. And instead, we're going to call model.predict. This method takes a 2-dimensional array. So here's the outer array. In this array, each element is an array. So I'm going to pass another array here. And in this array, I'm going to pass a new input set, a 21-year-old male. So 21, 1. That is like a new record in this table. Okay, so this is one input set. Let's pass another input set for a 22-year-old female. So here's another array. Here we add 22, 0. So we're asking our model to make 2 predictions at the same time. We get the result and store it in a variable called predictions. And finally, let's inspect that in our notebook. Run. Look what we got. Our model is saying that a 21-year-old male likes hip-hop and a 22-year-old female likes dance music. So our model could successfully make predictions here. Beautiful. But wait a second. Building a model that makes predictions accurately is not always that easy. As I told you earlier, after we build a model, we need to measure its accuracy. And if it's not accurate enough, we should either fine-tune it or build a model using a different algorithm. So in the next lecture, I'm going to show you how to measure the accuracy of a model. In this lecture, I'm going to show you how to measure the accuracy of your models. Now, in order to do so, first we need to split our data set into 2 sets, one for training and the other for testing. Because right now, we're passing the entire data set for training the model, and we're using 2 samples for making predictions. That is not enough to calculate the accuracy of a model. A general rule of thumb is to allocate 70 to 80% of our data for training and the other 20 to 30% for testing. Then instead of passing only 2 samples for making predictions, we can pass the data set we have for testing, we'll get the predictions, and then we can compare these predictions with the actual values in the test set. Based on that, we can calculate the accuracy. That's really easy. All we have to do is to import a couple of functions and call them in this code. Let me show you. So first on the top, from sklearn model underline selection module, we import a function called train test split. With this function, we can easily split our dataset into two sets for training and testing. Now, right here, after we define X and Y sets, we call this function. So train test split, we give it three arguments, X, Y, and a keyword argument that specifies the size of our test dataset. So test underline size, we set it to 0.2. So we are allocating 20% of our data for testing. Now, this function returns a tuple, so we can unpack it into four variables right here. X underline train, X underline test, Y underline train, and Y underline test. So the first two variables are the input sets for training and testing, and the other are the output sets for training and testing. Now, when training our model, instead of passing the entire dataset, we want to pass only the training dataset. So X underline train and Y underline train. Also, when making predictions, instead of passing these two samples, we pass X underline test. So that is the dataset that contains input values for testing. Now we get the predictions. To calculate the accuracy, we simply have to compare these predictions with the actual values we have in our output set for testing. That is very easy. First, on the top, we need to import a function. So from sklearn.metrics, import accuracy underline score. Now at the very end, we call this function, so accuracy score, and give it two arguments, Y underline test, which contains the expected values, and predictions, which contains the actual values. Now this function returns an accuracy score between 0 to 1. So we can store it here and simply display it on the console. So let's go ahead and run this program. So the accuracy score is 1 or 100%. But if we run this one more time, we're going to see a different result, because every time we split our dataset into training and test sets, we'll have different datasets, because this function randomly picks data for training and testing. Let me show you. So put the cursor in the cell. Now you can see this cell is activated. Note that if you click this button here, it will run this cell and also inserts a new cell below this cell. Let me show you. So if I go to the second cell, press the escape button. Now we are in the command mode. Press D twice. Okay, now it's deleted. If we click the run button, you can see this code was executed and now we have a new cell. So if you want to run our first cell multiple times, every time we have to click this and then run it and then click again and run it. It's a little bit tedious. So I show you a shortcut. Activate the first cell and press Control and Enter. This runs the current cell without adding a new cell below it. So back here, let's run it multiple times. Okay, now look, the accuracy dropped to 0.75. It's still good. So the accuracy score here is somewhere between 75% to 100%. But let me show you something. If I change the test size from 0.2 to 0.8, so essentially we're using only 20% of our data for training this model, and we're using the other 80% for testing. Now let's see what happens when we run this cell multiple times. So Control and Enter. Look, the accuracy immediately dropped to 0.4. One more time. Now 46%, 40%, 26%. It's really, really bad. The reason this is happening is because we are using very little data for training this model. This is one of the key concepts in machine learning. The more data we give to our model and the cleaner the data is, we get the better result. So if we have duplicates, irrelevant data, or incomplete values, our model will learn bad patterns in our data. That is why it's really important to clean our data before training our model. Now, let's change this back to 0.2. Run this one more time. Okay, now the accuracy is 1, 75%. Now it dropped to 50%. Again, the reason this is happening is because we don't have enough data. Some machine learning problems require thousands or even millions of samples to train a model. The more complex the problem is, the more data we need. For example, here we're only dealing with a table of 3 columns, but if you want to build a model to tell if a picture is a cat or a dog or a horse or a lion, we'll need millions of pictures. The more animals we want to support, the more pictures we need. In the next lecture, we're going to talk about model persistence. So this is a very basic implementation of building and training a model to make predictions. Now, to simplify things, I have removed all the code that we wrote in the last lecture for calculating the accuracy, because in this lecture, we're going to focus on a different topic. So basically, we import our data set, create a model, train it, and then ask it to make predictions. Now, this piece of code that you see here is not what we want to run every time we have a new user or every time we want to make recommendations to an existing user, because training a model can sometimes be really time consuming. In this example, we're dealing with a very small data set that has only 20 records. But in real applications, we might have a data set with thousands or millions of samples. Training a model for that might take seconds, minutes, or even hours. So that is why model persistence is important. Once in a while, we build and train our model, and then we'll save it to a file. Now, next time we want to make predictions, we simply load the model from the file and ask it to make predictions. That model is already trained. We don't need to retrain it. It's like an intelligent person. So let me show you how to do this. It's very, very easy. On the top, from sklearn.externals module, we import joblib. This joblib object has methods for saving and loading models. So after we train our model, we simply call joblib.dump and give it 2 arguments. Our model and the name of the file in which we want to store this model. Let's call that music-recommender.joblib. That's all we have to do. Now, temporarily, I'm going to comment out this line. We don't want to make any predictions. We just want to store our trained model in a file. So let's run this cell with control and slash. Okay, look, in the output, we have an array that contains the name of our model file. So this is the return value of the dump method. Now back to our desktop, right next to my notebook, you can see our joblib file. This is where our model is stored. It's simply a binary file. Now back to our Jupyter notebook. As I told you before, in a real application, we don't want to train a model every time. So let's comment out these few lines. So I've selected these few lines. On Mac, we can press Command and slash, and on Windows, Control slash. Okay, these lines are commented out. Now this time, instead of dumping our model, we're going to load it. So we call the load method. We don't have the model. We simply pass the name of our model file. This returns our trained model. Now, with these 2 lines, we can simply make predictions. So earlier we assumed that men between 20 and 25 like hip-hop music. Let's print predictions and see if our model is behaving correctly or not. So Control and Enter. There you go. So this is how we persist and load models. Earlier in this section, I told you that decision trees are the easiest to understand, and that's why we started machine learning with decision trees. In this lecture, we're going to export our model in a visual format, so you will see how this model makes predictions. That is really, really cool. Let me show you. So once again, I've simplified this code. So we simply import our data set, create input and output sets, create a model, and train it. That's all we are doing. Now, I want you to follow along with me, type everything exactly as I show you in this lecture. Don't worry about what everything means. We're going to come back to it shortly. So on the top, from sklearn, import tree. This object has a method for exporting our decision tree in a graphical format. So after we train our model, let's call tree.export underline graph viz. Now here are a few arguments we need to pass. The first argument is our model. The second is the name of the output file. So here we're going to use keyword arguments because this method takes so many parameters, and we want to selectively pass keyword arguments without worrying about their order. So the parameter we're going to set is out underline file. Let's set this to music-recommender.dot. This is the dot format, which is a graph description language. You'll see that shortly. Now, the other parameter we want to set is feature underline names. We set this to an array of 2 strings, age and gender. These are the features or the columns of our data set. So they are the properties or features of our data, okay? The other parameter is class names. So class underline names. We should set this to the list of classes or labels we have in our output data set, like hip hop, jazz, classical, and so on. So this Y data set includes all the genres or all the classes of our data, but they're repeated a few times in this data set. So here we call y.unique. This returns the unique list of classes. Now we should sort this alphabetically. So we call the sorted function and pass the result of y.unique. The next parameter is label. We set this to a string all. Once again, don't worry about the details of these parameters. We're going to come back to this shortly. So set label to all, then rounded to true, and finally filled to true. So this is the end result. Now let's run this cell using Control and Enter. Okay. Here we have a new file, music recommender dot. That's a little bit funny. So we want to open this file with VS Code. So drag and drop this into a VS Code window. Okay, here's the dot format. It's a textual language for describing graphs. Now to visualize this graph, we need to install an extension in VS Code. So on the left side, click the extensions panel and search for dot. Look at the second extension here, GraphViz or dot language by Stefan VS. Go ahead and install this extension and then reload VS Code. Once you do that, you can visualize this dot file. So let me close this tab. All right. Look at this dot here on the right side. Click this. You should have a new menu. Open preview to the side. So click that. All right. Here's the visualization of our decision tree. Let's close the dot file. There you go. This is exactly how our model makes predictions. So we have this binary tree, which means every node can have a maximum of 2 children. On top of each node, we have a condition. If this condition is true, we go to the child node on the left side. Otherwise, we go to the child node on the right side. So let's see what's happening here. The first condition is age less than or equal to 30.5. If this condition is false, that means that user is 30 years or older. So the genre of the music that they're interested in is classical. So here we're classifying people based on their profile. That is the reason we have the word class here. So a user who is 30 years or older belongs to the class of classical, or people who like classical music. Now, what if this condition is true? That means that user is younger than 30. So now we check the gender. If it's less than 0.5, which basically means if it equals to 0, then we're dealing with a female. So we go to the child node here. Now, once again, we have another condition. So we're dealing with a female who is younger than 30. Once again, we need to check their age. So is the age less than 25.5? If that's the case, then that user likes dance music. Otherwise, they like acoustic music. So this is the decision tree that our model uses to make predictions. Now, if you're wondering why we have these floating point numbers like 25.5, these are basically the rules that our model generates based on the patterns that it finds in our data set. As we give our model more data, these rules will change, so they're not always the same. Also, the more columns or more features we have, our decision tree is going to get more complex. Currently, we have only 2 features, age and gender. Now back to our code, let me quickly explain the meaning of all these parameters. We set filled to true, so each box or each node is filled with a color. We set rounded to true, so they have rounded corners. We set label to all, so every node has labels that we can read. We set class names to the unique list of genres, and that's for displaying the class for each node right here. And we set feature names to age and gender, so we can see the rules in our nodes. So that was a short and sweet introduction to machine learning. Now you can use the materials that you learned in this section and apply them to solve a different set of problems. Now here's a question for you. What ideas do you have for machine learning? What kind of problems do you want to solve with machine learning? Use the comment box below and let me know. I love to hear about your ideas. Next, we're going to use Python and a popular framework called Django to build a web application. Are you ready? Let's get started. In this tutorial, I'm going to show you how to create your first website with Python and a very popular framework called Django. So it's spelled with a silent D and it's pronounced Django. It's a web framework for perfectionists with deadlines. So if you're a perfectionist and you want to quickly put together a website that is fast, scalable, and secure, Django is your best friend. And here are the popular websites built with Django, like Instagram, Spotify, YouTube, Washington Post, and so on. Now you might ask, what is a framework and why do we need a framework to build a web application or a website? Well, a framework is essentially a library of reusable modules. These modules provide functionality for common tasks. For example, in case of a web framework like Django, we have modules to work with HTTP requests, URLs, sessions, cookies, and so on. These are the concerns of pretty much every website or web application out there. So all this functionality is already baked into Django. We don't have to code it from scratch. That is why we use a framework like Django. Now, technically a framework is more than a library. So apart from providing these modules, it also defines a structure for our application. It tells us what folders and files we should have in our project. So this provides a consistency amongst various Django projects. So as you move from one company to another and work on different projects, you can easily transition from one project to another because all these applications follow the same structure. Now, with that introduction, let's create our first Django project. So back to Pycharm, close the Hello World project and create a new project. Okay, let's call this new project PyShop. Go ahead. All right, now down the bottom, let's open up a terminal window. In this window, we're going to install Django. So we use pip to install Django, but be sure to add 2 equal signs here, followed by 2.1. With this, we're telling pip that we want to install Django version 2.1. The reason I'm doing this is because in the future, when you're watching this video, chances are there is a newer version of Django out there. I want to make sure that you can easily follow these tutorials, even though what I'm going to show you in these tutorials will most likely work with the latest version of Django. I just want to be on the safe side. So let's go ahead with this. All right, Django is installed. Next, we need to create a Django project. So here, press Ctrl and L. This cleans up our terminal window. You don't have to do it, but it's just easier to see. To create a Django project, we need to execute this command, Django-admin space start project space. We're going to call this project PyShop space period. So when we install Django, Django brings a command line utility called Django-admin. So this is a utility or program that we can execute from the command line or terminal right here. Now, this program takes various arguments. In this case, we want to use this argument, start project. With this, we're going to create a project called PyShop in the current folder. So this period is important here. That means the current folder. If you don't add this period, this utility is going to create an extra folder, and that looks a little bit repetitive. So let's go ahead with this. All right. Now, back to the project panel. If you expand PyShop, you can see that this is our project that we created in Pycharm. And in this folder, we have these files. So init.py, you have seen this before. That means this folder is a package. So we can import various modules from this package into other modules. So here we have this settings module. In this module, we define various settings for our application. You're going to see this later in this course. We also have the URLs module. And with this module, we define what should the user see when they go to, let's say, /about, /contact, /products, /shopping cart. Again, we're going to work with this soon. And finally, we have this module, WSGI, that is short for Web Server Gateway Interface. The purpose of this module is to provide a standard interface between applications built with Django and web servers. This is an advanced topic, so for now, don't worry about it. Now, outside of this folder, we also have
this new file in our project, that is manage.py. As the name implies, we use this module to manage this Django project. With this, we can start our web server, we can work with our database. Again, we're going to work with this soon. So let's open up the terminal window one more time. Now type out this command, Python if you're on Windows, or Python 3 if you're on Mac. Because as I told you at the beginning of the course, Mac by default comes with an installation of Python, that is Python 2. But in this course, we're using Python 3. So Python 3 space manage.py space run server. What is going on here? So with Python interpreter, we are running this program manage.py and passing run server as an argument. This manage.py is essentially the same program that we worked with here, Django admin. But we used Django admin before creating a Django project. Now we have a Django project. So in this project, we work with manage.py. This is a module that contains some Python code. So we use this module to manage our Django project. So let's go ahead and run our development web server. As you can see, this started a development web server at this address, http://127.0.0.1. That is the address of your current machine. Now note that after this, we have :8000. Unfortunately, the link below this address has a problem. As you can see, the port is excluded. So if we click this, it opens up our web browser and points it to this address. So we don't have the port number. Let's add :8000 at the end. And here's our first Django website. So we created this Django project. Now this Django project can contain multiple apps. These apps don't represent the entire application. There are small functional areas in our Django project. Here's an example. Imagine you want to build a website or a web application like Amazon. Amazon is a big website. It has so many different functions. Instead of implementing all these functions in a Django project, we divide this project into small functional areas that are focused on one concern. For example, we could have functional areas like product management, order management, customer management. These are completely different functional areas. The functions we have for managing the customers are different from the functions for managing the products. By the same token, when you go to an organization, there are small departments or small offices specializing in different areas. So with this analogy, we divide a Django project into multiple Django apps. Each app is focused on one functional area. So in this tutorial, I'm going to show you how to add a new app to manage the products in our imaginary shop. In the future, let's say we want to add a blog to our online shop. We could come back here and create a new app that represents a blog. Now, the beauty of these apps is that we can reuse them across different Django projects because each app is essentially a Python package. Let me show you. So back to our project, let's open up a terminal window. So this is the terminal window we opened earlier where we started our web server. Now up here, we have this plus button for creating a new terminal window. So let's click that. Now let's type out this command, Python on Windows or Python 3 on Mac, manage.py. So we're using the same program, the same module, but this time with a different argument. Start app, and we're going to call that app products. Let's go ahead. All right, now here we have a new folder called products. Let's see what we have in this folder. We have a subfolder called migrations. We'll look at this later. Below that, we have this init.py. So products is a package. We can take this package and reuse it in another Django application, or more specifically, Django project. We can also publish this package to PyPI for other people to reuse in their Django projects. For example, if someone else wants to build an online shop, they can reuse this package for managing the list of products. They don't have to build this functionality from scratch, okay? We have this module, admin, and this is used for defining how the administrative panel of this app will look like. Again, we're going to come back to this later. Below that, we have this module, apps. Unfortunately, the name is a little bit confusing because right now we are inside of one app, that is the products app, and it doesn't make sense to have a module called apps inside of an app. So I don't know why Django creators decided to call this module apps, but basically we use this module to store various configuration settings for this app. So it would be better to call this config. But that aside, let's move on. Next, we have models, and this is where we define classes or new types for modeling the concepts in this app, in this domain. For example, in the domain of products, you probably have concepts like product, category, review, and so on. So we could model these concepts using classes. Again, we're going to come back to this and define a new class here. Next, we have tests.py, and this is where we write automated tests for this app. That's an advanced topic beyond the scope of this course, so don't worry about it. And finally, we have the views module. And this is where we define what should the user see when they navigate to a certain page. In this tutorial, I'm going to show you how to create your first view or view function in Django. What is a view function? A view function is basically a function that gets called by Django when the user navigates to a particular page. For example, here we are on the homepage of our website. When we go to /products, our browser sends an HTTP request to our web server. At this point, Django takes that request. It inspects the URL or the address. It figures out that we want to see the list of products. Then it will call a function, which we call a view function. And the job of this function is to return the response to the browser or to the client. So this function should generate some HTML markup to be returned to the client. Our browser will get this HTML content and display it as a page right here. Now, technically, if you want to be a web developer, you need to know HTML, CSS, and JavaScript. I'll try to do my best to hold your hand throughout this course. But in the future, be sure to watch a tutorial about HTML, CSS, and JavaScript. On my channel, I have plenty of JavaScript tutorials. I recommend you to start with my JavaScript tutorial for beginners. So back to our project. Inside the Products app, let's open up the Views module. So here on the top, we have some boilerplate code. From Django.shortcuts, we are importing the render function. So Django is a package, shortcuts is a module, and we are importing the render function. You will see this soon. Below that, we have this comment. We don't need it. Let's create our first view function. So define. We call this function index. It doesn't really matter, but by convention, we use the word index for the main page of an app. So when we go to /products, this will be the main page of our products app. Now, potentially in the future, we could support additional URLs inside of this app. For example, products/new or trending and so on. So we call this function index. Now, all our view functions should always take a parameter, and that is the HTTP request that is passed to this view function. So as I told you before, when we navigate to /products, our browser sends an HTTP request to our web server. Django takes this request and sends it to our view function. With this request object, we can find information about the client. Now, in this tutorial, we don't want to worry about HTML. We just want to return some plain text to the browser, like hello world. So on the top, from Django.http module, we need to import a class called HTTP response. With this class, we can create an HTTP response to return to the client or the browser. So back to our view function. Here we return an HTTP response object. So we're creating an instance of this class, right? Now, as an argument to the constructor, we pass hello world. Now we need to add an extra blank line above the index function to make Pycharm happy. Beautiful. As simple as that. So we are done with this view function, but nowhere Django knows that it should call this function when we send a request to /products. So we need to tell Django that, hey, whenever there is a request to /products, call this index function. We need to map this URL to this function. A URL is short for Uniform Resource Locator, and that basically means address. Okay, so let's do the mapping. We're done with this module, close it. Back to our products app, right-click this folder and add a new Python file. Call that URLs. The name is very important here. This is one of the conventions that Django framework defines. So we need to follow this convention to structure our project. Okay, so this adds urls.py inside of the products app. Now in this module, once again, by convention, we should define a variable called URL patterns. Make sure to spell it exactly as you see here. So there is no underscore between these two words, and all characters are in lowercase. So we set this to a list object. In this list, we map various URLs to their view functions. Now, to reference a URL, we need to import the path function. So on the top, from Django.urls, let's import the path function. With this function, we can map a URL to a view function. So we call the path function. The first argument is a string that specifies our URL endpoint. Here we pass an empty string that is a string with no characters in it. And this represents the root of this app. Let me show you what I mean. So imagine our app starts at /products. So if the user sends a request to this endpoint, they will be at the root of this app. Potentially here we could have other URLs like /products, /one, /detail, or /products, /new, or trending, or whatever. So all the URLs in this app start with /products. Okay? Now back to the first example. What happens if we take away this /products? We are left with nothing. And that is why we use an empty string here. Now, as the second argument to this function, we need to specify our view function. So we defined that view function inside of the views module. So first we need to import this module into the URLs module. Now, this is how we do this. From period import views. Period means the current folder. So from the current folder, we are importing the views module. So with this syntax, we're telling Django to import the views module that we have in this folder. Now you might ask, Mosh, why didn't we import the views module like this? Import views, because views is actually in the current folder. So why do we have to use the from import syntax? The reason for this is because views is kind of a generic name. So it is possible that our project has a dependency to another library called views. With this syntax, Python will end up importing that module instead of the views module in the current folder because that will take priority. So to remove these potential issues, we use the from import syntax. So now we imported the views module. As you know, when we import a module, that module will end up being an object. So we can use the dot operator to access the functions defined in that module. So here we want to reference the index function. Okay, let's delete it from here. Back to our path function. As the second argument, we type out views.index. Now note that I'm not calling this function. I'm simply passing a reference to it. Django will take care of calling this function at runtime when the client sends an HTTP request to the server. So here we should not call this function. So let's quickly recap what we have done up to this point. In the views module, we created this view function. And in this view function, we simply return some plain text to the browser or the client. Now, I told you that nowhere Django knows that it should call this function. So that's why we added the URLs module to our app. And in this module, we mapped the root URL to this view function. There's one more step left. We need to tell Django about this app because up to this point, Django is not aware of this app. So let's collapse the products folder and open up the PyCharm folder. In this folder, we have another URLs module, and this is like the root or the parent URLs module in our Django project. Let's open this and scroll down. Once again, you see this URL patterns variable that is set to a list. In this list, again, we're calling the path function. As the first argument, we're telling Django that, hey, any URLs that start with admin, delegate them to the admin app. So every Django project by default comes with this admin app, which gives us a beautiful administrative panel. We're going to work with that soon. So in this module, we should also tell Django about our products app. So let's add another object to this list. Once again, we call the path function. Now we tell Django that, hey, any paths or any URLs that start with products / delegate them to the products app. So we want Django to delegate the handling of that request to this URLs module that we defined in the products app. Okay, how do we do that? Very easy. Back to the main or the parent URLs module. On line 16, we have this import statement. Let's expand it. So basically, we have two import statements. Look at the second one. From Django.urls module, we're importing the path function. There is another function that we need to import, and that is the include function. Now we're going to use this function on line 21. So as the second argument to the path function, we call include. And here we need to reference the URLs module in the products app. So we type out products.urls. So take a look. In the products app, we have this module, URLs. That is why we type products.urls. But we don't type out .py. Django will automatically take care of that. Now, at this point, you might be a little bit confused or intimidated by all these various steps that you have to follow. They may look foreign to you, but trust me, this becomes second nature as you practice building Django applications. It's actually very easy. It's just the first time that you have to follow these conventions defined in Django framework. Once you understand the concept, it becomes really easy. So basically, because we created a new app, the products app, only once ever we need to write this line of code to tell Django that, hey, any URLs that start with products / send them to the URLs module in the products app. So we write this line of code only once. Anytime in the future, we want to define a new view function. First, we go to the views module, we create a new function, and then we go to the URLs module in that app and define a new URL pattern to map that view function to a URL endpoint. That is really easy. All right, now let's test our application. So back to the browser, let's head over to /products. There you go. You see our hello world message here, beautiful. But if we navigate back to the home page, we get this error, page not found. So our beautiful Django homepage disappeared. And the reason for this is that homepage is automatically generated and is only displayed when we first create a Django project. As soon as we define a new URL pattern and register it in our project, that homepage disappears. But don't worry, we're going to come back and create a new function for our homepage later in the course. Now here's your exercise. I want you to modify this Django project such that when we navigate to products/new, we'll see a page here with some text like new products. I strongly encourage you to do this exercise because it makes it really easy for you to follow the future tutorials. All right, here in the products app, let's open up the views module. In this module, we define a new view function. So define, let's call that function new. As I told you before, every view function should take this request parameter. Now here we want to return an HTTP response with the text new products. That's it. Now to make Pycharm happy, we add another line break here. So we have 2 line breaks after the index function and also 2 line breaks after the new function. These are the best practices defined in PEP 8 to format our code. So we're done with this view function. Now we need to map it to a URL endpoint. So we go back to the products app and open up the URLs module. Here we need to add another URL pattern. So we call the path function. The first argument should be new. You want to map this URL endpoint to views.new function. That's all you had to do. Now back to our browser. When we navigate to products/new, we get this message in the browser. Beautiful. In this tutorial, I'm going to show you how to create a model in a Django project. A model is a representation of a real-world concept. For example, in an online shop, we could have models like order, customer, shopping cart, product, review, and so on. So let's go ahead and create our first model. Here in the products app, open up the models module. In this module, we're going to create a new class called product. So let's delete this comment. We don't really need it. Class product. Now we need to inherit this class from the model class in Django. So in parentheses, we type out models.model. Let's see what's going on here. So on line 1, from Django.db package, we are importing the models module. In this module, we have a class called model, and this class defines all the common characteristics and behavior for models in a Django application. For example, we want to be able to store these models in a database, or read them from a database, or delete them. These are all the common operations that we need to perform on these model objects. So by inheriting this product class from this model class, our product class will have all these capabilities built into it. We don't have to code it, okay? So, colon. Now in this class, we need to define a few attributes. What are the attributes of a product that we need to know in an online shop? We need to know their name, price, stock, image, and so on. So let's define a new attribute. We call it name, and we set it to an instance of models.charField class. So once again, in this module, we have a class called charField, which is short for character field, and this represents a field that can contain textual data. Now here, as a best practice, we can supply a maximum length to prevent a malicious user or hacker from accidentally storing a product with an enormously large name. This can mess up with our application. So let's pass a keyword argument, max length, and we set it to 255 characters. Now let's define the price attribute. So we set price to models dot float field. So this represents a field that can contain floating point numbers. That's it. Now let's define the stock. We set this to an instance of models.integer field. And finally, let's define image underline URL to an instance of once again, char field. So in this course, we're going to use Google to find an image for our products. For example, we can find this image, right-click it, and copy its link address, which is the URL. Now, if you open up a new tab and paste that URL, you can see this is a very long string. So we don't want to enforce a maximum length of 255 characters. Instead, we want to use 2083 characters. That is the standard maximum length for URLs. So our product class or product model has these 4 attributes. Now to make Pycharm happy and remove this warning, let's put the cursor at the end of this line, press enter, then backspace to remove the indentation. Beautiful. We should also add 2 line breaks before this class. So here's one, press enter, the second line break. Beautiful. So our code is formatted according to PEP 8 standards. Next, I will show you how to use this model to create a database table for storing products. In this Django project we have created, you can see we have this file db.sqlite3. This is an empty database file that Django creates, and we use this to store our data. Now, SQLite is a kind of database, and it's the simplest for small applications, but it's not suitable for large enterprise web applications. So if you want to build a real enterprise web application with Django, you need to use a proper database engine like SQL Server, MySQL, Oracle, Postgres, and so on. The good news is that Django supports all of these database engines. But SQLite is the easiest to get started. So we're going to work with this for now. And in the future, I will show you how to use a proper database engine. Now, for the purpose of this tutorial, I want you to open up your browser and search for DB browser for SQLite. So on this page, sqlitebrowser.org, you can find a very simple and free application for opening SQLite databases. And as you can see here on the right side, there are executables for Windows, Mac, and so on. So when you open it, you get something like this. We can create a new database here on the top or open an existing one. Now here I'm going to drag and drop our database file right here. You can see we don't have any tables in this database. So to store data, first we need to create a table. For example, to store the list of products, we need to create a table called products, and the fields or columns we have in this table should be exactly the same as the attributes we have in our product class. So in this tutorial, I'm going to show you how to use Django to automatically create this table. We don't have to do this by hand. We can just tell Django, hey, here's our model. Go ahead and automatically create a database table for storing our products. That is very easy. So here down the bottom, let's open up a new terminal window and run Python on Windows or Python 3 on Mac, manage.py, make migrations. Make sure to spell this properly. So make migrations in one word. Now when you run this, you get this message, no changes detected, because by default, Django doesn't know about our product model. To solve this problem, we need to go back to our project and open the PyShop package. In this package, we have this settings module for storing various configuration settings for our project. So let's open this and scroll down. On line 33, you can see a variable called installed apps set to a list of strings. These are applications or apps that are automatically installed with every Django project. For example, we have this admin app which gives us a beautiful administrative panel. You're going to work with it soon. You also have this auth app, and we use this to authenticate users. You can put them in different roles, give them different permissions. It's all about authentication and authorization. We'll look at the other installed apps in a future tutorial. So for now, let's register our products app in this list. How do we do that? First, we go to our project. Inside the products app, earlier I told you about the apps module. Take a look here. The name of this module is a little bit misleading because we're in the boundary of one app and we have a module called apps. That aside, all we have here is a class called products config where we store configuration settings for this particular app. Okay? Now we need to go back to our settings module and add the complete path to this class, including its package and module. So this class is defined in the apps module, and this module is inside of the products package. So back to the settings file. In the list of installed apps, we need to type out a string like this. Products, that's our package, dot, apps, that's our module, and then products config. Again, make sure to spell this properly. So P and C are capitalized because here we have a class. But products and apps are all in lowercase, okay? So now Django knows about our products app. So when we go back to the terminal and run the last command, we'll get a different result. So use the up arrow to bring up the last command and enter. There you go. Now we get this message, migrations for products. So inside the products folder, inside the migrations folder, we have a new module with this sequence number called initial. Let's have a quick look at the code inside this module. So back to our products app, let's expand the migrations folder. Here's our initial migration. Let's have a quick look here. So we have a class called migration. And in this class, we have this attribute called operations, which is set to a list of operations. So every migration can contain multiple operations. Look at the first operation we have here, migrations that create model. So with this operation, we can create a new database table called product. And in that table, we're going to have these fields, ID, name, price, stock, and image URL. These are the attributes that we created in our product class. But we didn't have this ID attribute. Django automatically generates this because every database table must have an ID field. And we use this to uniquely identify records in our database. Now, let's go back to the terminal. So we have a new migration, but our database is still in its previous state. We don't have a new table here yet. So we need to run this new migration to generate our product table. And that is very easy. So one more time, Python, manage.py, migrate. When we run this command, Django will look at our project. It will look at every app, and it will run the pending migrations for that app against our database. So take a look. When we run this, we get several messages. So if you scroll up, you can see applying content types .001 initial. So in the content types app, which is one of the apps installed by default, we have this migration. So Django ran this migration and this created a database table for this app. Similarly, in the auth app, which is used for authenticating users, we have this initial migration. We also have a bunch of migrations for the admin app. So Django ran all of these migrations, and down the bottom, you can see applying products initial migration. So every app can contain multiple migrations, and each migration will make a slight change to the database to add a new table or modify an existing one. So back to DB browser for SQLite. Let's drag and drop our database file one more time here to reload it. There you go. Now we have 12 tables in this database. Each table is prefixed with the app it belongs to. For example, you can see we have a table for storing our users. We have another table for storing the groups a user belongs to. We have another table for storing permissions and so on. Now here down the bottom, you can see this table, products, underline product. So this product table is prefixed with the name of our app, which is products. Now, if you expand this, you can see these fields in this table, ID, name, price, stock, and image URL. So this is the beauty of Django. We didn't have to come here and manually create these tables by hand. That's very time consuming. We simply created a model with these attributes, and then we ran two commands in the terminal. One for creating a new migration based on the changes we have made in our code, and the other to run the pending migrations. So now all the migrations in this project are run against our database, which means if we go back to the terminal and run python manage.py migrate, we get this new message, no migrations to apply. So here's the workflow. Next time we create a new model or modify an existing one, we should come back here in the terminal, create a new migration, and then run it. All right, here's your exercise. We want to have the concept of offering discounts in our imaginary online shop. So I want you to create a new model class called offer. And in this class, we should have 3 attributes. One is code, which is a textual field. For example, our offers code could be VCA2142. It's just a coupon code. Here we should also have an attribute called description. Again, this is going to be a textual field. For example, we can say 20% off all products. And then we can display this text somewhere on the homepage in the future. And finally, we need another attribute called discount, which is going to be a floating point number, like 0.2 for 20% discount. So go ahead, create this model class. Next, create a migration and run it to bring our database up to date. This is an awesome exercise for you to get your hands dirty in Django. So spend 3 to 5 minutes on this exercise. When you're done, come back, see my solution. So here in the models module, right after our product class, I'm going to define a new class. Class offer. This class should also derive from the model class in Django. Here we add the attributes. So the first one is code, which is going to be an instance of models.char field. And we set the max length to, let's say, 10 characters. Next, we add the description. Once again, we're going to have a char field with max length of 255 characters is sufficient. And finally, we need discount. And we're going to set this to an instance of models.float field. So here's our offer class. Now we need to create a migration. So over here, I'm going to open up a terminal window. This is the main terminal window where our web server is running. So I'm going to create a new terminal window and run python manage.py make migrations. Django detected a change in our models, so it created this new migration number 2 called offer. And this migration will create the offer table in our database. So let's go ahead and run it. Python 3 manage.py migrate. Beautiful. Now let's drag and drop our database here one more time. Our database is refreshed. As you can see, in the products app, we have this new table, offer, with these 4 columns: ID, code, description, and discount. In this tutorial, I'm going to talk to you guys about the administrative panel of Django applications. So here in the browser, if we head over to /admin, we get this beautiful login screen to log into our administrative panel. So every Django application by default comes with an administrative panel. We don't have to create this from scratch. We don't have to code this. It gets auto-generated. And this is one of the fantastic features of Django that increases your productivity. So let me show you how to work with this administrative panel. Here in Pycharm, we need to create the first user of this application. We call that super user. So here in the terminal window, let's run python manage.py create super user, all in one word. So let's go ahead with that. It asks for a username. Let's type admin. Next, we need to enter an email address. I'm going to enter my email address. Next, we need to enter a password. I'm going to type 1234 and repeat it one more time. Note that it complains because this password is too short, it's too common, and it's entirely numeric. So at the end, it asks if you want to bypass password validation. For simplicity, let's go with that. But of course, in a real scenario, you don't want to create an admin user with such a simple password. All right, we successfully created the super user. Now back in the browser, let's log in with admin and 1234. There you go. So this is our administrative panel. As you can see, we can manage the users and groups. We can add new users or modify or delete existing ones. Let's have a quick look here. So here we have this search bar on the top. We can quickly search for users. Below that, we have this table of users with these columns: username, email, first name, last name, and status. We can sort this table by any of these columns. We also have these filters on the right side. So we get all these beautiful features for free with every Django application. We don't have to code this. Earlier in this course, we talked about this settings module. Let's have a quick look here. In this module, we have a setting or a variable called installed apps. And one of the apps that is installed by default is the admin app. So this app is the piece that is responsible for generating these views. Now, the beautiful thing about the admin app is that it is easily extensible. So back to the home page of our administrative panel, so far we can only manage the users and groups. But using one line of code, we can also manage our products. Let me show you. Let's expand our products app. Inside of this app, we have this module admin. And in this module, we register the models that we need to manage in the admin section. So let's open this module. Now on the top, first we need to import our product model. So we can type out some code like this from period models. That means the models module in the current folder. So from this module, we want to import the product class or the product model, right? Now you can see this comment here, register your models here. Let's delete this comment. We don't need it anymore. Instead, we're going to write code like this. So admin.site.register, and we pass this product class as an argument. What is going on here? We're using this admin object that is imported on line 1. This object has an attribute called site, which is an object itself. This object has a method called register. We're calling this method and passing our product class as an argument. With this, we're telling Django that we want to manage our products in the admin area. So now with only one line of code, or more accurately 2 lines, if we go back to our administrative panel and refresh this page, we see this new table, products, that represents our products app. And in this app, currently we only have one model called product. So here we can manage all our products. Currently, we don't have any products in our database. So let's go ahead and add a new product. Look, we get this beautiful form for free. We didn't write any code to create this form and handle the click event of these buttons to insert a product into our database. All this is automatically generated by Django. So let's go ahead and add a new product. Call that orange. Let's say 1.99 each. And set the stock to 50. Now we need an image URL. So open up a new tab here. And in Google, search for orange. Then go to images. Click on tools. From the user rates menu, select for labeled for reuse. This way we don't have problem with copyright issues. So these are the free images that we can use in our application. Let's pick this one. Click on it again. Now on this page, right-click the image, copy a link address, and then back to our product form, paste it here, and then save. So we successfully added a product, and that product is listed here in the product table. But what we see here is a little bit confusing. It says product object 1. It's not clear what product this is. Is it an orange? Is it a strawberry? What price is it? So in the next tutorial, I will show you how to customize this table and add columns specific to products. In this tutorial, I'm going to show you guys how to customize this products table in the admin area. That is very easy. So back to Pycharm. Here in the admin module where we register the product class for administration, we need to create a new class called product admin. So we create a class called product admin. So this is the convention we follow in Django. We start with the name of our model, that is product, and then we add the suffix admin. Now we should inherit this class from admin.modelAdmin. What is going on here? Well, this admin is a module that we have imported on line 1. In this module, we have a class called modelAdmin, which provides all the common functionality for managing models in the admin area. So by deriving this class from the modelAdmin, this class inherits all this common functionality. Now, in the body of this class, we can override or change some of this functionality or attributes. For example, in this class, we have an attribute called list underline display, and this attribute specifies the columns that should be visible in this table. So we set this to a tuple, and in this tuple, we add one or more attributes of our product class. So let's quickly open up our product class. It's here in the models module. Okay, there you go. So our product class has these attributes: name, price, stock, and image URL. Now, image URL, as you saw, is a long string, so we don't want to display that in our table. So in this tutorial, let's add these three attributes to our products table. Back to the admin module. In this tuple, we add three strings: name, price, and stock. Now we have this little warning here because we haven't added two line breaks before and after this class. That is better. Finally, when registering our product class for administration, as the second argument, we need to pass this new class, product admin. So Django will use the information in this class to decide how to present the list of products. So back in the browser, let's refresh this page. There you go. Here's our products table. Now we have three columns: name, price, and stock. You can see we have this orange. The price is set to $1.99, and currently we have 50 items in the stock. Beautiful. Let's go ahead and add a new product here. Let's say a strawberry, and the price $2.99, 30 for the stock, and finally we need an image URL. I'm going to paste this address that I just copied before recording this video. Okay, let's go ahead, save the changes. The product is added, beautiful. And now we have two products in our table. Now here's what I want you to do. I want you to pause the video and add a few more products to our database, somewhere around 5 to 10. In the next tutorial, I'm going to show you how to display these products to the public users of our website, because this admin panel is only visible to admins. So anonymous users or other registered users are not going to have access to this panel. Instead, they're going to go to /products. Now currently we are displaying a hello world message. We're going to change this page and display the list of our products in a beautiful grid. So pause the video and add 5 to 10 products, then come back, continue watching. Currently in the admin area, we can only manage the products in the products app. So there is no way to manage the offers. So as an exercise, add the ability to manage the offers here. When we click the offers link, we should see a table with two columns, code and discount. So go ahead and implement this and then create a new offer. All right, here's my solution. In the admin module of the products app, on line 2, first we need to import the offer class. Next, we create a new class called offer admin. We derive this from admin.modelAdmin. And here we set the list display attribute to a tuple with two items, code and discount. And finally, we need to register our offer model for administration. So admin.site.register offer and offer admin. That's it. Now, if we go back to the admin area and refresh the home page, we see the offers link here. Beautiful. Currently, we don't have any offers, so let's go ahead and add a new offer. I'm going to use a code like VCA 1010. Let's say 10% off all products. And discount, I'm going to set this to 0.1. Now, technically, in a real application, this code should be unique. But that's a topic for a future tutorial, so for now, don't worry about it. Let's go ahead and save this offer. Okay, our offer is saved successfully. Beautiful. As you can see, in this table, we have two columns, code and discount. In this tutorial, I'm going to show you guys how to replace this hello world message with the list of products in our database. And that is super easy. So here in Pycharm, in the products app, let's open up the views module. Earlier I told you that in this module we define our view functions, which are functions that get called when the browser sends an HTTP request to the server. For example, when the user navigates to /products page, our browser sends an HTTP request to our Django application. Django takes that request and hands it off to this function, the index function. Now here we're simply returning a hello world message. We want to replace this with the list of products in our database. So the first step is to get the products stored in the database, and then we need to format them using some HTML template. So let's go ahead and on the top, import our product class from the models module. So from period models, import product. So we're importing the product class in the models module in the current folder. So period means the current folder. Now this product class has a bunch of useful methods for getting data from our database. For example, we can call product.objects.all, and this returns all the products we have in our database. We also have filter for filtering products. Let's say we want to get products that are more expensive than $2 or products that are out of stock. We can use the filter method. We also have the get method for getting a single product. And we also have the save method for inserting a new product or updating an existing one. Now in this tutorial, we're going to use the all method to get all the products from our database. Then we store them here in this variable. So we have done the first step. Next, we need to create an HTML template for presenting this list of products to the user. So back to the project panel, inside the products app, let's add a new folder, a new directory. And by convention, we should call that templates. Make sure to spell it properly because this is a special directory that Django looks at to load templates. So let's go ahead with that. Now we want to create a template for the index function. So inside of this folder, let's add a new file and call that file index.html. Now here we can write some HTML code. If you're not familiar with HTML, don't worry, just follow along with me. It's super easy to learn. So first let's type H1 and then press tab. This inserts an H1 tag into our HTML document, and we use this to display a big bold heading. So inside these tags, let's type products. Now below this H1, let's type UL and press tab. Now this inserts a UL tag, and we use this to display a list of items. Now we need to surround each item with an LI tag. So type out LI, press tab, and in between the tags, let's type item 1, then copy and paste this a couple times. So item 2 and item 3. Now instead of item 1, item 2, and item 3, we want to display the name of our products. But before we get there, let's simply return this HTML markup to the client instead of the hello world message. So back to the views module. Here in the index function, we need to change the return statement on line 8. So we want to call the render function. This function is already imported on the top on line 2. We use this function to render a template. So let's call this function. As the first argument, we need to pass this request object that we get as an argument to this function. So let's pass the request here. As the second argument, we need to specify the name of our template. So we pass a string. What is the name of our template? That is index.html, right? Now, before going any further, let's go back to the browser and refresh this page. So instead of hello world, we see this products heading. This is the result of an H1 tag. And with UL and LI tags, we see these bullet points over here. Beautiful. Now, finally, we need to replace item 1, item 2, and item 3 with the list of our products. So back to our view function. As the third argument to the render function, we need to pass the list of products that we loaded from the database. So here we need to pass a dictionary. In this dictionary, we're going to add one key value pair. We're going to call the key products, but we could call it anything. It doesn't really matter. The value for that key should be the products object that we define on line 7. So here in our dictionary, let's add this key products, colon, and the value should be this products object. So let me break up what we have on line 8 over multiple lines so you can see it clearly. We're calling the render function with 3 arguments: the request object, the name of our template, and a dictionary that contains the data to be passed to this template. And finally, we're going to go to this template, index.html, and replace these items with our products. That is very easy. So just after the UL tag, I want you to type out a curly brace, followed by a %, a space, a % one more time, and a closing brace. This is what we call a template tag in Django. So in between these markers, we can write dynamic code. For example, we can add loops to repeat some instructions or write if statements to conditionally render some content. So here we want to write a for loop for product in products. So earlier in our view function, we passed these products here using a dictionary. Back to the view function, look, as the third argument to the render function, we passed this dictionary. This dictionary is called the context, so it provides data to be used in our templates. In this case, we have a property called products, and that is the reason we can access it here. So we are looping over these products. Now, for each product, we want to render a list item. So let's indent this item here and replace item 1 with the name of the product. So here we want to dynamically render the name attribute of this product object. To do that, we use double curly braces. So open 2 curly braces and close them, and in between them, type out product.name. So whenever we use double curly braces in a Django template, Django will evaluate the expression that we put here and render it in HTML. Now, the last step is to end this for block, because Django, unlike Python, doesn't rely on indentation to determine the scope of a block. So right after this for loop, once again, we add curly braces, a %, and type out end for. And then we close it here. Now, we no longer need these items here, so let's delete them. Now back to the browser, let's refresh our page. So instead of item 1 to 3, we see the name of the products stored in our database. Now let's take this to the next level by displaying the price of each product right next to it. So back to our template, this is where we're rendering the name of the product. After the curly braces, let's add parentheses. Now inside of the parentheses, we want to dynamically render the price of each product. So once again, we use the double curly brace syntax to render some value dynamically. That is the value of product.price, like this. Now back here, let's refresh the page. Now we can see the price of each product right here. Beautiful. We could also prefix that with a $sign. So before the curly braces, we add a $sign. And then when we refresh the page, we see the actual dollar value. So this is what I want you to take away in this tutorial. In Django templates, we have 2 special syntaxes. One is a curly brace and a %. This is called a template tag, and we use this to dynamically execute logic. So in between these template tags, we can write for loops to repeat some code, or we can use if statements to dynamically render content. The other syntax we have is the double curly brace syntax, and we use this to dynamically render values in our HTML markup. So whatever we put in between them will get evaluated and written to the HTML markup. Now, this page is pretty boring so far. In the next tutorial, I will show you how to convert these bullet points into beautiful cards. Over the next few tutorials, we're going to replace this boring list of bullet points with a beautiful modern card like this. So on the top, we're going to display the image for each product. Below that, we're going to display the title or the name of the product, as well as the price and potentially a button to add that product to a shopping cart. Now, to present something like this, we're going to use a framework called Bootstrap. It's a very popular framework for building modern and responsive applications. So head over to getbootstrap.com. On the home page, you should see something like this, and then go to the documentation. On this page, you can see how you can add this Bootstrap framework to your web applications. So if you scroll down, here you should see a starter template. So here we have some basic HTML markup. We want to bring all this HTML markup and store it in a template called base.html. So over here, you should see this copy button. Click that to copy this. Then back to Pycharm. In the project panel, inside of the templates folder, let's add a new HTML file. So a new file, we call this base.html. Now, with Command and V on Mac or Control and V on Windows, paste all this markup that we copied from Bootstrap website. Now, here on line 13, we have the body tag, and this is the container for what the user sees in a given web page. Now in this example, we have an h1 tag for displaying a hello world title. We want to replace this with something dynamic. So for each page in our application, we want to render something different. For example, when the user goes to the products page, over here, instead of this h1 tag, we want to render what we defined in index.html here. Okay, so back to base.html, let's delete this h1 tag. Once again, we're going to use a template tag. So curly brace, %, curly brace. Now the template tag we're going to use is called block. And with this, we can define a block or a hole in this document. So we're going to create a block called content. We could call it anything, but here we're defining the content area of our website. So that's why we call this block content. Now, after this, once again, we need to add another template tag, and this is called end block. Now we should go to index.html. On the top, we should tell Django that we want to extend this base template, which means we're going to use all the markup defined here. And this gives our applications a modern look and feel. So back to index.html. Once again, we're going to use another template tag. This one is called extends. So extends. What are we extending? The template defined in base.html. So here we add a string base.html. Now we want to fill the block or the hole that we defined in base.html with these few lines. So once again, we add a template tag, block. What is the block that we're filling? That is the content block, right? And we close it here. So now all this markup is going to go in the content block. Now finally, we need to close this block. So after the last line, let's add another template tag and block. Now to make this code cleaner, I would prefer to select these few lines that belong to the content block and indent them like this. This is not required, but it just makes our code easier to read. So with these changes that we made in this tutorial, when Django tries to render this page, first it will look at base.html. So it will take all the markup defined in that file, and then it's going to fill this content block with the markup we have defined here. Now, if we go back to our browser and refresh this page, we're going to see something a little bit better. So refresh. You can see the fonts are changed, and there is a little bit more space in between the bullet points. Now we are ready to replace each bullet point with a bootstrap card. And that's what I'm going to show you next. In this tutorial, I'm going to show you how to display these beautiful cards on our products page. Now note that this page is responsive. So if you view it on a small mobile device, we're going to have one card on each row, like this. And if you view this on a bigger screen, we're going to have more columns or more cards on each row. So let me show you how to build this. First, head over to getbootstrap.com, click on the documentation. Here on the left side, you can see a link called Components. On this page, you can see all the components that are defined in Bootstrap. These are the components that we can add to our web pages to make them beautiful and modern. So the component that we're going to use is called a card. Over here, you can see an example of a card. And right below that, you can see the markup that we need to use to render something like this. So let me resize the screen. Okay. On the top right corner, we have this button. Copy this markup. Now back to index.html. Instead of rendering a UL and a bunch of LIs, we want to render a bunch of divs. Because with UL and LI, we'll get bullet points, but we don't want to display bullet points here. So right below the h1 tag, type out div.row and then press tab. So this creates a div with the class row. Now in this row, we want to repeat multiple columns. So type out div.col, as in short for column, and then press tab. So we use these divs to create a layout like this. We have multiple columns in a row. Okay. Now inside of a column, we want to render a card. So now we should paste the markup for rendering a bootstrap card. So paste that here. Now you can see our code looks a little bit ugly because it's not indented properly. So on the top, go to the code menu. Here we have this item, reformat code. And look at the shortcut that is associated with this command. So let's click that. Now our code is beautifully formatted and it's easier to read and modify. So we have a row. Inside this row, we have a column, and inside this column, we have a card. Now we're going to take our for loop and put it above this column. So for each product, we want to render a column. So scroll down and grab this line of code, cut it, and then paste it right above this column. Now we should close this for loop. So let's collapse this div below it. Okay, now right after this div, we want to add a template tag and type out end for. With these changes, we don't need the code from before. We don't need the UL and LI tags. So let's delete all of these. So this is the final result. Inside the content block, we should have these tags. We have an H1 on the top for the heading. Below that, we have a row. Then we have our for loop. And in each iteration, we render a column. So let's also indent this line to go inside the for loop. That's better. Now finally, we close our for loop. And after that, we close our row. With this change, if we go back to the browser and refresh, we get something like this. We're basically repeating all that static or fixed markup from Bootstrap over here. So we're not rendering the actual name or the image of each product. But that is a very easy fix. So back to our markup, let's expand this column. So here's our card. Inside this card, we have an image on line 9. Look at the source attribute of this image. We need to change this and dynamically render the image URL attribute of each product. So let's delete this. And inside the quotes, we add double curly braces to render some value. We want to render product dot image underline URL like this. Now over here on line 11, we have this text card title. We want to replace this with the name of each product. So delete double curly braces and we add product dot name. Next, we need to replace this text with the price of each product. So delete. Here we have a paragraph tag. Inside this tag, we add double curly braces to render product.price. And just before these braces, we want to add a $sign. And the last change is the label for this button. It's called Go Somewhere. We want to change that to Add to Cart. Now back to this page, refresh. We should get something like this. Beautiful. In this tutorial, I'm going to show you a couple of techniques for improving the look and feel of this page. First, we're going to add a navigation bar on the top, and then we're going to add some padding around these elements. Currently, this product card is way too close to the left side of the screen. So we should add some padding to let this page breathe. Now, to add a navigation bar, once again, we go to the Bootstrap website. Look at the documentation for the navbar component. So here's the navbar. Now, if you scroll down, you can see a typical navbar. So we can have these links. We could have a drop down. We could have a search bar. Now, this looks a little bit clunky because I've resized the screen, so it doesn't look pretty. But below that, you can see another simple navigation bar with only the brand or the name of the application. So over here, we have the markup to render this navigation bar. So let's go ahead and copy this. Now back to Pycharm. Where should we add this markup? We should add it to base.html because this is supposed to be a base template for all pages in our application. So here's the opening body tag. Right below this body tag, we want to paste the markup for rendering a navigation bar. Now the code is not formatted properly. It looks clunky. So once again, go to the code menu and then reformat code. As you can see, the shortcut for Mac is Alt, Command, and L. So I'm going to use a shortcut here. There you go. That is better. So here's our navigation bar. Now let's change this text from navbar to PyShop. That's the name of our application, right? Now back to the browser. Let's refresh this page. We have this navigation bar on the top. Let's go back to Pycharm and make a slight change in the structure of our application. So here in the products app, we created the templates folder. And in this folder, currently we have two templates, the base template for our application and the template for the products page. The problem with this structure is that this base HTML is not reusable because we have added it inside the templates of the products app. What if in the future we want to add another app to this project? We don't want to recreate this base.html in every app. That just doesn't make sense. So we want to reuse this across multiple apps. And that's why we need to move this outside of this folder and put it somewhere central. So in the root of our project, here we need to add a new folder called templates. So right click the project and add a new directory called templates. Now we want to go back to the products app. Inside the templates folder, we drag this base.html file and drop it into the main templates folder. Okay, good. Now our base template is somewhere central, so we can reuse it in multiple apps. However, if we go back to the browser and refresh this page, we get this error, template does not exist. If you scroll down, you can see why we get this error. So over here, you can see this red line. Let me zoom in. This error happened because Django couldn't load base.html. Now, if you scroll up, you can see the paths that Django searches for to find this template. Here's the first path, admin/templates/base.html. So Django is looking for this template inside the admin app. Here's the second path, auth/templates/base.html. So Django couldn't find it in the admin app. It thinks maybe it's in the auth app. And finally, here's the last path, products/templates/base.html. That is our products app. So what is going on here? Django is looking for this template only inside of the installed apps. But this templates folder that we created, it's not really part of any apps. It's just a standalone folder. So we need to tell Django to look inside this folder in addition to the installed apps. And that is very easy. So in the main package, PyShop, you have seen the settings file before. Let's have another look here. If you scroll up, you can see this variable, base directory. This variable is set to the complete path of where you have stored this Django project on your disk. We're going to take this directory and append templates to it. So scroll down. On line 55, you can see the configuration for loading templates. Look at the settings we have here. The first setting is backend, and this is the engine that is used to parse our templates. So all those template tags, as well as the double curly braces, this is the engine that knows how to interpret those. Look at the second setting, directories. This is set to an empty list. So here we need to reference the templates folder in this project. So let's type out os.path. So we're using the path object defined in the OS or operating system module that is imported on the top. Now this path object has a method called join. And with this, we can join multiple parts of a path. The first part is base_dir, which is the variable that I showed you earlier. It's set to the complete path of your Django project. Now we want to take this and append templates to it. That's all we had to do. So back to the browser. Let's refresh the page. There you go. The problem is fixed. So now our base template is somewhere central and we can reuse it across multiple apps. Beautiful. And one last change. Currently, as you see, these items are so close to the left side of the screen. So I'm going to add some padding to make this page breathe. And that is very easy. Back to Pycharm. Here in our base template, where we define this content block, we need to wrap this with a div with the class container. This is one of the classes defined in Bootstrap that we use to define a container area in our application. This container area has some padding. So type out div.container and press tab. Okay, and then move these template tags inside of this div. That's it. Now back to the browser. Let's refresh. So this is our container area. As you can see, we have some padding to the left and right side of this container area. Beautiful. So that brings us to the end of this Django tutorial in this Python course. I hope you learned a lot and thank you for watching.
So that was a short and sweet introduction to Django. But Django really requires its own course, and I'm planning to create a comprehensive course on the topic in the near future. Now here's a question for you. What kind of applications do you want to build with Django? Use the comment box below and let me know. I will take your ideas into consideration as part of creating my upcoming Django course. So that brings us to the end of this course. I hope you learned a lot. Please support my hard work by liking this video and sharing it with others. And also subscribe to my channel for more tutorials like this. Thank you so much for watching, and I hope to see you again soon.